Welcome to Experts Live Austria. Thanks for joining in. There are already a lot of people watching us, so we are very excited that we can do this show. Normally, you would come by train, plane, or car. You might have familiarized yourself with the conference on arrival, tuned in to the conference, go to the lobby. This time, Experts Live is an online-only conference, and you probably went to the kitchen to get something to drink, and a few steps later you were here at our conference. I pretend most of you are sitting at your home office and watching our talks. But I think that you all want to network, meet your peers, tech staff, and so I can announce now that we will do an in-person event as soon as possible. Of course, you can communicate in our lobby, but we think we should do an in-person event as soon as possible. Maybe we can do this summer in 2021. And we also have already a lot of ideas for the next time. What we will do. So we will do an in-person event, as I already told you. We do our quarterly Expert Lives cafes, as we've done till now, with Azure Stack content, with Azure content, with PowerShell content, and so on. We do our PowerShell trainings, which are free and for newbies, I would say. And absolutely new, also an announcement, we will do this year quarterly Azure events starting with the 11th of March 2020. And we have some more things and ideas in our pipeline. So how can you stay up to date? You can stay up to date at our website, expertslive.at. You can get our newsletter at this website. You can join our newsletter. So we only will inform you about upcoming events in this newsletter. There's no ads or such things. You will get one mail per quarter. You can stay informed with LinkedIn. We have a LinkedIn channel. You can search for Experts Live Austria. So we'll see. You can make up on this channel. And yeah, we will also provide all our PowerPoint, so you will have the link to our LinkedIn channel, and you can use the meetup if you like. So we are using social media really broadly. So how can you join us? If you want to help us organizing such things, you can join us. And you can join us as an attendee, as you are doing right now. And you can join us to discuss tech things. And you can join us as associated member, as Vereinsmitglied, it's called in Germany and in German. And this means you can support us organizing events. You can support us with your passion to do things you like. You can also join us as a speaker. We are always searching for speakers. We also take beginners if you want to speak and it's your first time. Maybe Experts Live Cafe is a good place to start and to expert for such conferences as today. You can also join us as a sponsor. We have evening events, we have one-day events, and we have supporting members, so supporting us over the year. If you want to do this, let's contact us at info@expertslive.at. So, and I really want to thank our sponsors because they make it possible that we can volunteer for organizing such events. First, ACP. They have a product, they have really a lot of product diversification. So you can join each of the platinum sponsors. They are in the first row. They all have an own channel. You can see this at Experts Live AT, their channels, and talk to them what they're doing. The next one is Thomas Krenn, and the last one is the security company Fortinet, and they all have their own sessions. They promised me to give a technical session, so you can join them. You can learn technical things from them, and if not, let me know. And the other sponsors, they also support us. The PowerShell User Group Austria, for example, they are doing the technical PowerShell trainings. SmartPoint doing some SharePoint stuff. TechActive, they are also help organizing the event. And NICE, the security, solution to for operating. So CloudGuard and SecureGuard are also help us organizing these events. So we have a lot of sponsors, and I really love that, and we want to thank them that they are supporting us. So I also want to thank our team. We have 9 persons in our team helping us. Thank you for that. They are very passionate, and I hope we will have lots of other funny events or fun events this year. So where are you from? I only know where are the registered persons from, and the most are from Austria. Okay, it's like Experts Live Austria. But we also have some from Germany. We have some from Swiss. We have the Netherlands. We have Belgium. We have also India, and we have Great Britain. Oh, sorry, this is a German word, but we have Great Britain also. We are really excited that so many nations are watching our stream or will watch our stream. Our stream, this event, we have 3 tracks, and we have 3 URLs for these tracks. All are on Experts Live AT. You can always go there and have a look where the tracks are. If the track doesn't work anymore, anything, go at Experts Live AT. We will have the information there. So you see, we have 3 tracks: the hybrid track, the Azure track, and the modern workplace track. As I said, they are also on the Experts Live AT website, so you can do a screenshot for secure if you want to be very secure, but they are all on the Experts Live AT. And we have a lobby. You can go there. There is one person waiting. You can talk to this person. You can ask questions, and this lobby will also work as a break room. So you can make break, you can discuss with the others and such things what you are doing in the lobby for in a on-prem event. I also told you we have 3 platinum sponsors. We have 3 URLs for their sponsors. Go there, talk to them, ask them what they are doing. We live from our sponsors, so go there and talk to them, because all 3 sponsors are really good sponsors. They have good products, so go there. And last but not least, I want to thank our speakers. I want to go through all the speakers. The first one is Cosmos Darwin, our keynote speaker. We will hear him in a few minutes. And he is for product manager at Microsoft. And we are very proud that we have two persons from Microsoft product groups directly speaking and answering questions for us. The second one will speak in the evening. This is Sydney Smith from the PowerShell team. She also has very inspirative talks. Martin Hood is the founder of Experts Live and Microsoft MVP, and will also talk at our conference about Azure Sentinel. And so one of our local heroes is Hannes Lagler-Gruener. He is a multi-cloud solution architect and will speak at the Azure Stack Family. Simon Binder, also Microsoft MVP. So you see we have a lot of MVPs in these talks. He will speak about Microsoft 365. Microsoft 365 is in the modern workplace track, and we can thank Michael Freistetter for this track because he organized this track. Helmut Otto, the owner of the Azure Stack track or hybrid track, and he is managing director of SecureGuard and also organizer of Experts Live Austria. Bernie Jaspers and Tim Herney do their track in the Post-to-One track and the Modern Workplace track. We also have a SQL session for this time. It is Alexander Arvidsson does some Azure SQL Server for the on-premise DBA. Since I'm also a SQL fan, I'm very looking forward for this session. The good, the bad, and the fantastic Carsten Rachfahl from Germany. Eric Berg also speaks about Azure Policy and Azure DevOps, also an MVP. Our Power BI guru Wolfgang Strasser, MVP. Didier with Virtual WAN, also an MVP. At 4 o'clock, Michael Flüfli knows what to do. Fredrik Nielsen also speaking about the cloud. Our second woman speaking, Henny Ilmarin. Marcel Zehner from the Experts Live Europe also speaking with 10 tips how to boost the cloud career. And another local hero organizing the Experts Live Austria conference is Stefan with IoT. And from the PowerShell user group, Bartek Moczulski, talking about PowerShell 5 versus PowerShell 7. These were our speakers. I want to say some words to our Microsoft Live event. So when you hear me, you hear what I said about 20 seconds before. So we have a 20 seconds delay. In the lowest case, you can rehear some things in with the function of live events. We have an interaction with the speaker via the Q&A section. The Q&A section is watched by a supervisor, and he will watch this and approve your interaction, so the speaker can answer your questions. And the session will be recorded and published in the internet, so will your questions, of course. And this means if you ask a question, you are willing in that you or you're agreeing to that we can make it public. you have also the opportunity to ask your questions anonymously. So the event is recorded, information via newsletter. The latest information you can get on our website, Experts Live AT. If you want to give feedback, you can give feedback at Experts Live AT. And last but not least, I again want to thank our sponsors because they made this event possible. Thanks for joining in. Thank you so much. I will hand over to our first introduction to the keynote. This will be announced by Helmut Otto. Thank you for joining us.
Okay, thank you, Patrick. Yeah. We still have some time left because the keynote will start at 9 o'clock. So at the moment, we just wait that all the speakers arrive, especially that Cosmos came in for the keynote. We are very, very happy that Cosmos has the possibility to speak here. Then there will be most of the questions answered by him will be afterwards on mail, because at the moment he is on the East Coast, US, and as you perhaps have noticed, there's some problems there. Yeah, I think the only thing we can do at the moment is just wait for the event to start. We will start in 13 minutes. Yeah, hello everybody. So again, want to welcome everybody to our first online Experts Live event here in Austria. And I'm really, really proud and happy to present our keynote speaker, Cosmos Darwin, product manager for Azure Edge and platform at Microsoft. One of the guys who is on first hand with Azure Stack HCI. And yeah, so I hand over to Cosmos. Cosmos, please start.
Hello, everyone, and welcome to the first session of this event. Before we get started, I do want to just say thank you to Helmut and to the organizers for the opportunity to speak here. It's exciting to be at Experts Live Austria. I also want to thank, of course, the sponsors for making this event possible, and most of all, I want to thank you, the audience members, for taking the time and taking the interest in these technologies and for being here today to listen to this session. So with that out of the way, let's jump into it. My name is Cosmos Darwin. I'm a program manager on the Azure Edge and platform team at Microsoft. I'll be delivering this first talk this morning. And the subject of today's talk is about how you can innovate anywhere with Azure. And in particular, as part of that, I'm going to be focusing on what's new for a product called Azure Stack HCI. So we have a lot of ground to cover, so I'm not going to spend any more time on this slide. I'm just going to get into it. All right, so here's the agenda for the talk today. First of all, I'm going to give a little bit of background about hyper-converged infrastructure, about what's going on in the market and why this trend is happening. Then I'm going to talk a little bit about Microsoft's strategy, and this is important because it helps to explain. You might be wondering, why is this Azure guy here talking about hyper-converged infrastructure if hyper-converged is on-prem and Azure is cloud? And so I'll try to clear that up a little bit and explain why it is that it makes sense to think about Azure when you think about hyper-converged infrastructure. And then I'll get into some specifics about the Azure Stack HCI product. So I'll give an overview of what it is and what it does. I'll cover some of the new features that are in the core infrastructure software stack. I'll talk about the changes in the last year related to transforming Azure Stack HCI into an Azure hybrid service. And I'll also touch on a few of the things that are not changing, some of the ways in which we are deliberately keeping this product familiar for you. So that's the agenda for this session. Hopefully that sounds good to you. Let's get into it. We'll start with talking a little bit about the background of hyper-converged infrastructure. Now, I suspect many of you in the audience, because you are very familiar with these server technologies, you probably have heard of hyperconverged infrastructure before. Simply put, hyperconverged infrastructure is the new wave of consolidation, sort of the next step in the journey of virtualization. And so if you compare a traditional three-tier architecture, which is what you see over here on the left side, with a hyperconverged infrastructure on the right side, you can see that just as we did in the virtualization wave, HCI helps you to consolidate and run a more efficient infrastructure using a smaller physical footprint. In a traditional architecture, you would normally, if you start from the bottom here, you would have your storage, either your SAN or NAS array, which is a dedicated set of storage hardware. Connecting that storage into your hypervisors, you would have a storage fabric of some sort. This could be fiber channel as a very common example. And then you would have your hypervisor hosts. Those could be running VMware or Hyper-V or some other hypervisor. That's actually, the servers that are running your applications, that are providing your compute. And then connected to those hypervisors and typically sitting between them and the rest of the internet, you would have some set of network appliances providing functions like load balancing or potentially a firewall or a gateway. And ultimately connecting those network appliances to your hypervisors and connecting all of this together, you would have a set of Ethernet switches. And this is sort of the three-tier infrastructure that was basically universal if you looked around maybe 5 or 10 years ago. With hyperconverged infrastructure, this gets consolidated into a much smaller footprint of industry standard x86 servers, which bring their own storage and bring their own networking. And so these servers are packed with additional high-speed storage devices, additional SSDs and storage drives, as well as additional high-speed networking components, network interface cards over and above those that are needed for the compute, so that the software-defined storage and software-defined networking can exist between these same servers. So instead of a dedicated SAN or NAS, with hyperconverged infrastructure, you have software-defined storage, meaning the virtualized data volumes are actually created from local drives in each of the hypervisor hosts. And you have a software-defined networking fulfilling many of the same functions that a traditional network appliance might have done, such as load balancing or creating a firewall at the perimeter of your infrastructure. All of that done in software that is essentially built into the hypervisor. So that's the general idea of HCI in just a minute or two. And I imagine many of you are familiar, so I'm not going to spend any more time going over these basics. What I do think it's important to say is hyperconverged infrastructure is really, really popular. In fact, a recent survey of organizations with a data center modernization strategy found that more than half of them expected that deploying hyperconverged or converged infrastructure would be among their most significant modernization investments over the coming couple of years. And that's not just a hollow aspiration. It's not just something that these organizations hope that they'll be able to do. It's actually already happening. If you look at the investment data that is collected by the analyst firm IDC, you can clearly see that the spending organizations are putting into hyperconverged infrastructure is increasing significantly quarter over quarter, year over year. And this has been true for many years now, and it continues to be true this year. The takeaway here is that HCI is quickly becoming the new normal way to deploy servers. It is essentially what most organizations are turning to for most of their on-premises virtualization scenarios. At first, HCI was limited to certain use cases. There were scenarios like virtual desktop infrastructure, for example, was a very popular one. But more and more as the years go on, HCI is becoming the normal way to deploy new servers. And that, I think, is a very important background for understanding the product that we're going to talk about today, which is Azure Stack HCI. Okay, now that leads us to this next question, which is, that's all well and good, great, HCI is happening, HCI is popular, cool. How is this related to Microsoft Azure? Right, Microsoft Azure, I'm sure all of you are familiar with it. It's a hyperscale cloud, first and foremost. And so what does this have to do with HCI? Our strategy with Microsoft Azure, and this is really something that we take very seriously at Microsoft, is to become the trusted hybrid cloud provider of choice for customers. And I say hybrid, that's the key word here. It's not just about hosting customers' workloads for them in our public cloud. Of course, that's it's very important. We're very excited about that. We're very proud of Azure. It's also about bringing Azure technologies to meet customers where they are and really deliver a complete hybrid solution that includes both a public cloud as well as the ability to run Azure technologies on your servers, on your premises, on your terms in the way that makes sense for you. We call this innovating anywhere with Azure. And whether that's a scenario that is at the edge in a branch office or a retail store, or a new scenario with a new application, or whether it's modernizing your existing data center with the existing workloads and applications that you run today on older traditional infrastructure, and whether that's connected to Azure directly, or in some cases a disconnected scenario, we are committed at Microsoft to building technologies that help you to innovate and to modernize across all of these scenarios, and to delivering you a consistent set of tools and a consistent set of experiences under the Azure brand that serve you well in the way that makes the most sense for you across all of these scenarios. And that's really why, even though I work on the Azure team at Microsoft, I'm here today to talk about on-premises hyper-converged infrastructure. And in particular, I'm here to talk about Azure Stack HCI. So let's get into it. What's that? What is Azure Stack HCI? Azure Stack HCI is the newest member of the Azure Stack product portfolio from Microsoft. If you've been following Microsoft over the years, you might be familiar with the product we now call Azure Stack Hub. That was the first product in the Azure Stack family. But we've grown from just offering Azure Stack Hub to now offering a whole portfolio of edge infrastructure products. This includes Azure Stack Edge, Azure Stack Hub, and the newest member of the family, which is Azure Stack HCI. And of course, that's what we're going to talk about now. All of these edge infrastructure products have some commonalities. They also have some differences. They're geared toward different scenarios. Our goal is to make sure that no matter what the infrastructure is that you're trying to modernize, we have a product in the Azure Stack family that can help you to achieve your goals. Now, Azure Stack HCI in specific is what we're going to talk about today. And the Azure Stack HCI that we'll cover was actually announced pretty recently. It was announced just last year in 2020 by Microsoft CEO Satya Nadella. He introduced it at the Microsoft Inspire event in July of 2020. And as part of the introduction, I think he summarized really well what it is. It's Azure Stack HCI that delivers hyper-converged infrastructure software, but as a native Azure service, meaning you get an easy way to manage your clusters and your VMs from the Azure portal, and then seamlessly move between local tools and cloud management, depending on what makes sense. And I think that's actually a pretty good summary, and we'll unpack that and talk about the details. But this was Satya introducing Azure Stack HCI just a few months ago. And so I'm essentially going to be expanding on this announcement that he made. If we take a big step back and look at where Azure Stack HCI fits into the landscape of Microsoft's hybrid stack, I think this will help to situate many of the things that we'll talk about. This slide is a little bit busy, there's a lot here, but this is really how we view the role of Azure Stack HCI in the hybrid future that we are building with Microsoft Azure. Azure Stack HCI is fundamentally the layer that connects our ecosystem of server hardware. If you start from the bottom, right, you have a whole variety of solutions from different vendors, many of whom are sponsors of this event here today. Those hardware servers are ultimately things that you're using to run applications, right? And applications are at the very top of this picture, whether those are modern applications, whether they're Linux applications or Windows applications, or whatever the scenario is that you actually need to run. Ultimately, if you procure new server hardware, you're doing it because you need to run apps. And the role of Azure Stack HCI is to run on that hardware and provide you with the ability to run virtual machines of any size or any configuration that will fit, and to run the Azure Kubernetes service, which allows you to run containers. And so with virtual machines that are Linux and Windows, and then containers that are Linux and Windows, and inside of those containers you can run any number of Azure services, including data services on your premises or cognitive services on your premises. The role of Azure Stack HCI is to make all of that possible, to take the ecosystem of server hardware that is compatible with Azure Stack HCI and allow you to run VMs and containers on top of that infrastructure. All of this can be managed through local tools, as you can see over on the left-hand side, as well as through Azure Arc, which you'll see over on the right-hand side. And we'll talk a little bit more about each of these things. But I find it helps to just take a big step back and sort of situate the position of Azure Stack HCI within this broader landscape of the Azure hybrid stack, because there's so much news every day from Microsoft Azure, and it's important to kind of keep an eye on the big picture. So hopefully this helps to clarify the role of Azure Stack HCI within the portfolio. So let's get into the specifics. What really is Azure Stack HCI? And you can probably guess based on some of the things on the previous slide. First and foremost, Azure Stack HCI is a new operating system from Microsoft. It is the latest commercially available version of the Azure hypervisor that we run in our own data centers from Microsoft Azure. It's that latest hypervisor with built-in software-defined storage and software-defined networking. And this operating system is actually optimized for virtualization specifically. And so it has some commonality with what you might know from Windows Server, but it's actually been reduced down to focus very specifically on the virtualization and specifically the hyper-converged infrastructure scenarios, which means a lot of the roles and features that you don't need in that scenario are removed. Certain things are optimized in a way that we can't do with general-purpose Windows Server. And you'll see when you install the product, it actually has a very distinct look and feel. And so from the moment that you turn it on, there's no mistaking that this is very clearly the Azure HCI operating system. It's not Windows Server. And that's the first and foremost thing that this new product really is. And to be clear, it runs on your servers on your premises, right? So this is a bare metal operating system that you install on your servers that you control and you manage on your premises. This is not something that is hosted by Microsoft. This is not something that you have to connect to over the internet just to get access to it. This is an operating system that you install on your servers. So that's familiar, but it's also got some pretty big differences. The most important one is that this operating system is actually delivered as an Azure hybrid service. So let me explain what that means. First of all, there's no traditional software license that you need to actually buy and track to use Azure Stack HCI. And so if you're familiar with how you have to license Windows Server and you have to keep track of how many of the licenses you've purchased and whether you're correctly licensed for how many servers you're running, none of that exists with Azure Stack HCI. Instead, as soon as you start running the Azure Stack HCI operating system, it automatically bills itself to your Azure subscription as just another line item on your Azure bill. And so if you're an existing Azure customer, and 95% of the Fortune 500 are existing Azure customers, then it's very convenient to start using this OS because all of the billing is taken care of using the account that you already have with Azure. In addition, there's actually no standalone legal agreement as part of this operating system. And so if you make a comparison again to Windows Server, with Windows, there's an end-user license agreement, a EULA, and when you have to install it, you have to go through and you have to accept the EULA, and there's a lot of language you have to read. None of that exists with Azure Stack HCI. When you start using the operating system, it is automatically covered under the Azure Online Services terms that you agreed to as part of having an Azure subscription in the first place. So it's very easy from a compliance perspective to get, your organization to agree to use this product because you already have, if you're an Azure customer, you already have a billing relationship that allows you to pay for this, and you already have actually agreed to using it, even if you aren't using it today. There's also no separate support contract that you need for Azure Stack HCI. So again, if you're an Azure customer, you're probably familiar with the fact that you can get support for any of the Azure services that you use directly from the Azure portal. You just, on the page for that service, you go to new support request, and you can, get help right there in the portal. And that's true for Azure Stack HCI as well. The moment you have an Azure Stack HCI, you can receive support directly through Azure as part of your existing support agreement with Azure. So you don't need a separate one just to use Azure Stack HCI. And another pretty significant difference is because it's a service, because it's an always up-to-date subscription service, there's no versions that you have to worry about upgrading from one to the other, and oh, did I buy the new version? Is it worth buying the new version? All of that goes away. You simply subscribe to using this Azure Stack HCI OS delivered as an Azure service, and you'll get continuous feature updates over time, so you always have the latest features that your hardware is capable of supporting. And so there's, again, it's in some ways it's familiar. It's clearly an OS that you install on your servers, but there's also some very clear differences here too, because it's delivered as an Azure service. So that is an overview of Azure Stack HCI. If you have no idea what it was, hopefully now you have some idea of what you can use Azure Stack HCI for. And now I want to talk a little bit more about some of the things that are specifically new. So let's get into what's new for the Azure Stack HCI product. I think it's helpful to do this sort of in three areas. And so I want to talk first and foremost about things that are new features in the core hyperconverged infrastructure software stack. That's what we'll cover first. Then I want to talk a little bit more about this whole delivered as an Azure hybrid service thing, because that's complicated and new and different, and actually it's pretty exciting. There's some really cool technology here. And then third, last and certainly not least, I do want to talk a little bit about how we're making sure that Azure Stack HCI remains familiar for you in IT to manage and operate, because that's super important and it's core to our mission with Azure Stack HCI. So let's go through each of these sections then in order, and we can start with the hyper-converged infrastructure software stack. All right, let's get into it. What is actually new? So I talked about the new OS, of course, right? And you can see from the moment you install it, it looks and feels very different. It's a different composition. It's a different build. So it's a custom OS. But it's not just reduced. It's not just that certain things have been removed. It actually has a lot of things that are new and that have been added. The first one is the ability to do native disaster recovery through stretch clustering with Azure Stack HCI. I know this is especially important, I'm sure, for many of you in the audience. This is frequently a requirement from European customers because you need to have a cluster that is stretched between 2 fire zones, and I understand that requirement. And so the great news is that with the new Azure Stack HCI service, this is a natively built-in capability. You can take an Azure Stack HCI cluster, you can span it across 2 locations, whether that's 2 rooms in the same building, or 2 completely different buildings, or even 2 completely different cities. And built into the software-defined storage stack, you can use synchronous, near synchronous, or asynchronous storage replication to replicate all of your data from one location over to the other location, optionally encrypting it if you like, so that if there's a disaster and one of the sites goes down, all of the virtual machines from one site will seamlessly fail over to the other site. That's automatic. There's no administrator action required to initiate a failover. And when the VMs arrive at the other site, they'll find a complete replica of their storage. So this is a really frequently requested scenario. This is something that was never possible before using the on-premises products that Microsoft made for hyper-converged infrastructure. And so this is a huge new scenario that we're really excited about with the new Azure Stack HCI. But there's more. Something else that's new is we've created a guided deployment workflow that's designed to make Azure Stack HCI easy to set up. This is really important to us. This is important to me in particular, because hyper-converged infrastructure is so broadly applicable, whether it's in the core data center or in the branch office, whether it's a large enterprise or a small or medium business. And it's important that all of those different participants be able to actually set up this technology. And so to make it easy to set up Azure Stack HCI, we've created a guided workflow that's it's delivered as an extension to the Windows Admin Center product, if you're familiar with that. It's completely free of charge. There's no separate fee that you need for this. It's included. And this guided workflow steps you through everything you need to do to get Azure Stack HCI up and running, including configuring clustering, configuring virtualization, and configuring all of the advanced software-defined storage and networking that you need. And so if you sit down in front of this wizard and you click sort of next, 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 you will have your Azure Stack HCI set up, which makes it really more approachable, especially for IT generalists or folks who may not be familiar with hyper-converged infrastructure, and especially for smaller customers and small to medium businesses. So this is something else that's new and something that we're very excited about. Those are 2 examples of completely new things, right? Stretch clustering is something that was never possible before, and now it's possible. A guided workflow to deploy HCI was never a thing before, and now it exists. And so those are kind of big and obvious examples of what's new, but there's a lot of smaller, more subtle things that are also new and improved, because our team is constantly working to take the innovations that we build, and typically that we build in the context actually of the Azure servers that we are responsible for operating, and bringing those innovations into this Azure Stack HCI operating system. A great example of that is a significant change that we've made to how storage resynchronizes and repairs as part of Storage Spaces Direct. So Storage Spaces Direct is the technology inside of Azure Stack HCI that provides software-defined storage. If you've used any kind of HCI before, whether it's from us or from another vendor, then you know that after a server goes down and then comes back up, there's a resynchronization period where the storage has to get updated on the node that was temporarily down. That can take a long time, actually. And one of the big pieces of feedback we've heard is improving that would actually make a big difference to how easy and reliable this product is for customers to use. And so you can see on the slide here a summary of how significantly faster the new Azure Stack HCI is compared to anything that we've had before. In fact, in the average case, the 50th percentile case, resynchronization and repair with Azure Stack HCI is actually about 4 times faster than the latest version of Windows Server that's available, which is Windows Server 2019. And in the worst case, in the 99th percentile case, it's actually almost 5 times faster than Windows Server 2019. So this is maybe not very sexy, as they say, but it makes a huge difference when you're actually using the product. And these are the kinds of little things that the team is constantly working on. And this is just one example that I think it really stands out of something that's new and different and better in the new Azure Stack HCI. One more that I want to tell you about is what we call integrated full stack updates. Now, this is really important for customers who are procuring a solution from an OEM partner and then who want to have a unified experience for updating not just the software from Microsoft, but also all of the firmware and drivers and all of the other things that need to be updated to keep the whole solution up to date. And previously, this required you to use multiple tools. So you would have to use a tool from Microsoft to update the Microsoft software, and then you would have to use a tool from the OEM partner, from the person who actually sold you the hardware solution, to update any of the firmware or drivers or the BIOS or any of the components from them. And you'd have to use 2 different tools. Coming soon for Azure Stack HCI, select partners have built integrations, what we call snap-in extensions, into the Windows Admin Center, so that as part of the same updating run, you can update not only the software from Microsoft, but also everything from the partner in one workflow, one unified experience in one tool. So what you see on the screen here is an early screenshot of the snap-in extension that is being developed by Dell EMC. We've also announced that other partners, including Lenovo and DataOn and a few others are coming soon, are building these extensions so that you get full stack updates integrated right into the console for managing Azure Stack HCI. So that's just a set of examples. I think that was 4 different examples of things that are new in the core software-defined infrastructure stack of Azure Stack HCI that are part of this new operating system and the management and services that surround it to really make hyper-converged infrastructure that's enterprise-grade and that's easy and approachable for everyone to use, not just to deploy, but also to update and really manage day-to-day. Okay, so that's what's new for the HCI stack. What's really new here, the biggest difference, right, is this whole delivered as an Azure hybrid service thing. So let's get into that. Let's talk a little bit more about what that specifically means. When you deploy Azure Stack HCI, the new OS that we've been talking about, it natively integrates with the Microsoft Azure cloud. What I mean by that is that you get an Azure Resource Manager, an ARM resource, that represents every on-premises Azure Stack HCI cluster that you have, so that you can see those clusters directly in the Azure portal. This provides the foundation for hybrid management. It enables a number of scenarios, which I'll describe in just a moment. And what's really important is there's no agents or scripts or anything complicated that you need to fuss with. This is built natively into the operating system to make it easier. One of the things we hear often is that hybrid is actually kind of hard. Organizations sometimes have skills in the cloud, but they don't have skills with on-premises servers. Other organizations have the reverse problem. They have a lot of experience with servers and virtualization, but they're not really familiar with the cloud. It's kind of new for them. And learning how to operate an infrastructure that actually kind of spans both on-premises and the cloud is really challenging. So our whole goal with Azure Stack HCI is to make that easier, and this native integration is really the first step. And in fact, I can show it to you. It's sort of pretty easy to see. So here's a quick demo of Azure Stack HCI in the Azure portal, which is pretty crazy if you haven't seen this before. To show you in my browser, I'm just going to go to portal.azure.com. This is the normal Azure portal on the public internet. Very easy. I don't need any particular line of sight here to anything. And what you'll see that's new and different is right here in the Azure portal, I can see my Azure Stack HCI clusters that are running on my premises. Here they are in Azure. I have 2 of them here, Contoso HCI and Cluster 2. And I can select one of these clusters and actually get a set of custom screens in the Azure portal where I can see information about this hyperconverged cluster. For example, here I can see that there are 2 nodes, node 1 and node 2, and I can see some basic information like the OS build that they're running, how many cores and how much memory they have, things like that, directly from the Azure portal, meaning I can get it anywhere. I can even get it on my mobile device. I can get it when I'm on the go. The Azure portal is really, really easy to reach and really accessible, and it's always there, right? Because it's hosted in the cloud. Now, because Azure Stack HCI participates in this Azure Resource Manager model, it benefits from all of the standard constructs of the Azure Resource Manager, which means I can categorize my clusters with tags. I can organize them into resource groups. I can see all of my Azure Stack HCI clusters in a single global view. And I can even leverage Azure's Identity Access Management framework to determine which other users within my Azure AAD have what privileges on my Azure Stack HCI clusters. And I'll give an example of a scenario in a minute that is going to take advantage of that capability. Now, Azure customers love Azure support. We know this, and I alluded to this a little bit earlier. And so one of the things that we also get with Azure Stack HCI participating in Azure and being a part of the Azure Resource Manager is that it is now covered under Azure support. In fact, we've created a new dedicated team of engineers who are specifically trained to support Azure Stack HCI. It's no longer part of the generic Windows commercial support. And you can access this team of dedicated support experts for HCI and self-help resources, if you need them, directly from the Azure portal, just like you would for any other Azure service. And all of it is covered under any of the Azure support plans, including the one that starts at just $29 a month for developers, or I think it's $100 a month for what we call standard support. And so you can learn more about this by going to azure.com/support. But the key thing here is that as a customer of Azure, if you already know and use Azure support, then that extends to cover Azure Stack HCI as well. You don't need a separate contract for it. And we have a dedicated team standing by to help you. We also have transformed the way that you pay for Azure Stack HCI so that it is charged as a subscription service as part of Azure. And again, I alluded to this a little bit earlier, but just to give a few additional details here, it is not consumption-based. And so if you're familiar with services where your price changes, from 1 minute to the next based on what you're doing and how much you're using, it's not like that. Azure Stack HCI is billed as a predictable monthly fee that covers both the cloud services portion of the product as well as the on-premises software. And so it's all charged to your Azure subscription, and it's a very simple cost structure that just depends on how many physical processor cores you have. And so you can easily say how many cores are in the hardware, how much is this going to cost per month and per year, and then because this is a subscription service, it covers continuous feature updates. You're always up to date. You'll always get the latest features and capabilities, and it's all just billed to your Azure subscription. So just like you can see your bill for any other service in the Azure portal, you can see all of this in the Azure portal as well. And you can learn more by going to azure.com/pricing. One thing that's important to note is that just like it's the case on every other HCI product in the market, guest operating systems and guest applications are sold separately, right? So if you want to use Azure Stack HCI to run certain operating systems on top, whether that's Windows or Linux, and then if you want to run certain applications, whether those are things like SQL Server, which come from Microsoft, or they're applications from a third party, all of the operating systems and applications on top are sold separately. They're not part of the base HCI product. And that's the same as it would be with any competing solution. So just want to make that clear. All of these things together, the management through the Azure Resource Manager, the billing through Azure, the support through Azure, they're all part of a broader effort on our part to really transform Azure Stack HCI toward something that is hybrid first and toward being an Azure service itself. And so there are a set of capabilities that have been possible for some time, hybrid capabilities like hybrid networking, backup and recovery. Those are things that are available. They were announced in 2018 and 2019. But what's new here now, since last year, is that Azure Stack HCI itself is transforming toward being an Azure service in all of these ways that I've described. And this really is just the beginning. There are so many things that we can do now that Azure Stack HCI is a service, and a number of them I think are pretty exciting and pretty cool. So I do want to spend a little bit of time telling you about a few things here that are in development. What I'm going to describe next is not available right now. It's things that are going to come over the course of the next couple of months, next 1 year maximum. But I do want to just describe to you some of what these capabilities are, because they help to explain, I think, why we are so excited about turning this product into a hybrid service. The first is something that we get asked for all the time. This is one of the most requested things from customers who use both Azure Stack HCI and who use other products from Microsoft today, like Windows Server. And that is the ability to see all of your Azure Stack HCI deployments, no matter where they're located in the world, in a single central place with real-time health information, real-time performance metrics. And this is a capability that is possible now because of how Azure Stack HCI integrates into Azure. And so we're going to make, actually we're working right now on making a lot of these things default so that there's nothing you even need to set up. When you connect to the Azure portal, you'll be able to see this real-time health and performance information about every single one of your clusters all in the same place. And because it's completely managed, right, it's leveraging the Azure Monitor service, which is operated by Microsoft. This scales to tens, to hundreds, even to thousands of locations. And you, as the customer, don't have to worry about maintaining the infrastructure for monitoring. You don't have to deploy a bunch of servers just to monitor your other servers. And so this is, we think, going to be really, really convenient, and it's something that customers have asked us for many, many times. So we're very excited about this. One of the things that actually makes this possible is what you may have heard of called Azure Arc. Azure Arc is sort of an umbrella term that we use at Microsoft to refer to bringing Azure's management capabilities to any infrastructure and bringing Azure services to any infrastructure. And I want to give you sort of an example of what's possible with Azure Arc, because it's the foundation of what lets us do the fleet scale monitoring that I just described. So I'm going to show a demo here. This is real. This is not something like fake or mocked up. This is a genuine demo of technology that our team is just finishing putting the final touches on, and it's going to be coming later this year to everybody who subscribes to Azure Stack HCI. And this is Azure Arc being built in to Azure Stack HCI. So let me show you how this makes it easy to set up things like monitoring at scale. To start here, I have an empty resource group in the Azure portal. And you can see here, if I refresh, that there are no resources to display in this group, so it's an empty group. Meanwhile, on premises, I have an Azure Stack HCI cluster, and so you can see I have 3 nodes here, nodes 1, 2, 3. And I'm going to go ahead and register this Azure Stack HCI cluster with Azure. I'll put it into my subscription into this resource group. And then after a moment, when that's finished registering, I can refresh. And what you'll see here is now in Azure, I can see my Azure Stack HCI cluster, and I can also see each of the nodes that is a member of this Azure Stack HCI cluster. Now, because these nodes are fully Arc enabled, I now have access to a lot of management capabilities directly from the Azure portal. One of them, for example, is Azure Policy, and that's what I'm going to show you as an example. Now, there are these things called extensions, and right now I don't have any extensions. You can see the list is empty. Now, I could add one from that table, but I want to show you how I can actually use Azure Policy to do this at scale, because we're talking about at-scale monitoring, right? So I've created an Azure Policy here that's going to install the Microsoft monitoring extension. There's a couple of parameters that I can give it, like my workspace ID and my workspace key. If you're familiar with log analytics, you'll recognize a lot of this. If you're not, don't worry, it's not that hard. And I'm just going to create this policy and assign it to all of the nodes in my cluster. Now, after a moment, once the policy has taken effect, I can go back to my node and see, look, here is the Microsoft monitoring agent now, which has been installed automatically for me right from the Azure portal onto node 1. And not just node 1, it's actually been installed onto all of the servers. And I want to show you that by doing something kind of cool. I'm going to add another node to this cluster. So before it was a 3-node cluster, now I'm going to add node 4. Now when I go back into the Azure portal, if you'll see I refresh in the browser, there is node 4. It shows up directly in the Azure portal for me. And because I set that policy that said, look, I want to use monitoring in Azure, I want all of them to have this agent, node 4 also has the Azure monitoring agent extension automatically installed on it because of my Azure policy. And so this is really, I think, a great example of how when all of the on-premises infrastructure is participating fully in Microsoft Azure like this, in the Azure Resource Manager model, all these capabilities that are so powerful and so useful, like Azure Policy and Azure Extensions, which you've been using all along for virtual machines in Azure, suddenly you can actually use them on-prem too. You can use them on Azure Stack HCI for the hosts as well as for the virtual machines and services that run on top. So that's a quick look at sort of Azure Arc, and how it's going to enable that at-scale monitoring that's going to be coming very soon in 2021. Something I do want to highlight is that from the Microsoft perspective, we are treating Azure Stack HCI as an extension of Azure itself. And what that means is that all of the management built-ins that are included for free as part of Azure are also included for free as part of Azure Stack HCI. So to be very clear, what I mean is services that are free on Azure are free on Azure Stack HCI too. Services that are not free on Azure are not free on Azure Stack HCI either. And I gave a couple of examples here that our team is specifically working on. Azure Policy, I just showed you in the demo, but there's also configuration management, Azure Automation, and others that will be coming down the road. And these services, when they are built in as part of the management experience of Azure, they are also built in and included as part of Azure Stack HCI. Now, I also mentioned, I do want to give just one more example, and that is, I mentioned Azure Identity Access Management. And a great scenario that our team is building right now, this will be coming very early in 2021 as well, is self-service virtual machines on top of Azure Stack HCI. What I mean by this is, when you deploy an Azure Stack HCI cluster on your premises, you will be able to delegate access to other users within your Azure Active Directory so that they can go in the Azure portal and actually create virtual machines onto the on-premises servers that you've created directly from the Azure portal, giving them a consistent set of tools that they can use using the portal and using the Azure SDK and Azure CLI, but also providing this kind of lightweight tenancy abstraction, because those users that you give this permission to, they can create VMs, but they are not able to actually access the underlying host infrastructure and go in and screw anything up. So this is a great example of the role-based access control that's possible with Azure Identity Access Management, and it's also a scenario that we've gotten a ton of requests for recently. So we're really excited to deliver this soon in the coming year, and I cannot wait to hear what you think about this scenario. Okay, so that's a lot to unpack, right? We talked about a lot of different things there, but hopefully you're starting to see what I mean when I say it's an on-premises, hyper-converged infrastructure operating system, but it's really delivered as an Azure hybrid service. And in so many ways, it looks and behaves in a manner that is consistent with Microsoft Azure, and sometimes is actually the same in terms of the experience. Like the experience I showed you with Azure Policy is identical to how you use Azure Policy in the Azure public cloud, but in this case, it's working against my on-premises servers. Now, I think it's important as we talk about all these things that are new and different to emphasize some things that are not changing, because we really believe it's important for Azure Stack HCI to be familiar for you in IT to manage and operate. And what I mean by that is that you have a set of skills and tools and processes that you and your team are already invested in, that you already know, and you should be able to continue using those tools, continue using those processes, continue taking advantage of those skills that your team already has as you adopt hyper-converged infrastructure and as you modernize. So that means a few different things. First of all, it means you can use the tools you already have and that you already know to manage Azure Stack HCI. The new Azure Stack HCI that I'm describing today, you can manage it through the Windows Admin Center, which gives you a modern browser-based local management experience that's included for free. There's no separate cost. If you have existing automation, meaning you've written PowerShell scripts, the new Azure Stack HCI has full compatibility with Windows PowerShell, the full .NET backward compatible Windows PowerShell. So you can continue to use your existing scripts with Azure Stack HCI. And coming early in 2021, you'll be able to use System Center as soon as the update rollup 3 is available for System Center 2019. You'll be able to use Operations Manager, Virtual Machine Manager, and Data Protection Manager together with the new Azure Stack HCI. Now that's, of course, sold separately, but my point here is if you have tools that you've already invested in and that your team already knows, you can continue to use them even as you modernize and start consuming a hybrid cloud service like Azure Stack HCI. And it's not just limited to first-party tools. So we've actually been working with many of the most popular third-party tools in the industry, including Veeam Backup, Altaro, Commvault, Datadog, Veritas, and others, to ensure that their tools also support the new Azure Stack HCI. And so if you use Veeam, for example, to back up everything in your environment, you can continue to do that and even back up the virtual machines that run on Azure Stack HCI. We know that's super important. We want it to be familiar and easy for you to manage and operate, and that's why we've been working with these third parties. I want to be clear, some of these tools that I'm describing run locally, and that's true today, and it's going to continue to be true. This is not something that we're trying to eliminate or change. And so if you manage Azure Stack HCI from the Azure portal, then of course that's based in the cloud. It's highly scalable. You can access it from anywhere. But what happens if you have an internet access hiccup or your connection is disconnected for a moment? Well, that's no problem, because you can use local tools like Admin Center or System Center, which are edge local. They run on your premises, right where the infrastructure is running. Those are always available even without internet connection. And our goal is to make it easy for you to use both of these tools because we think they're complementary. And we're working very hard to make them as consistent as possible with one another so that you can, in the same scenario even, you can start in one tool and transition into the other tool. And the whole experience is actually very seamless for you. And I'd like to give an example of that just to show you what I mean. This is a real demo of replicating virtual machines from an Azure Stack HCI cluster that's running on premises up into the Azure public cloud. And watch this. So I'm going to start in Windows Admin Center. Here I have my list of all the virtual machines that are running on my cluster. And I'm going to just select one of those virtual machines, go over here to the actions list, and I'm going to protect that virtual machine, which behind the scenes is going to use Azure Site Recovery to synchronously start replicating it up into an Azure Vault. Now, once that's set up, I can actually click here on Protected, and I can see the Recovery Services Vault where this virtual machine has been replicated to. I can see that the replication is ongoing, the state is healthy, and what you might have noticed, or maybe you didn't notice, is in the middle of that demo, I switched from Windows Admin Center, which is running on my premises, over into the Azure portal, which is running in Azure, hosted by Microsoft. But it looks very, very similar, right? The overall navigation, the patterns, the paradigms, how it looks and feels is very, very similar. And we're trying to make it as easy as possible to switch between these tools, even if it's in the middle of a scenario, so that you can get the work done that you need to get done, no matter where you are and in the way that makes the most sense for you. Now, last but not least, I've talked a lot about software tools, and whether they're third party or first party. It's also really important to talk about hardware. And so with Azure Stack HCI, we are committed to giving you the choice to run our software on the servers that make the most sense for you from the partner that provides the best services and support in your region. Many of these partners you see on the screen have a ton of experience with Azure Stack HCI. They're extremely capable and they have wonderful solutions available for the product. In fact, many of them are sponsors of today's event, so thank you very much. Many of these partners are also new, and so we're pretty excited with the momentum that we're seeing with Azure Stack HCI and how quickly this ecosystem is growing. We're up to over 200 validated solutions to run the Azure Stack HCI software. You can actually find these solutions by going to azure.com/HCI. There's a hardware catalog where you can browse all of the available solutions. And there's really a ton of variety. If you go there, you'll see there's an immense selection of different servers from different vendors, ranging from very large systems with a ton of storage capacity to very fast and high-performance solutions, and in fact, all the way down to very small solutions. I think it's probably good for me to point out, you do not need a huge amount of hardware to run Azure Stack HCI. In fact, you can start very, very small with just 2 servers, and those servers individually can be very small. They can be as little as 64 gigs of RAM, an 8-core processor or even less, and just a couple of SSDs and a couple of HDDs with 1 or 2 10 gigabit network connections between them. And a great example of that is actually a product called the Thomas Krenn microcluster. Thomas Krenn, of course, have launched a number of wonderful HCI solutions over the last year, but this is one of my favorites. And it's a very small, very lightweight solution that's very affordable. It's also very quiet. You should talk to them about it. And this is a great example of how you just don't need a huge footprint to get started. Even not just on little servers like this, you can run Azure Stack HCI, you can run virtual machines, you can even run the Azure Kubernetes service completely on a 2-node cluster like this. Okay, so that's some of what's new for Azure Stack HCI. We covered a ton of ground. I think you probably knew that was how this was going to go because it's the first session of the day. So some of these things you'll hear more about throughout the day. You'll get a little bit more detail. But we talked about what's new in the core hyper-converged infrastructure stack, the specialized new operating system with new features like native BCDR, faster storage resync, a guided workflow for deployment, and full stack updates. We talked about what it means to deliver Azure Stack HCI as an Azure hybrid service with native integration, no agent required, with the Azure portal. how you can manage it from Azure, how you can get support and billing and even run certain Azure services in a way that is completely consistent with Azure. And we talked about keeping it familiar for IT to manage and operate. So in spite of all of this change, in spite of all of these new features, making sure that the same tools that you know, that you trust, that your team is already invested in, that you have experience in, that you can continue to use those tools to manage Azure Stack HCI just like you would manage any other infrastructure that you're running on-prem. Okay, now with the exception of the things that I specifically noted that are coming soon, everything else is actually generally available today. So Azure Stack HCI is generally available worldwide right now. It has been since December 10th of last year. And so if you are ready for a hardware refresh, or if anything that I described today catches your eye, you can go ahead and get started with this right now. In fact, you can learn more by visiting azure.com/HCI. And to keep abreast of all of the latest news and updates, you can follow me on Twitter. I'm at Cosmos Darwin on Twitter, and whenever we have announcements like blogs or new demo videos or things like that, I always make sure to tweet about it so you can hear about it there. Okay, so that really concludes today's session. That was what I wanted to give as kind of a first overview of Azure Stack HCI. Hopefully you learned something. Hopefully this was exciting for you. We are very excited about the future of on-premises infrastructure and of hybrid edge infrastructure products from Azure. This is one of the sort of most exciting segments for us on the Azure team. We're making huge investments here. We hope that you'll come along for the ride, subscribe to Azure Stack HCI, and take advantage of these new capabilities. Over the course of today, you're going to hear a little bit more about some of these things and about other things. So of course, stick around. But now for the next 10 minutes, we have a short break, and then the next session will begin in just a few minutes. Okay, thank you very much.
Yeah, we'll have a short break at the moment for about 10 minutes till the next from the next track or the next session from Johannes starts. And yeah, let's go on, and the event will continue soon. Hello again. Our next session is the Microsoft Azure Stack Family by Hannes Lagler-Gruener. This track, this session will be held in German, and I'm proud to go on and give the control up to Johannes, and yeah, have fun. Bitte, auf geht's.
Ja, hallo zusammen. Freut mich heute, euch zu begrüßen dürfen auf der Experts Live in Österreich. Mein Name ist Hannes Lagler-Gruener. Ich bin Cloud Innovations Expert bei der Firma ACP. Ich beschäftige mich schon sehr, sehr lange mit dem Thema Public Cloud, bin auch in den unterschiedlichsten Bereichen zertifiziert. Einer meiner Hauptspezialitäten ist natürlich dementsprechend die Microsoft Azure Cloud. Ich bin auch unterwegs auf den unterschiedlichsten sozialen Foren, ob das jetzt LinkedIn, Twitter ist. Ich habe auch meinen privaten Blog, https://cloudblogger.at, und würde mich dementsprechend auch freuen, wenn Sie mich einmal besuchen würden. Das heutige Thema, das wir jetzt anschneiden werden, geht über die Azure Stack Family. Wir haben in der Keynote schon ein bisschen was gehört über Azure Stack HCI. Unsere Agenda heute wird sein, eben die komplette Azure Stack Family. Wir werden uns anfangs kurz unterhalten über das Thema Azure Stack Edge. Was ist denn Azure Stack Edge? Für was können wir das verwenden? Gehen nachher weiter in das Thema Azure Stack Hub. Viele von euch werden das Thema vielleicht schon kennen. Ich möchte es aber noch einmal aufrollen, dass man weiß, okay, für was benötigt man diese Produkte und wo ist dann auch der richtige Einsatzzweck und was kann man damit vor allem auch machen. Und zum Schluss natürlich auch von meiner heutigen Session das Hauptfokusthema Azure Stack HCI und hier dann auch ein bisschen tiefer in die Thematik hinein, auch in den Bereich Hybrid-Szenarien. Wie funktioniert es? Welche Services gibt es in Hybrid? Und ganz wichtig, ich werde Ihnen heute auch eine Live-Demo zeigen. Live-Demos sind normalerweise immer ein bisschen kritisch, aber ja, ich habe eine Live-Demo gebaut. Wir werden uns direkt mit unserem Azure Stack HCI in unserer Firma connecten und dann werde ich Ihnen einiges auch dementsprechend zeigen. Okay, nächste Slide. Wir haben heute schon ganz kurz in der Keynote gesehen, dieses Bild. Die Azure Stack Family ist natürlich dafür angedacht, dass sie halt eben die unterschiedlichsten Bereiche abdeckt, ob das jetzt Disconnected-Szenarien sind, Data Center oder Edge-Szenarien. Natürlich alles ist in einem großen Verbund quasi in dieser Azure Stack Family. Es gibt unterschiedliche Anwendungszwecke, die wir halt eben verwenden können. Es gibt unterschiedliche Produkte in unterschiedlichen Kategorien, wo es ja dann am besten passen würde. Das bringt mich gleich einmal zu dem Thema Azure Stack Edge. Was ist Azure Stack Edge? Edge ist im Prinzip ein Service, ihr könnt Edge Computing Workloads in eurer Edge Location laufen lassen. Grundsätzlich ist das so, dass wir hier Monthly Payment haben für die Hardware. Also es gibt hier, Microsoft bietet hier auch dementsprechend Hardware an, die man mieten kann. Und ihr habt natürlich unterschiedliche Szenarien, die hier auch abbilden könnt. Ein ganz wichtiger Punkt hierbei ist, wenn wir von Edge sprechen, sprechen wir grundsätzlich von einer Single Node, sprich wir haben hier keine Hochverfügbarkeit. Wir können hier unterschiedliche Hardware kaufen, sehen wir nachher im nächsten Slide. Was sind so typische Anwendungsszenarien für ein Azure Stack Edge? Grundsätzlich ist es ja so, dass wir hier Machine Learning Szenarien theoretisch in Edge laufen lassen können. Wir können hier auch IoT Solutions laufen lassen. Also wir können hier quasi Azure Stack Hub, also Azure Hub auf der Edge laufen lassen, wo wir halt dann halt dementsprechend auch die Messages empfangen, dann halt dementsprechend auch aufbereiten können und auch in die Cloud transferieren können. Ein ganz wichtiger Punkt ist natürlich hier auch das Thema Network Data Transfer. Azure Stack Edge ist auch dafür gedacht, dass wir zum Beispiel von On-Premise Daten in die Cloud transferieren können. Es gibt hier unterschiedliche Einsätze, dass man sagt, okay, ich transferiere die Daten auf den Azure Stack Edge und von dort werden sie dann nachher zentralisiert in die Cloud nachher transferiert. Oder wir können uns auch die Azure Stack Edge Box bestellen, quasi, dass wir sagen, okay, wir transferieren die Daten auf die Edge, schicken diese Daten, also diese Box nachher dementsprechend in das jeweilige Rechenzentrum, wo ich die Daten einspielen möchte und kann dort dann auch die Daten wiederverwenden und habe dann auch eben die Möglichkeit, dass ich die Daten auch in der Cloud einspiele. Wie schon vorher erwähnt, gibt es unterschiedliche Hardware-Typen. Wir reden hier von 3 Azure Stack Edge-Serien, die von der Microsoft angeboten werden. Es gibt die Pro A und die Mini A. Die Mini A-Series ist sehr, sehr klein. Sie ist optimiert halt eben für sehr, sehr kleine Solutions. Also theoretisch könntet ihr das sogar auch in einen Rucksack einpacken. Es ist eine batteriebetriebene Variante. Dann gibt es alternativ natürlich die Pro A-Series. Hierbei reden wir von einer staub- und stoßgeschützten Variante, wenn es zum Beispiel darum geht, dass ich die Daten oder das Service selbst mobil benötige und vielleicht dann auch irgendwo mit hin transportieren möchte. Und die Pro-Serie ist grundsätzlich eine 1HE-Einheit, dass man zum Beispiel in ein Datacenter nachher dementsprechend in der Edge reinschrauben kann und verwenden kann. Soweit so gut, einmal ganz kurz umrissen, was Azure Stack Edge bedeutet. Wir werden heute noch im Laufe der Zeit noch ein bisschen mehr davon hören. Ich möchte jetzt gleich einmal auf das Thema Azure Stack Hub eingehen. Was ist denn überhaupt Azure Stack Hub? Azure Stack Hub ist ein Service oder beziehungsweise das sind Server, die man kaufen kann, damit ich Cloud-Services on-premise abbilden kann. Was bedeutet das? Ich kann hier auch nicht nur virtuelle Maschinen hosten, also Infrastructure as Service. Ich kann hier auch Plattform as a Service Szenarien abbilden, sprich ich kann auf den Azure Stack Hub auch Cloud Native Apps entwickeln. Ich habe zum Beispiel die Möglichkeit, dass ich auf einen Azure Stack Hub auch eine Azure Web App laufen lassen kann oder einen Azure Key Vault, wo ich vielleicht meine Secure-Daten ablegen möchte, Connection Strings und so weiter. Ich habe hier auch die Möglichkeit, dass ich dementsprechend einen Azure Storage Account integriere und vielleicht auch Kubernetes in weiterer Folge. Der wichtige Punkt hierbei ist, wir haben consistent Tools und Experiences. Was bedeutet das? Grundsätzlich heißt es so, dass wir, wenn wir den Azure Stack Hub kaufen, wir bekommen eine fixfertige Solution von unseren Hardware-Provider und können dann nachher darauf läuft der Azure Stack Hub und on top drauf ist eben das Azure Stack Hub Portal für die User beziehungsweise auch für die Admin-Konstellation. Ergo, wir haben auf das Betriebssystem, was drunter läuft, also quasi die virtuellen Maschinen, die halt eben dieses Service zur Verfügung stellen, keinen Zugriff. Es ist ein geschlossenes System und ich habe eigentlich auf die Web-Oberfläche, die sehr, sehr ähnlich ist zu dem Public Azure Portal Zugriff, ob das jetzt die User-Portal oder das Admin-Portal ist für Subscription-Erstellung, auf das habe ich Zugriff. Bringt mich dann halt zum nächsten Punkt natürlich auch Consistent Tools. Also ich habe hier natürlich auch die Möglichkeit, dass ich unterschiedlichste Tools verwende, ob das jetzt ARM-Templates sind, Azure PowerShell oder natürlich auch das CLI. Also ich habe hier wirklich ein komplettes Ökosystem. Es gibt von Azure Stack HCI 2 Szenarien. Ein Szenario lautet Connected und das andere ist Disconnected. Was bedeutet das? Connected heißt, wenn ich den Azure Stack HCI aufbaue, muss ich mich ja irgendwie dann auch auf den Azure Stack HCI Portal anmelden können. Grundsätzlich in der Standardkonfiguration ist es so, dass wir hier für das Azure Active Directory benötigen. Sprich, ich brauche ein Azure Active Directory, ich brauche eine Subscription dementsprechend auch, damit ich mich halt dann auch dementsprechend in Azure Stack HCI anmelden kann. Wenn ich aber ein Disconnected-Szenario benötige, gibt es hier auch die Möglichkeit, dass ich eine Disconnected Azure Stack HCI mir aufbaue. Ist dann auch für die Lizenzierung etwas anders. Und Sie haben dann nachher im Azure Stack HCI auch Ihren Authentifizierungsprovider, der halt Ihnen dann nachher die Möglichkeit zur Verfügung stellt, damit Sie sich auch dann auf den Azure Stack HCI Portal anmelden können. Frage, warum Azure Stack HCI überhaupt? Azure Stack HCI, ein Thema ist natürlich ganz oben, ganz präsent, Azure in Your Data Center. Wenn Sie schon die Public Azure Cloud verwenden und Sie haben zum Beispiel Legacy-Applikationen in Einsatz, die halt vielleicht aus gewissen Gründen, wir kommen im nächsten Slide, also übernächsten Slide ein bisschen näher auf das zu sprechen, die einfach nicht in der Public Cloud laufen können. Sie wollen aber die gleichen Tools und die gleichen Experiences haben auch on-premise, dann haben Sie natürlich die Möglichkeit, mit Azure Stack HCI auch Azure in Ihr Data Center zu bringen, mit den gleichen Tools und den gleichen Application Model. Wir sind natürlich beim Azure Stack HCI hier auch flexibel, fast und flexibel, also wir können sehr, sehr schnell Ressourcen nach oben spinnen und aber auch wieder dekommissionieren, wenn es notwendig sein sollte. Und das bringt mich auch zu den Verrechnungsmodell. Beim Azure Stack HCI reden wir von einem Pay-as-you-use-Modell, sprich alle virtuellen Maschinen, die Sie laufen lassen, kosten Ihnen nur so lange etwas, solange die VM auch läuft. Wenn sie wieder abgedreht wird, kostet diese VM nichts mehr. Keine Lizenz und auch keine Azure Stack HCI Ressourcekosten. Ein weiterer wichtiger Punkt ist natürlich auch Single Contact for Support. Wenn Sie Ihre Hardware kaufen bei Ihren Hardwareherstellern und dann auch Azure Stack HCI auf der Hardware drauflaufen lassen, dann können Sie in einem Problemfall entweder den Microsoft anrufen oder aber auch den Hardwarehersteller anrufen. Es ist egal in diesem Fall, ob das jetzt ein Hardware- oder ein Softwareproblem ist. Auf beiden Seiten wird Ihnen geholfen, beziehungsweise wird dann auch im Hintergrund dementsprechend auch die weiteren Schritte veranlasst, dass dann zum Beispiel der Partner nachher mit involviert wird. Wir haben jetzt schon einiges gesprochen bezüglich Hardware, Hardwarehersteller, externe Hersteller. Wir als ATB bieten Azure Stack HCI an. Wir haben Azure Stack HCI bei HP gekauft. Es gibt hier unterschiedlichste Ausprägungen. Wir haben in unserem Fall einen 8-Node-Cluster in Einsatz. Es gibt hier die Variante bis maximal 16-Node-Clustering aufzubauen. Sie sehen hier unterschiedliche Rack-Typen. Wir können hier von DL380 Hybrid Node, DL380 All-Flash Node beziehungsweise DL360 All-Flash Node zum Beispiel auswählen. Zusätzlich haben Sie noch die Optionen zwischen Disk- und HP-Switches zu wählen. Des Weiteren gibt es optional noch KVM-Switches zu integrieren. Also wirklich ein sehr, sehr breites Portfolio, das wir hier anbieten können, also das, was die HP hier anbietet und Sie dann auch dementsprechend auch in Ihr Rechenzentrum implementieren können. Wir haben vorher schon kurz gesprochen über Use Cases. Use Cases für den Azure Stack HCI. Was könnte das zum Beispiel sein? Wir haben hier einige aufgelistet, zum Beispiel, wie vorher schon erwähnt, Legacy Application. Hier in Klammer ein Szenario Low Latency. Wenn wir Services in der Public Cloud positionieren und von On-Premise auf das Service zugreifen, dann haben wir natürlich eine gewisse Latenzzeit, weil die Services stehen ja Stand heute noch nicht in Österreich. Das Rechenzentrum wird ja, wie Sie wissen, erst gebaut in den nächsten Jahren. Aber sie stehen, das nächste Rechenzentrum ist von unserer Seite her dann auch in Deutschland und da haben wir eine gewisse Latenzzeit, die wir halt eben beachten müssen. Wenn das die Applikation nicht unterstützt oder wenn das eben so eine Legacy-Applikation ist, dann haben Sie natürlich die Möglichkeit, das auf Ihren Azure Stack HCI mit der gleichen User Experience und den gleichen Toolings auch zu implementieren. Ein weiteres Thema kann natürlich auch immer Compliance sein. Compliance bedeutet, wenn ich zum Beispiel Daten habe, die nicht in der Public Cloud positioniert werden müssen, aus welchen Gründen auch immer, kann ich hier zum Beispiel die Daten auf den Azure Stack HCI ablegen und vielleicht, wenn ich sie danach in die Cloud transferiere, anonymisieren und danach in der Cloud ablegen. Werden wir dann nachher bei den Tiered Data for Analytics sehen, wenn wir ein bisschen mehr ins Detail reingehen. Geo-Distributed ist auch immer ein spannendes Thema. Geo-Distributed bedeutet dann auch im Wesentlichen, ich habe mein Azure Stack Hub, da läuft meine Applikation und ich kann sie dementsprechend auch erweitern und vielleicht die Public Cloud auch dafür verwenden, um ein Cross-Cloud-Scaling zu machen. AI at Edge, in dem Fall kann ich es natürlich in Edge implementieren. Ich kann es aber auch, wenn ich Hochverfügbarkeitsszenarien benötige, auch im Azure Stack Hub implementieren. Und die letzten zwei Themen, Cross-Cloud-Scaling bzw. Tiered Data for Analytics, möchte ich Ihnen jetzt einmal ein bisschen näher zeigen. Also ich möchte es Ihnen anhand auch von Grafiken zeigen. Wir haben hier eine Möglichkeit, Cross-Cloud-Scaling zu implementieren in der Azure Cloud. Was bedeutet das? Auf der rechten Seite sehen Sie im Prinzip die User, die sich auf der Applikation anmelden möchten. Sie kommen vom Internet und melden sich auf einen Azure Traffic Manager an. Der Azure Traffic Manager läuft grundsätzlich in der Public Cloud und ist nichts anderes als ein globaler Layer 3, Layer 4 Load Balancer. Damit natürlich die Namensauflösung funktioniert, benötigen wir auch dementsprechend einen Azure DNS Service. Und dann geht es weiter. Dann weiß der Azure Traffic Manager, okay, es kommt ein Request, ich möchte auf die Applikation zugreifen. Und primär greift der Azure Traffic Manager bzw. routet der Azure Traffic Manager auf einen App-Service auf unseren Azure Stack Hub weiter. Wenn dort theoretisch die Ressourcen ausgelastet sein sollten auf den Azure Stack Hub oder wenn diese Web-App schon ziemlich ausgelastet sein sollte, gibt es hier eine Azure Function, die kann entweder in der Public Cloud laufen oder halt eben auf den Azure Stack Hub. Und diese Azure Function monitort eben diese Applikation am Azure Stack Hub und kann im Notfall auch in der Public Cloud mit dem gleichen Source Code, also quasi mit dem gleichen ARM-Template, Ressourcen nach oben spinnen und dementsprechend auch in den Azure Traffic Manager integrieren und dann auch neue Ressourcen wieder zur Verfügung stellen. Zwei Vorteile daraus natürlich. Einerseits einmal Kundenzufriedenheit. Die Applikation läuft performant. Und der zweite große Vorteil natürlich, ich zahle für das, was ich benötige. Sprich, wenn die Last wieder wegfallen sollte, werden auch die Ressourcen in der Public Cloud zum Beispiel wieder dekommissioniert und ich zahle auch nichts mehr dafür. Soweit einmal von den Cross-Cloud-Scaling. Ein weiteres Thema kann natürlich auch sein, wie vorher schon kurz besprochen, Tiered Data for Analytics. Wir haben unsere Daten. Die Daten sind aus Compliance-Gründen, dürfen sie nur anonymisiert in der Public Cloud abgespeichert werden. Jetzt haben wir hier die Möglichkeit, am Azure Stack zum Beispiel einen Azure Storage Account anzulegen, ganz auf der linken Seite. Und dort sehen Sie dann, werden die Daten auf den Azure Stack, also auf den Azure Storage Account abgespeichert, mit einer Azure Function auf einer lokalen Web Application zur Verfügung gestellt innerhalb von meinem Data Center. Und wenn ich die Daten nachher noch rausschieben möchte, transformiert diese Azure Function bzw. sendet die analysierten Daten zu einer Storage Queue bzw. auch zu einer Storage Archive Queue. Und dann gibt es eine weitere Function, genau diese hier. Diese nimmt die Informationen von der Azure Storage Queue, anonymisiert diese Informationen und speichert die Daten auf einen Azure Storage Account in der Public Cloud ab für den globalen Zugriff. Somit kann ich natürlich beide Funktionen verwenden und habe natürlich eine User Experience. Ganz wichtig, ich habe hier natürlich die gleichen Services on-premise am Azure Stack Hub, wie aber auch in der Public Cloud. Das kann natürlich auch ein Anwendungsszenario sein für Sie als Kunde, wenn Sie sagen, Sie verwenden schon Public Cloud, es gibt aber gewisse Services, die einfach in der Public Cloud nicht funktionieren. So, wie spielt denn dieses Thema, diese beiden Themen jetzt der Azure Stack HCI mit hinein? Grundsätzlich, was ist denn der Azure Stack HCI? Wir haben in der Keynote schon einiges gehört. Ich werde deshalb hier auch etwas schneller drüber gehen. Grundsätzlich reden wir von einer Hyper-Converged Infrastruktur. Wir sind hier flexibel vom Hardware-Offering. Also wir können hier unterschiedliche Hardware-Sizes kaufen, von sehr, sehr klein bis sehr große Environments. Der Unterschied hier zwischen Azure Stack HCI und Azure Stack Hub. Hier ganz klar, beim Azure Stack Hub gibt es eine Minimum-Konfiguration von 4 Nodes, die man halt verwenden sollte und dementsprechend auch vom Preis her also um einiges höher als der Azure Stack HCI. Beim Azure Stack HCI habe ich natürlich flexible Hardware-Offerings. Azure ist Hybrid by Design. Wir werden in der späteren Folge auch Live-Demos sehen, was das bedeutet. Ich werde Ihnen wirklich anhand von einer Live-Demo zeigen, wie wir Hybrid Solutions auch für den Azure Stack HCI verwenden können. Familie, Management and Operations. Vorher haben wir es auch schon ganz kurz gehört. Sie können natürlich das Windows Admin Center verwenden für die Administration, also beziehungsweise ist das die Administrationsengine. Es gibt auch PowerShell-Module, die Sie verwenden können. Sie haben hier im Hintergrund einen Hyper-V-Cluster aufgebaut, können dort natürlich in weiterer Folge, also in Zukunft dann auch dementsprechend auch die System Center Produkte verwenden und ihren Azure Stack HCI administrieren. Ganz unten gibt es das in-air Data Center, Branch Office oder Offline. Und das ist ein Use Case, den ich gerne mit Ihnen noch teilen möchte. Ein Kunde von uns ist uns herangetreten und hat gesagt, er ist ein weltweiter Kunde mit sehr, sehr vielen Branch Offices und einigen Data Center und er möchte gerne die Branch Offices standardisieren, sprich gleiche Hardware in jedem Branch Office und eine zentrale Administration oder eine vereinheitlichte Administration. Die Idee von uns dahinter ist dann aber gewesen, dass wir gesagt haben, okay, lieber Kunde, priorisieren wir oder kategorisieren wir Ihre Branch Offices nach Größe. Dann können wir dementsprechend auch die Hardware einkategorisieren, dass wir sagen, zum Beispiel bis 10 Mitarbeiter im Branch Office, Hardware XY, ab 10 Mitarbeiter bis 30 Mitarbeiter und dann auch noch höher. Also es hat dann auch im Endeffekt 3 Hardware-Typen gegeben, die wir halt eben für die Branch Offices ausgegeben haben. Natürlich dementsprechend immer hoch verfügbar und zentral gemanagt über das Windows Admin Center. Das kann natürlich durchaus ein Use Case sein für den Azure Stack HCI. Den Punkt haben wir heute noch nicht gesehen. Ich möchte hier noch einmal veranschaulichen, die Überlappung zwischen Azure Stack Hub und Azure Stack HCI. Den Azure Stack Edge habe ich hier jetzt bewusst rausgenommen. Auf der ganz linken Seite sehen wir die Public Cloud, Azure Cloud. Also sprich, wir reden hier von Azure Hardware, von Cloud Computing, Storage, Networking, natürlich dementsprechend auch das Azure Portal, die API, Infrastructure Service, Platform as a Service und Cloud Platform Admin Tools. Azure Stack Hub greift in diesem Bereich auch durchaus ein, also sprich der oberste Layer, das Portal und die API sind am Azure Stack Hub sehr, sehr ähnlich, ich sage ganz bewusst sehr ähnlich. Grundsätzlich ist es so, dass der Azure Stack Hub circa von der Entwicklungsphase ein Jahr zurück ist zur Public Cloud, logischerweise, aber wir haben hier nahezu same User Experience. Aber wir reden vom Azure Stack Hub hier auch von einer Hybrid Converged Compute Storage und Netzwerkinfrastruktur beziehungsweise von Industriestandard-Hardware, die wir halt immer am Azure Stack Hub verwenden. Und ganz auf der rechten Seite sehen wir den HCI und der HCI hat eigentlich im Prinzip kein vereinheitlichtes Portal, also quasi nicht das Azure-Portal, sondern wir haben hier eine andere Komponente, was wir in weiterer Folge sehen werden. Wir sind aber auf einer Hybrid Converged Infrastruktur unterwegs und wir haben Industriestandard, den wir halt dementsprechend nachher integriert haben. Wie ist die Architektur von Azure Stack HCI? Ganz unten ist natürlich der Layer validierte Partner-Hardware, also sprich, ich kaufe Hardware, wie Darwin vorher schon kurz gezeigt hat. In den Online-Marketplace kann ich es mir zum Beispiel anschauen, kaufe ich zum Beispiel von Thomas Krenn eine Hardware und das ist eine validierte, eine zertifizierte Hardware. Auf diese Hardware kann ich dann nachher Azure Stack HCI oder Azure Stack HCI OS, das neue OS, was mittlerweile GA ist, installieren und habe dann nachher die Möglichkeit, dass ich natürlich Hyper-V drauf laufen lassen kann, Software-Defined Storage und Software-Defined Networking-Szenarien. Und on top, obendrauf, kann ich natürlich dementsprechend meine virtuellen Maschinen, ob das jetzt Linux oder Windows ist, oder in weiterer Folge auch ein Kubernetes-Cluster oder sonstige Services drauflaufen lassen. Für die Administration von den Azure Stack HCI ist natürlich das Windows Admin Center verantwortlich, also sprich, unser zentraler Einstiegspunkt ist das Admin Center für diesen HCI OS, wo wir auch den Cluster konfigurieren, wo wir auch virtuelle Maschinen anlegen. Stand heute, in Zukunft, wie Darwin ja auch gezeigt hat, ist auch geplant, dass man über Azure Arc eine virtuelle Maschinenprovisionierung in der Public Cloud machen kann. Und das bringt mich auch zu dem Thema oben drüber. Das Azure-Portal wird immer mehr und mehr auch in das Azure Stack HCI integriert, ob das jetzt Kubernetes ist, Azure Arc ist für die Administration oder sonstige Services, die ich dann auch später noch zeigen würde. Oder natürlich auch ganz unten für das Azure Stack HCI OS auch für die Lizenzierung. Wir haben ja vorher gehört, dass die Lizenzierung unter anderem über die Public Cloud gemacht wird. Jetzt noch einmal, warum Azure Stack HCI? Wir haben hier standardisierte Hardware, die wir halt eben zentral managen können. Wir haben hier flexible Hardware-Choices, also sprich, wir können unterschiedliche Hardware-Typen verwenden, Hardware-Größen von unterschiedlichsten Herstellern und so weiter, alles zertifiziert dementsprechend. Es gibt mittlerweile 200 und mehr Azure Stack HCI Solutions, es gibt 25 Partner unter anderem. Wir haben für den Azure Stack HCI eine monatliche Subscription Fee pro Core, also sprich, wir registrieren den Azure Stack HCI in der Public Cloud und zahlen dementsprechend auch für die Cores. Und wenn Sie natürlich jetzt das schon Hyper-V kennen, dann werden Sie natürlich beim Azure Stack HCI auch nicht die großen Probleme haben, weil es läuft im Prinzip ja auch auf den Azure Stack HCI Hyper-V bzw. ein Hyper-V-Cluster. Und ganz wichtig, es ist integriert ins Data Center und arbeitet mit den bestehenden Tools und auch mit den bestehenden Prozessen zusammen. Wir haben bei uns in unseren Rechenzentren dementsprechend auch den Azure Stack HCI implementiert. Sie sehen hier, ich habe jetzt einmal aufgelistet von HP. Unser Azure Stack HCI ist von HP. Es gibt hier unterschiedlichste Ausprägungen, ob wir jetzt eine DL380 Gen 10 oder vielleicht eine Edgeline EL8000 oder vielleicht die große Variante Synergy 480 Gen 10 verwendet. In unserem Fall haben wir die DL385 Gen 10 in Einsatz. Also wir haben zwei Komponenten hier. Wir haben Azure Stack HCI Cluster aufgebaut und den werden wir dann auch in unserer Testumgebung uns anschauen. Wie ist das jetzt da von Hybrid Services? Es gibt hier unterschiedlichste Hybrid Services, die wir beim Azure Stack HCI nutzen können. Cosmos Darwin hat das kurz auch schon angeschnitten, wegen Azure Site Recovery, Azure Monitoring, Azure Backup, Azure Update Management, Network Adapter, File Sync, Azure Arc und ein ganz wichtiges Thema auch Cloud Witness. Wenn wir von einem Cluster reden, müssen wir nachher irgendwo natürlich auch unseren Witness-Bereich ablegen. Hier gibt es auch die Möglichkeit, dass wir Cloud Witness verwenden, sprich ich lege diese Witness-File in der Cloud ab auf einen Storage-Account und kann dann halt eben diese Services so nutzen. Wir werden in der Demo, in der Live-Demo noch einige von diesen Services auch live sehen, wie es funktioniert und wie wir das dementsprechend auch nutzen können. Und zu guter Letzt möchte ich Ihnen noch zeigen, bevor wir in die Demo starten, Support and Billing, wie Cosmos Darwin vorher schon erwähnt hat. Es gibt hier ein dezidiertes Team für Azure Stack HCI, wo Sie halt eben die Möglichkeit haben, wenn ein Problem auftreten sollte, das Team kontaktieren. Es gibt hier die Möglichkeit, dass Sie das natürlich direkt über das Azure-Portal machen. Also Sie haben hier im Azure-Portal die Azure Stack HCI Ressource und auf dieser Azure Stack HCI Ressource können Sie dementsprechend auch ein Ticket aufmachen, wenn es Probleme geben sollte. Es gibt hier auch unterschiedliche Plans, die Sie auswählen können, also Azure Support Plans, die starten von $29 im Monat und gehen natürlich dementsprechend auch nach oben. So, mittlerweile sind wir bei der Demo angelangt. Ich möchte Ihnen jetzt live zeigen, wie wir Azure Stack HCI verwenden können. Ich switche hier dazu, wie gesagt, auf eine Live-Demo. Und ich bin jetzt auf unseren Server in der Firma connected. In dem Fall bin ich jetzt auf den Windows Admin Center Server verbunden. Und wir sehen hier unterschiedlichst, ich werde das ein bisschen größer machen, damit es vielleicht schon sichtbarer ist. Wir sehen hier unterschiedliche Server gebunden. Einerseits gibt es hier den Gateway-Server, der halt eben notwendig ist, damit das Windows Admin Center läuft. Und hier gibt es zwei Azure Stack HCI Server und oben drüber gibt es natürlich die Cluster-Konfiguration auch. Dementsprechend werde ich hier jetzt auf den Cluster switchen und wir sehen dann nachher, wenn alles gut läuft, eine Übersicht, wie es meinem Cluster geht, welche Ressourcen ausgelastet sind, also wie die Ressourcen ausgelastet sind und dementsprechend, wie die Volumes ausgelastet sind. Memory Usage, CPU Usage, Storage Usage, Cluster Performance und so weiter. Wenn ich hier weiter nach unten schaue, gibt es hier den Serverbereich und hier drinnen sehe ich dann nachher auch in einer Übersicht über meine einzelnen Azure Stack HCI Server und natürlich dementsprechend, ob hier auch Fehler aufgetreten sind. Und weiter auf der rechten Seite im Inventory sehen wir hier, okay, wir haben hier Houston 1, Houston 2, das sind zwei HPE-Server, DL385 Gen 10 und die Auslastung dementsprechend auch. Ein ganz wichtiger Punkt hier natürlich auch, wir haben hier unter Drives die unterschiedlichsten Disken, die wir halt eben in unseren Azure Stack HCI integriert haben. Wir haben ja NVMe-Disken, die halt eben für Caching verwendet werden, und nochmal die HDD-Disken, die halt nachher dementsprechend auch für die Datenaufbewahrung verwendet werden. Ganz wichtig, wir reden hier von Storage Spaces Direct, das wir halt dann nachher eben zusammenspannen können. Des Weiteren können wir hier auch unter Volumes, können wir hier ein neues Volume anlegen. Ich habe jetzt, der Stand heute, 2 Volumes drinnen, das Volume 1 und das Volume 2. Und wenn ich ein neues Volume anlegen möchte, gibt es hier die Möglichkeit, einfach Volume 3 anzulegen, zum Beispiel mit 1 Terabyte, und klicke hier auf Create und habe ein zusätzliches Volume, wo ich dann halt dementsprechend auch meine virtuellen Maschinen positionieren lassen kann. So, als nächsten Punkt switchen wir jetzt in den Bereich Servermanagement, und ich möchte mich jetzt zum Beispiel hier auf den Houston 1 einmal connecten. Das ist einer von meinen Azure Stack HCI Server. Und jetzt sehen wir hier in Overview, sehen wir hier, okay, wie dieser Azure Stack HCI aufgebaut ist, welche Version installiert ist, welche Prozesse drinnen sind, von welchem Manufacturer und so weiter. Dann gibt es hier auf der linken Seite, und da kommen wir schon das erste Mal hinein, was wir vorher auch schon gesehen haben in der Slide, auf die Hybrid Services. Es gibt unterschiedlichste Hybrid Services, Azure Hybrid Services, die wir hier auch verwenden können. Es sind in meiner Konstellation 4 konfiguriert, die kommen ein bisschen später nachher zum Sprechen. Es gibt aber hier noch weitere Services, die nicht konfiguriert sind. Und ich möchte hier ganz kurz einmal auf die Services eingehen. Einerseits gibt es hier Azure Backup, damit ich natürlich auch ein Long-Term Retention Backup für meine Services, für meine Server anlegen kann. Azure File Sync, wenn ich meinen File-Server entlasten möchte und zum Beispiel sogenannte Cool Data, also die Archivdaten, auslagern möchte in der Cloud. Und natürlich Azure Network Adapter, wenn ich virtuelle Maschinen in meinen Azure Stack HCI habe und ich möchte einzelne virtuelle Maschinen mit der Public Cloud connecten, dann habe ich hier mit Azure VNet, Azure Virtual Network Adapter, die Möglichkeit, ein sogenanntes Point-to-Site VPN aufzubauen. Azure Security Center habe ich in meinem Fall schon einen Einsatz, das werden wir dann auch sehen. Und Azure Extended Network, wenn ich die gleichen IP-Adressen-Segmente on-premise wie aber auch in der Cloud verwenden möchte, dann habe ich halt eben die Möglichkeit, auch Azure Extended Network zu implementieren. Des Weiteren in meiner Konfiguration konfiguriert Azure Site Recovery, werden wir nachher später gleich sehen. Azure Monitor, damit ich auch dementsprechend meine virtuelle Maschine monitoren kann, wie Cosmos Darwin auch schon kurz gezeigt hat. Azure Arc for Servers und Azure Update Management. Zu diesem Zweck werde ich jetzt einmal weiter nach unten scrollen und werde hier auf den Punkt gehen, Virtual Machines. Ich habe in meinen Azure Stack HCI 2 virtuelle Maschinen installiert, die halt eben also von mir installierbar sind, und eine dritte virtuelle Maschine, das ist im Prinzip mein Domain-Controller. Wir werden uns heute aber auf die oberen 2 virtuellen Maschinen konzentrieren, und Sie sehen hier ganz rechts das Thema Disaster Recovery Status Protected. Also diese virtuelle Maschine läuft jetzt auf meinem Azure Stack HCI Cluster, ist aber protected by Public Azure. Und ich habe hier auch die Möglichkeit, direkt drauf zu klicken, und Sie werden jetzt gleich sehen, es geht hier ein neues Fenster auf und ich melde mich direkt in der Public Cloud an, direkt in mein Recovery Services Vault, und sehe meine 2 virtuellen Maschinen, wie es ihnen dementsprechend auch geht. Jetzt kann ich hergehen und ich möchte zum Beispiel im Notfall, wenn mein Rechenzentrum nicht mehr funktionieren sollte, aus welchen Gründen auch immer, und ich möchte jetzt zum Beispiel meine Core-Services in der Public Cloud kurzfristig restoren, gibt es hier die Möglichkeit, zum Beispiel, ich klicke hier jetzt auf den HCI Experts Live VM01 und klicke hier einfach auf, sagen wir jetzt einfach mal ein Test-Failover. Ich muss jetzt da keinen Failover direkt machen. Und dann kann ich hier auswählen, okay, von wo soll es denn nach wo transferiert werden? In dem Fall vom Azure Stack HCI in die Public Cloud. Es wird im Prinzip, sofern er noch erreichbar ist, der Cluster, wird noch ein letzter Snapshot gezogen und die Daten werden dann auch in die Cloud transferiert. Dort wird dann auch eine virtuelle Maschine gestartet. Wir sehen es hier jetzt, also ich kann hier den Azure Stack HCI auswählen, das ist der SME Fabric to Microsoft Azure. Dann auch den Recovery Point, und hier unten kann ich dann auch noch auswählen, in welches virtuelles Netzwerk möchte ich denn die virtuelle Maschine binden. Ich habe hier eines vorkonfiguriert und dann klicke ich hier auf OK. Und jetzt beginnt der Failover. Sprich, ich kann hier, es wird hier jetzt eine neue virtuelle Maschine gestartet. Das kann jetzt etwas dauern. Und wenn es nachher fertig ist, ist die virtuelle Maschine fix fertig in der Public Cloud provisioniert und ich kann sie dort weiterverwenden. Im Zuge dessen, wir warten natürlich jetzt nicht die 5 bis 10 Minuten, sondern wir gehen weiter in Kontext und schauen uns zum Beispiel weitere Services an, die wir halt eben hier zur Verfügung haben. Ein Service hier, ich switche ganz kurz auf die neue Ansicht. Ein weiteres Service hier, wie Cosmos Darwin vorher schon angesprochen hat, ist natürlich das Thema Azure Arc for Server. Ich habe meine virtuellen Maschinen, die ich in meinen Azure Stack HCI, aber auch die Cluster Nodes mit Azure Arc verbunden und ich habe hier unterschiedlichste Möglichkeiten. Eine Möglichkeit hier kann natürlich auch sein, dass ich hergehe und klicke jetzt zum Beispiel auf die virtuelle Maschine und habe hier das Thema Security. Und ich möchte mir hier tatsächlich die Security anschauen und die Recommendations für die virtuelle Maschine, die on-premise gehostet ist. Das gleiche Thema habe ich natürlich auch bei den Azure Stack HCI Nodes. Und ich sehe hier, System Updates should be installed on virtual machines. Adaptive Application Control for Defending Safe Application und so weiter. Also es gibt hier schon Recommendations, die ich implementieren kann von Azure Security Center für meine virtuellen Maschinen on-premise. Ich habe hier natürlich auch die Möglichkeit, Extensions zu installieren, ob das jetzt über eine Policy ist oder halt eben manuell. In meinem Fall bei dieser virtuellen Maschine habe ich 2 Extensions bereits installiert. Ich habe hier jederzeit die Möglichkeit auch, wenn ich auf Add klicke, dass ich weitere Extensions installiere, zum Beispiel PowerShell Desired State Configuration, damit ich die virtuelle Maschine konfigurieren kann oder halt zusätzliche PowerShell-Skripte. So, jetzt kommen wir zu dem wichtigen Thema Monitoring. Ich möchte meine virtuellen Maschinen dementsprechend auch monitoren und habe hier natürlich bei der Azure Server for Arc den Punkt Insights. Und ich sehe hier, sofern der Agent installiert ist, automatisch gleich einmal eine Standard-Monitoring-Infrastruktur. Also ich sehe hier Disk Performance, CPU, Utilization, Memory, die IOPS, die Logical Disk Megabytes und so weiter. Ein sehr, sehr interessantes Thema hierbei ist auch, Sie haben ja vorher gesehen, ich habe den Microsoft Monitoring Agent installiert, aber auch den Microsoft Dependency Agent. Und das ist ein sehr interessantes Thema. Und zwar gibt es hier den Punkt Map. Und ich kann hier, ohne dass ich recht viel konfigurieren muss und ich muss nur den Agent installieren, kann ich hier automatisch einsehen, okay, welche Incoming Connections sind denn auf meiner virtuellen Maschine gestartet worden. In dem Fall gibt es eine virtuelle Maschine, also eine IP-Adresse, die 172, ich mache das ein bisschen größer, dass Sie es auch sehen, die 172 19 68 99 hat sich auf die virtuelle Maschine auf einen Prozess connected. In dem Fall war das dann ein Windows Operating System Prozess auf SVC Host. Des Weiteren kann ich hier auch dann noch sehen, okay, welche Prozesse nicht nur incoming verwendet werden, sondern auch outgoing verwendet werden. Es gibt hier zum Beispiel einen Prozess, der auf Port 80 auf 2 Server reagiert. In dem Fall ist es rot, weil diese Server 169 IP-Adressen sind, also das wird nicht funktionieren. Aber wir sehen hier wirklich out of the box alle outgoing Connections von dieser virtuellen Maschinen in die Public, also ins Internet danach dementsprechend auch. Gut, ein weiterer wichtiger Punkt kann natürlich auch sein, hier auch dieses Update-Management, wie vorher schon erwähnt. Ich update meine virtuellen Maschinen auch über die Public Cloud. Wir sehen es hier, wenn ich nochmal zurückswitchen darf auf die virtuelle Maschine. Es gibt hier auch bei den Azure Stack HCI Node hier auch das Thema Updates. Und hier sehen wir, dass diese virtuelle Maschine, das werden wir hier gleich sehen, managed in Azure Update and Restarts are managed by Azure Update Management. Also sprich, wir verwenden das Azure Update Management, damit wir auch unsere On-Premise virtuellen Maschinen dementsprechend patchen. Und wir sehen das jetzt hier auch bei dieser einen virtuellen Maschine, dass es hier zum Beispiel 3 Security Updates gibt, ein Rollup, also ein Update Rollup und ein Update und 2 Definition Updates. Wenn ich das alles konfiguriert hat, habe ich auch die Möglichkeit, Inventory und Change Tracking zu involvieren. Inventory ist ein spannendes Thema, dass ich hier auch meine komplette Software einsehen kann. Was ist denn auf meiner virtuellen Maschine installiert? Dann hier auch Change Tracking im Registry-Bereich. Es kann hier auch gewisse Registry Keys, ob das jetzt die vordefinierten Registry Keys sind oder selbst definierte Registry Keys, monitoren, ob da irgendwelche Änderungen gemacht worden sind. Des Weiteren habe ich hier auch Windows Services, die halt eben gemonitort im Inventory drinnen sind, ob die jetzt da vom Startup-Typ disabled sind, stopped und so weiter. Also wir sehen hier gleich einmal eine komplette Auflistung von unseren ganzen Services. Und ganz zum Schluss gibt es hier auch noch Files und das sind Custom-Files. Sie sehen es hier auch cdemo expertslive1.txt. Und ich kann hier natürlich dementsprechend auch draufklicken, wo das drauf liegt. Das liegt auf dem Azure Stack, also HCI, Experts Live VM01, ist dieses File vorhanden und dort wird es auch dementsprechend auch das Inventory integriert. So, und jetzt gibt es hier die Möglichkeit, auf der linken Seite, wenn ich das Inventory habe, auch ein Change Tracking zu integrieren. Und hier sehen wir dann auch sehr, sehr schön aufgelistet, was ist denn auf meinen Systemen verändert worden in der Public Cloud über diesen Microsoft Monitoring Agent. Wir sehen hier auch unterschiedliche Services sind verändert worden. Es sind auch Files verändert worden. Also unser Experts Live Demo 1 File wurde heute in der Früh, um 8 Uhr in der Früh verändert. Das habe ich heute noch schnell gemacht. Und wir sehen hier auch die Changes, die gemacht worden sind. Und zusätzlich habe ich noch eingebunden, bevor etwas geändert wird, dass immer die vorherige Version auch gesichert wird. Also sprich, wir können hier auch eine Sicherung implementieren. Und zwar wurde diese Sicherung auf einen Storage-Account abgelegt. Hier drinnen gibt es einen Container und dort drinnen gibt es einen Container, der heißt Change Tracking. Und hier sehen wir HCLI ist Experts Live VM01. Und hier dann auch die Files, die verändert worden sind von den unterschiedlichen Timestamps her. Also ich könnte hier auch theoretisch hochsensible Daten immer wieder, bevor es geändert wird, beziehungsweise eigentlich jede Version ablegen, damit ich auch diese dementsprechend auch wieder sehr schnell in Zurückgriff habe. Okay. Mittlerweile sollte die virtuelle Maschine auch fertig migriert worden sein. Schauen wir mal ganz kurz, oder ob es noch ein bisschen dauert. Okay, das Starting Failover, es ist noch immer in Test, es ist noch immer in Arbeit. Dementsprechend werde ich jetzt da weitergehen und werde Ihnen auch das Thema Azure Arc noch einmal zeigen, was ich jetzt da implementiert habe. Azure Arc bedeutet, wir haben hier die Möglichkeit, die Services, die ich vorher schon genannt habe, zu implementieren, ob das jetzt der Update Management, Inventory und so weiter ist, aber Azure Arc ist hier auch ganz, ganz stark dabei in dem Thema Policies. Und ich habe hier unterschiedlichste Policies angelegt, wie wir vorher schon gesehen haben, für die Installation von den Agent. Ich habe aber hier auch Compliance Policies integriert. Und zwar gibt es hier eine Experts Live Demo HCI Policy. Und diese virtuelle Maschine ist zum Beispiel jetzt dann not compliant. Warum ist das so? Das ist jetzt keine Policy, das ist eine sogenannte Initiative, also sprich eine Ansammlung von Policies. Und hier drinnen sehe ich alle meine Policies, die ich für diese Initiative gebunden habe, wenn ich hier weiter nach unten scrolle. In dem Fall gibt es hier 49 Policies und 28 Policies sind hier non-compliant. Also es gibt hier zum Beispiel die Möglichkeit auch, dass ich sage, Moment, ich muss ein bisschen weiter rüber scrollen, dass ich sage, so, genau, das hier, Windows Machine that not have a maximum password age of 70 days. Diese Maschine hier, also diese virtuelle Maschine ist nicht so konfiguriert, dass die maximale Alter von dem Passwort maximal 70 Tage sein kann. Also das passt in diesem Fall jetzt nicht. Sie sehen hier auch, das ist jetzt dann nicht nur auf die virtuelle Maschinenhülle gedacht, sondern es ist wirklich ins Betriebssystem drinnen, werden auch die Einstellungen dementsprechend gemonitort. Und wir haben hier sehr, sehr viele Policies, die wir per Default schon verwenden können. Das sind diese vordefinierten Policies. Es gibt aber auch die Möglichkeit, dass Sie natürlich dementsprechend auch Ihre eigenen Policies schreiben und dann auch auf die virtuelle Maschine noch anbringen. So, gut. So, jetzt ist die Frage, ob der Prozess hier jetzt schon fertig ist. Okay, Creating Virtual Machine. Ja, wie gesagt, es ist eine Live-Demo. Die virtuelle Maschine wird jetzt gestartet. Wir können hier in unsere Ressourcegruppe gleich einmal reinschauen. Azure Stack HCI Demo. Es sollte hier jetzt dann dementsprechend bald auch eine virtuelle Maschine auftauchen, eine zusätzliche. Genau, hier haben wir schon die Netzwerkkarte, die virtuelle Maschine, die VM01, die Testmaschine. Diese wird jetzt provisioniert. Sie ist in dem Fall schon running und dann auch in der Cloud dann auch eben zur Verfügung gestellt. Es gibt hier natürlich auch die Möglichkeit, dass wir, wenn wir den richtigen Failover gestartet hätten, dass die virtuelle Maschine, mittlerweile sind wir auch fertig, wunderbar, dass die virtuelle Maschine in der Cloud gestartet wird und on-premise, sofern sie noch erreichbar ist, dann auch noch abgeschalten wird. Okay, gut, was haben wir noch hier im Portfolio? Wir haben hier natürlich bei den virtuellen Maschinen, sehen wir ganz normal auch den Inventory, also wir haben hier auch die Möglichkeit, sich auf die virtuelle Maschine zu connecten. Es gibt hier unterschiedliche Einstiegsmöglichkeiten, ob ich jetzt da direkt mich connecten möchte oder das RDP-File herunterladen möchte. Wir haben hier auch unterschiedlichste Einstellungsmöglichkeiten. Wir können hier die Memory increasen, wir können hier auch den Prozessor erhöhen. Natürlich dementsprechend muss die virtuelle Maschine gestoppt sein. Die Disken können wir verändern. In dem Fall ist auch noch eine ISO-Disk nicht mehr gemountet, also ein ISO-Image nicht mehr gemountet. Wir haben hier auch die Netzwerkmöglichkeiten. In dem Fall habe ich einen Converged Switch integriert und kann hier natürlich dementsprechend auch agieren. Okay, gut. Soweit, so gut von der Demo, von der Live-Demo. Wie gesagt, die Integration mit der Public Cloud ist nahtlos. Also wir haben hier die Möglichkeit, dass wir auch vom Admin-Portal, vom Windows Admin Center direkt in das Azure-Portal switchen, wo wir dann auch dementsprechend auch die Ressourcen konfiguriert haben. Ob das jetzt Azure Monitoring ist, ob das jetzt Azure Site Recovery ist oder ob das Azure Backup ist. So, das war es von meiner Demo. Die Demo noch einmal zusammengefasst. Ich habe Ihnen gezeigt einen Overview über das Azure Stack HCI, über das Admin Center, wo Sie ja dann die Konfigurationen machen können. Wir haben ein Disaster Recovery gemacht, ein Live Disaster Recovery von der virtuellen Maschine am Azure Stack HCI in die Public Cloud recovered. Ich habe Ihnen gezeigt, wie Azure Arc funktioniert, wie auch andere Policies integriert werden können. Ob das jetzt eine Audit Policy ist oder auch eine Installation Policy, wie auch in der Keynote gesehen. Azure Monitor haben wir uns angeschaut, wie wir in die virtuellen Maschinen monitoren können, wie wir aber auch Azure Maps verwenden können, um uns dementsprechend auch die Incoming und die Outgoing Requests anzuschauen. Azure Security Center, ganz ein wichtiges Thema, sind meine Konfigurationen auch richtig gemacht worden, fehlt vielleicht etwas, sind Patches nicht installiert worden und so weiter. Zu guter Letzt möchte ich noch einmal darauf hinweisen, wir als ACB bieten natürlich den kompletten Portfolio an. Also wir haben ganz stark, sind wir ganz im LinkedIn-Bereich drinnen, in Public Azure, also wir von Onboarding bis dem Weg in der Cloud, beziehungsweise Unterstützung bei der Konzeptionierung beziehungsweise Applikationsdesign in der Cloud. Wir können Ihnen den Azure Stack Hub bei uns im Rechenzentrum anbieten, aber Sie auch unterstützen, wenn Sie das in Ihrem Rechenzentrum implementieren wollen. Zusätzlich bieten wir jetzt auch in unserem Portfolio an das Thema Azure Stack HCI. Entweder Sie kommen zu uns und konsumieren den Azure Stack HCI oder wir unterstützen Sie auch bei der Integration bei Ihnen in Ihren Data Center oder aber auch im Branch Office. Also wir bieten hier von Consulting bis Managed Service alles rund um das Portfolio an. Von meiner Seite auch nochmal ein Danke an die ganzen Sponsoren, natürlich wir auch als ACB, dass sie halt eben diesen Event ermöglicht haben. Und dementsprechend möchte ich jetzt auch in die Q&A, sofern noch Fragen aufgetreten sind, wechseln.
Hallo Hannes, na, momentan in der Q&A sind keine neuen Fragen.
Okay.
Ganz allgemein, wie oft hast du schon bei so einem Online-Event vorgetragen? Wie war das Gefühl heute?
Ja, also Online-Events waren mittlerweile natürlich jetzt schon mehrere. Also geht ja nicht anders, leider Gottes. Also wir sind natürlich In-Person-Events weitaus lieber, weil ich dann auch gerne die Diskussion nachher suche, auch die persönliche Diskussion. Grundsätzlich super organisiert, also hat wirklich gut geklappt. Am Anfang kleine Schwierigkeiten mit dem Audio. Ja gut, das kann halt passieren, aber sehr, sehr toll. Also wirklich super gemacht. Ich glaube auch, dass sehr, sehr viele Teilnehmer sind. Das macht Spaß.
Ja, okay. Gut, dann lasse ich die Teilnehmer in die nächste Kaffeepause. Also wir haben uns ja ganz bewusst dafür entschieden, zwischen den einzelnen Sessions immer wieder 10 Minuten Pause zu lassen, damit man das heiße Ohr als Teilnehmer sich ein bisschen wieder kühlen kann. Ja, gleichzeitig gibt es natürlich auch die Teilnehmerlobby, auf die ich extra noch einmal hinweisen möchte. Und natürlich auch unsere Sponsorentracks. Falls irgendwer also speziell noch Fragen oder Anregungen für die Sponsoren hätte, und sage recht herzlich Danke für das Ganze. Und ja, wir haben jetzt wieder 10 Minuten Pause, bis der nächste Track oder die nächste Session dann beginnt.
Businesses are rapidly adopting cloud computing, taking advantage of its flexibility and speed. Whether consuming SaaS applications, building cloud-native applications, or migrating existing applications to the cloud, finding a security solution that addresses a diverse set of needs is critical. Fortinet Cloud Security Solutions deliver. Get the confidence you need to deploy any application on any cloud supporting any initiative. Fortinet supports all major cloud providers, ensuring that critical assets are secure and that security is manageable. The Fortinet 3-pillar cloud security strategy provides the same level of security across multiple clouds by natively integrating security into the cloud platform, defining security policies for cloud services, and leveraging cloud services for security, ultimately enabling automation of security services. Fortinet provides the industry's broadest set of cloud security products, enabling you to use the same security in the cloud as you have on premises. By using purpose-built security tools in the cloud, you'll save time by leveraging existing skill sets. By managing security across multiple clouds through a single pane of glass, and by automating the security lifecycle management, you can better leverage existing skill sets and accelerate the confidence to deploy applications anywhere. From consuming cloud applications to building applications in the cloud and migrating IT to the cloud, Fortinet Cloud Security Solutions cover the broadest set of use cases, delivering the flexibility and confidence to use the cloud in a way that best serves your business.
Helmut, can you see my screen?
Yes, I can see your screen.
Okay, thanks.
Yeah, great. A bit early, so we have still 2 minutes. How do you like the event so far?
I'm pretty impressed. I like it very much. Unfortunately, there is some overlap with my session, but it's all fresh content, so that's always the case, right?
Yeah, it's something you can't really hinder, and we really tried to focus this event also on Azure Stack HCI, especially because of the general availability end of December. And since we are one of the first events here in January, it was a great possibility to present all of the new features. But at the end of the day, yeah, that's why we have some overlaps.
Yeah, but I will add my knowledge and my opinion, of course, to the features that are double. So will you moderate the Q&A? I will be in the Q&A too.
Yeah, I will moderate the Q&A. So if questions came in, I will ask you it at the end of the session for you, and answer what I can with my humble.
Yeah, and I'm the last session before the lunch break.
Yeah, afterwards we go into the lunch break, get some food, and hopefully come back then at 1 o'clock with some fresh power. But now I'm really proud to announce Mr. Carsten Rachfahl with Azure Stack HCI, the good, the bad, and the fantastic.
Yes, thank you, Helmut, and thank you to all the Experts Live team members to having me presenting at this event, and also for doing such an event. I know it's hard to do 3 teams sessions in parallel, and I'm looking forward to do that as well in Germany. So my name is Carsten Rachfahl. I'm Microsoft Cloud and Data Center Management MVP. I call this group the Cloud and Data Center Management Group, the on-premise group, and I'm also an Azure MVP. I'm an MVP for 10 years now, and maybe I will get my 11th award in summer. I hope so, but we will see. My blog is Hyper-V Server.de, and I will have some extra information where you can find more what I'm doing and more information about Azure Stack HCI at the end of the presentation before the Q&A. But let's dive directly into the presentation. So let's start with the good. And the good, the bad, and the ugly is normally the title of a very good movie. Most of you maybe know with Clint Eastwood, and I changed it to the fantastic because we have only some bad things, but there are, of course, some things we have to discuss about in Azure Stack HCI, but it's not too much. So I will start with the good part, then with some bad part, and then with some fantastic stuff. As Cosmos already mentioned, Azure Stack HCI is its own operating system. So it's not Windows Server, it's not Windows Client, it's its separate operating system. In the moment, we have a huge overlap with Windows Server. It's not completely new, so they took the best parts of Windows Server and made a new operating system that will drift apart from Windows Server further and further as time goes on. And I think you know Windows Server has an update cadence every 2 to 3 years. So we get a new version of Hyper-V, RDS, Active Domain, whatever you have in Windows Server. It's a large product of very different kinds of services. We get it only every 2 to 3 years, and that's a bit long for something like an hyper-converged infrastructure solution. So Microsoft now has Azure Stack HCI, and they promise that we get at least one new version every year. And maybe there are more. So we have a specialized operating system. It's only the core version because you should not do much stuff on the console with an Azure Stack HCI host. You should manage it remotely. And I strongly recommend that you install it in English and not in German. There is unfortunately a German version available, but in my opinion, and most people know me, I have strong opinions. In my opinion, you should install the English version, so it's much easier with support personnel. And we heard in Cosmos' presentation, there is an Azure support for Azure Stack HCI. So I think English is much helpfuler than other languages. Then we have a great integration in Windows Admin Center. You could say the Azure Stack HCI part is really purpose-built for Azure Stack HCI. So great solution here. Not everything is possible yet with Admin Center, but a lot of it is possible. And what I like very much is the cluster creation wizard. We have it here, and I have a demo about the cluster creation wizard, how you create an Azure Stack HCI cluster with the Azure cluster creation wizard. So let's look into it. It's around 5 to 6 minutes. I have speeded up a lot, so let's talk about it. I'm here on Windows Admin Center system, and I start the create new cluster. And we have two options here. We want to create an Azure Stack HCI cluster, and here you see the wizard. So I will authentify myself, and I will add 4 nodes here, and these are virtual machines. So you can install Azure Stack HCI in a virtual machine and play with it. That's, I think, a good thing. And he will join to a domain. The systems are already joined, so I have nothing to do here. Then it will help me to install the required features. So I click install here. I speed it up 10 times, so we don't have to wait too long. It will install data duplication. Hyper-V is already installed, a BitLocker, data center bridging, failover clustering, an Active Directory module, and an Hyper-V module. After that, it will look for the newest operating system updates. And it's always good to install the latest updates before you install a cluster or storage on Azure Stack HCI. So this is also very speedy here. Then we look for a solution update, and about the solutions, also a very great thing. I will talk a little bit later. So then we have to restart the servers. It will wait for the restart. And when the servers are there, we have finished our first part, the get started part, and we will go to networking. These machines have 5 network cards, and we will see them soon. So I have 1 management adapter, 2 SMB adapters, and 2 adapters for the virtual machines. So first I have to choose an adapter where I manage the system with. I have only 1, so I didn't do the high available solution. So I tick each adapter on each host, and then we go to next. And here you see there is a network test included. So Azure Stack HCI want to see if every network adapter can communicate to every other network adapter in the cluster. And for that, we have to do some IP, give them some IP addresses so they can try it. Here in advance, we can mess with jumbo frames if we want to, and then we apply it. And this is already speeded up because this takes a while. But when it successfully connects each adapter over each network, we can go on to the switch configuration. Because this is a hyperconverged setup, we need a switch. And I like the second scenario most, where you have 2 adapters for the switch and 2 separate SMB adapters. But other scenarios are also available. So I tick now every adapter that should be included in the virtual switch, and I named them VM switch NIC 1 and 2. And here we can change the name of the switch. If you don't like compute switch, I take it, and the load balancing algorithm for the set switch. You should go with Hyper-V port, and that's the default here. Now we finished the network part, and we will go into the cluster creation. So first we will validate our cluster without the storage spaces direct part, because storage spaces direct is not yet implemented. And it's very important that you see this CRED SSP message that we had before. If you don't get that, Azure Stack HCI can't be installed, or the cluster can't be installed over the Windows Admin Center. There are some confusions with the versions there. So this is 2009, so the version from September 2000. It works best with virtual machines. And here we see we can download a cluster validation report, and you see in this scenario everything is dandy. We have no errors here, as it should be. Sometimes we have some system configuration errors, or not. The patches are not all the same. So I can now create the cluster, and I give it a name. It's called Azure Stack HCI 3 cluster. And under the advanced settings, we can specify, for example, an IP address. And I prefer that, not to use DHCP for the cluster. I like my cluster with a dedicated IP address. You can specify it here, and it's done. The cluster is created now. And the last part, or the second last part, is storage. You can erase all the drives, and that is usually wise to do that, so that every drive is empty. But I have a 60, so I have an additional drive at the first node. You see it here with 40 gigabytes. So I didn't delete them, because on the drive is a lot of stuff I like to use, like VM Fleet, a benchmark VM, and so on. So I don't clean them, but usually you should do that. Then Azure Stack HCI, the storage part, checks every device on every node and give you a report. Everything is fine here. This is a cluster validation for the storage spaces direct. And after that, we can enable storage spaces direct. That takes some minutes, maybe 1 to 3 minutes, depending on how much devices you have. And then we are golden. And in the last part, you can create SDN, but we will skip that because it takes a while. So now we are in Windows Admin Center. You see here the nodes are added to Windows Admin Center. And if I click on the Azure Stack HCI 3 cluster, it will connect to the system for the first time. And here we see the dashboard we have seen in the last presentation. Just a minute. Okay, so, and here is our cluster. It's empty. We don't have created volumes, but we can now start creating volumes, deploy virtual machines on it, and so on. So the next thing that is it's a good thing is the switchless design. So what is a switchless design? If you have a small storage spaces direct implementation, so let's say 2 nodes, you could do a switchless design since Azure Stack since Storage Spaces Direct was available from 2016. But with more nodes, Microsoft was not so sure about it. And last year in November, no, it's 2 years ago. In November 2019, at the last Ignite, that was an on-premise event before the pandemic, they announced that they now also support more than 2 nodes in a switchless design. But what is a switchless design? So normally we have, of course, our network adapters for the virtual machines, for the connection to the Active Directory, where you back up your systems over from external. So here they are called external adapters, because you want to communicate with your VMs from your notebook, from receiving mail or whatever, or backup to Azure, or monitoring from Azure. This is done over the external adapters. If you add additional adapters into the system, here, for example, a 2-port NIC, you can also do a 3-node cluster, and every node has to be connected to the other cluster node. So here in this example, we see 1 connection from the first node to the 3rd node, and 1 connection from the first node to the 2nd node, and 1 connection from the 2nd node to the 3rd node. So that's possible now. And it's also possible now to do a 4-node cluster in a switchless design. So here again, we have 3 ports because we have 3 other nodes that we connect directly to. But I don't like this design with only one port to each other host. I prefer to do a full meshed with dual link. So in this example, we see the 3 nodes connected with 2 ports to each other node. So now we need already 2 NICs in each node for the interconnect between the hosts. And that's also possible with 4 nodes. So here I have another schema how you can do it. So here you see 2 connections from this node to this node, 2 connections from this node to this node, and 2 connections from this node to this node. So with 4 nodes, you need already 3 dual port adapters to connect 4 nodes with redundant connections. But this is not the end. Microsoft goes one step further, and they also support 5 nodes directly connected. And for that, we need 4 NICs, 4 dual port NICs in each server. Now we have some problems with PCI slots in the servers because they are not endless. So 4 dual port NICs that are 4 PCI slots that all have to be placed with network cards, and that's a lot. But it's supported. It's supported in Storage Spaces Direct, and it's also supported, of course, in Azure Stack HCI. And I like that because we have a lot of problems with networking, especially if we use RDMA. I will talk about that a little bit later. So this helps to simplify the designs, and also it drives down costs, especially in 2 nodes or 3 node scenarios. I have not done a 4 node scenario yet and a 5 node scenario, but it is also possible. Then Azure Stack HCI, it's also a good thing. You only pay for that what you have. So it's subscription based paid, and you also have, let's say, you have the right to always to use the last version. So it's like the software assurance is included. So if Microsoft releases a new version of Azure Stack HCI, let's say Azure Stack HCI 21H2 in the end of this year, in the second half of this year, and you have your subscription, you are allowed to update it. And in fact, you maybe have to update it to the newer version, because Microsoft is doing support here, and they will not support a 3-year-old version with H20, so 20H2. They assume that you are on the last version, or maybe at the second last version, but they will not support it back to 3 years, 4 years back. So that's also something you have to do, because it's a subscription and you get always the newest stuff with the newest features. That's great, but you also have the obligation to update it frequently. So the costs are scalable, and if you know the licensing from Storage Spaces Direct, it's in the Windows Server Data Center license. There will be a slide about that a bit later in the bad part. You have to license at least 16 cores, or there is a special version for very small systems that you can buy over an OEM with the system with 8 cores. But usually you have to license 16 cores. And with Azure Stack HCI, you can also license 8-core machines. And the sponsors have some of those. I know Thomas Gren has some of those, and SecureGuard has some of those nice little solutions with less than 16 cores, and they are much cheaper now with Azure Stack HCI as if you have to buy a data center license for that, or even with 4 cores. So you pay for the cores that are in your hardware servers, and you pay $10 per month. Including the subscription of the operating system. So that was some good stuff. We come to the fantastic stuff a little bit later, but now let's look at some things that are maybe not so nice or not so good, that are maybe bad. So again, the Azure Stack HCI subscription billing for Azure Stack HCI. It's a subscription. You have to pay for it every month. So you have costs every month. They are adding up. If you use your system for 5 years, they add up. If you do Storage Spaces Direct, you have one-time costs. Maybe with software assurance, you have additional costs, of course, but in Azure Stack HCI, they add up. And let's look about it. So first, storage spaces direct pricing. So storage spaces direct with Windows Server 2019, you pay once upfront. I would say if you buy a 16-core data center OEM license, it's around 4,500 euros, maybe 4,200, 4,300, 4,500. Doesn't matter really, but you pay for 16 cores 4,500 euros. And the Windows Server VMs are included. So every Windows Server VM that you put on an Storage Spaces Direct cluster is licensed through the data center license that is attached to the host. If you want to have newer versions, you can also buy software assurance, and you have to pay for a 16-core software assurance roughly 3,100 euros. It's not dollars, but you don't have to, because I don't know if there will be new stuff in Storage Spaces Direct vNext in the next version of Windows Server. That's a question we have for Microsoft, and I fear there will be not new stuff in Storage Spaces Direct in Windows Server vNext. All the new stuff is going to Azure Stack HCI. So maybe you don't need the software assurance here. On the other end, Azure Stack HCI pricing, you pay every month per core for 16 cores. That's 16 times $10. So that's $160 per month. That's $1,920 per year. It includes no Windows Server VMs. So if you want to put Windows Server VMs on top of your Azure Stack HCI cluster, you have to separately license them. Maybe with the standard edition, that's possible, Windows Server Standard, if there are only a few VMs, or if you want to put a lot of VMs on that Azure Stack HCI design, you need Windows Server Data Center licenses. But maybe you have it already. Maybe you want to move from an Hyper-V cluster with 2016 to Azure Stack HCI, but your VMs will not be updated to Windows Server 2019. They stay at 2016. So you can use your license from the Hyper-V server and put them on Azure Stack HCI. If there are volume licensing, in Germany, you can also transfer OEM licenses. So maybe you don't need Windows Server 2019 in the VMs or the next Windows Server. So you now have Windows Server 2019, but you don't want to have Windows Server vNext in your VMs. The good thing is new versions are included. So if there is a 21H2, a 22H2, and so on, you always have the right to use the newest version. So here I have a calculation for, let's say, sorry for the Spalte, it should be column. No, row, sorry. What costs, what is the cost when you buy it in the first month? So then after 12, 24, 36, 60 months, so that's 5 years. That's usually the time you should use your Azure Stack HCI cluster, because the hardware and the flash devices get old. So don't use it for 10 years, for example. But with Storage Spaces Direct, if you don't buy software assurance, you have for your node, a 16-core node, 4,500 euros. So after 16 months, you have 4,500 euros. If you buy Storage Spaces Direct 2019, so the Data Center Edition with software assurance, you have in the first year 7,600. We have to add 3,100 euros to the initial price. So, and there is, I think, a calculation error, or no, it's 7,600. After 2 years, you have to rebuy the software assurance, and after another 2 years again. So your server will cost after 5 years with all the newest software that is available for the VMs and for the host, 13,800 euros. On Azure Stack HCI, we have roughly $160 a month. I converted it to euro, the price from yesterday, the conversion course. It's 130 euros. And after 60 months, we have 7,900 euros. It's already more expensive than Storage Spaces Direct, but the operating system is not included. So if we add a data center OEM license to that, we are at 12,000 euros. And if we add software assurance to that, we are at 21 or 22,000 euros. So this is a huge difference. And if the new features are not for you, if you don't need the new features, I think a lot of customers will still buy Windows Server Data Center with Storage Spaces Direct. And the good news is in vNext, we will still have Storage Spaces Direct. So you can use it. Of course, you get some interesting things with Azure Stack HCI, new features, and maybe you're thinking about hosting Linux VMs or hosting Kubernetes with Linux VMs. For that, you don't need a Windows Server licenses, or you want to do VDI. And I hope that the graphic support in Azure Stack HCI will improve in the next version. We don't know yet, but I hope so. So then you can maybe use Windows clients VDI on Azure Stack HCI, and client VDI has to be licensed separately anyway. So you can use Azure Stack HCI and add the VDI licenses to it, or Linux, and then you have your system. A very nice price if you look at the competition. But with Windows Server, on top of this as VMs, you have to think about it. Another thing you have to think about, you need knowledge. And it seems so easy. Click through the click-through cluster creation wizard. And of course, I showed a demo. It seems so easy, but you still have to have some knowledge. So if you, especially networking is the core part of Azure Stack HCI, and we see a lot of problems in networking. And I speak out of experience. My company has done over 300 installations. Maybe we're at 500 now. So we know where most of the problems that customers are who don't have maybe the knowledge, who think, oh, this is easy. I saw it. It's so easy. I click through, and even in the newest admin center, you can configure your RDMA with admin center, with the agent. So, but you have to have some knowledge here. And the handling, yeah, you have to patch the system. Maybe you want to extend it with another node, or when you have a failure, you need knowledge to have an HCI solution running. And that's true for every HCI solution. Nothing is as easy as a Windows client, let's say that. Training, another bad thing. There is not really training from Microsoft. I know of one PFE who's doing a PFE-led training for Microsoft Premium or Unity customers. You can use your Unity or Premium support contract hours to have a training. But not many people have this Unity contract. So no Microsoft training for you. You have to depend on external training. And I'm doing Storage Spaces Direct training now for 4 years. I know there is not so much training out here. I heard last week there is a 3-hour online training available, but to be honest, I have a 5-day course about Azure Stack HCI and Storage Spaces Direct, and I don't come through all the stuff you have to know. So what can you do with 3 hours? Tooling, it's also a bad thing or a good thing. I'm not so sure, because Microsoft would say, marketing would say, you have choice here. So you can use Hyper-V Manager for Azure Stack HCI. You can use the failover cluster manager for Azure Stack HCI. You can use PowerShell for Azure Stack HCI. And you have, of course, Windows Admin Center. And one thing I have not on the slide is Azure. Azure will also be added, or there will be scenarios in Azure added. We saw it in Cosmos presentation, where you can manage Windows Azure Stack HCI. It is an Azure product. So you can say you have choice, but I have to be honest with you, you must use different tools. You can't do everything with Windows Admin Center yet, or maybe never. You have sometimes to go to PowerShell or to a failover cluster or to Hyper-V Manager. So this is a thing that is could be better. We could have everything in Windows Admin Center, but this is a long way to go for Microsoft. RDMA, I told you already. RDMA, it's a fantastic thing if it's right, if it's rightly done. SMB3 with RDMA, it's amazing, but to be honest, Rocky, that's one RDMA dialect over Ethernet. You have a lot of complexity. You have to configure PFC and ETS. That's some features in enterprise switches. So you have to have enterprise switches if you want to do Rocky, and you have to configure them. It's not enough to have enterprise switches. You have to configure them. So this is why the switchless design is very interesting. You don't have the switches. There's another dialect called IWARP, but we don't have really choice with IWARP. There are three vendors who have IWARP. It's Intel, it's Chelsea, and it's Marvell. Marvell, formerly known as QLogic. I can strongly advise you to not use Intel IWARP. Chelsea is not available really in Europe, so we have only one choice. It's Marvell. And if you do high performance IWARP, let's say 100 gigabit, you would be very wise to also configure PFC in your switches. Finding errors with RDMA is a nightmare. There are not much testing tools. There are barely counters in Pathmon. One of the best companies here is Mellanox with a lot of counters, maybe too much counters. And also Marvell is doing a great job with counters there. But you need counters. And in my experience, more than 70% of the problems with an Azure Stack HCI cluster and a storage basis direct cluster has its roots in networking, because it's so essential for the solution that we have the interconnect, the east-west network. It has to be flawless. There can't be much error here, because it is your storage system. It is your storage system. And if something goes wrong, you have to restore maybe 30 terabytes, 50 terabytes, 100 terabytes, maybe only 10 terabytes, but you have to restore it, and that takes time, and that's not a good thing. But let's leave the bad part and go to the fantastic part. So fantastic. We heard it already from Cosmos, Stretch Cluster. Stretch Cluster is now available in Azure Stack HCI. It's something the Germans, at least here in Germany, and I think the same is in Austria and in Switzerland, they love to stretch the clusters over different rooms or different places. So it's possible. We heard it already from Cosmos. It's possible now. It's supported. You have to start with 4 nodes. The data is really local here. So we have a two-way mirror on nested resiliency here with 4 nodes, and we have the data also here. So we have, if we have, for example, a 4-way mirror here, a nested mirror, then we have 4 copies here. We have another 4 copy of the data here. So we have to be clear. If you have more copies of your data, you need more storage and it's more expensive, but you can stretch it and you can use synchronous replication, or if you ever would span a cluster from London to Paris, that's several hundred, maybe 1,000 kilometers, I'd say 700. You can't do synchronous replication. You have to use asynchronous replication. It's also possible. Yeah. So quite a great solution here. We are waiting for that for a long time. If you need storage replica, Azure Stack HCI is for you. Then we heard about the fast repair in storage basis direct, and fast repair is not really a thing if you have a 2-node cluster with 5 terabytes. It's not a problem. But if you have larger installations, it takes a while, especially if you have something involved like double parity. So if you have a mirror accelerated volume, double parity is involved, and if it's large and if it's more nodes, then the repair takes a long time. And they worked on that. So you have to know in Storage Basis Direct and in Azure Stack HCI, we talk about extents. Our data is spread over the host in extents, and an extent is at least 256 megabytes. And let's do the animation again. If in Windows Server 2019 Storage Spaces Direct and in Windows Server 2016 Storage Spaces Direct, if you write into extent and a copy is not available because you are patching a host, you are shutting down a host or rebooting a host, the devices in that host are not available, so we can't copy data on it. And if the data has to go there, so we update an extent on another node and we can't copy the extent to the host that is not available in the moment, it gets to be resynced. And Windows Server 2019 Storage Spaces Direct has to resync the whole 256 megabytes. Also, if only 4K are changed. So we have to copy later 256 megabytes. And that's a lot of repair traffic. So Microsoft improved that in Azure Stack HCI, and they do sub-extent dirty region tracking. I don't know how large this region is. This is not a 4K region. I assume it's a megabyte or 4 megabyte, but to resync, for example, a 4 megabyte region instead of a 256 megabyte region, that goes much faster. And for that I have a demo. So here we are on an Storage Spaces Direct system. I have here running a PowerShell script that shows me all the virtual disks. They are all okay here, and if there are storage jobs, they are also shown here. But in the moment, we don't have running storage jobs. And here we see we have a VM fleet running. This is also a virtual environment, so we only do 300 IOPS per VM, and I have 12 VMs running, so roughly 1,800, 900 IOPS per VM. I have a stopwatch here, and I will start the video. So I go to one of the nodes, and I will turn it off. No shutdown, I turn it off and I turn it on. And you see the watch is running. We see here the storage job. This is 7 times faster than in reality because I don't want to bore you here. So we will slow down when we really come to the moment where the repair is starting. So you see here a lot of moving, and around 5 minutes-ish, 5:20, 5:10, the repairs jobs will start. So the repair jobs don't start immediately. They wait a time. So you see them here. They are suspended in the moment. We see the virtual disks that are degraded, and now they are in service. So now I slow down the video. We see all the repair jobs, and we see all the virtual disks here in real time. Now the repair is running, and here we see how many data has to be repaired. How many gigabytes? It's a small deployment, of course, in virtual machines. But I have seen here even terabytes of data that has to be repaired in a larger environment because of the huge 256 megabyte blocks. So now we have 2 volumes repaired and the others are going. We will stop at around 6 minutes something. So bear with me. So it's nearly finished. So you see here, I'm moving to the lab thing. 6 minutes, 20, 22. Now we are nearly done. Only 1 volume has to be repaired. It's a node 1 volume. It's at 77%. 85, 93, so nearly done. 98, and now it's done. So we have 6 minutes and 50-ish seconds, 51. So now we see an Azure Stack HCI cluster. I do exactly the same. I restart one of the nodes. We have exactly the same setup. You see the same script running here. I'm on the console of one Azure Stack HCI node. You see I have a RDP session here. I have to restart the watch cluster here because if it gets too much errors, it will not read it. So you see we have still 6,000, 7,000, 8,000 IOPS. The repair is not started yet. It will start also around 5 minutes. So that's the same with Azure Stack HCI. But if you look here, the one volume that was lost during the turn off of the Azure Stack HCI node is already repaired. So that's very fast. And now it starts repairing. You see there's one in service already. Here we see now 49, 69. Oh, I have looked at the time. It's already, I've only 9 minutes left. So let's come to the conclusion. Where is it? So we see here at 6 something we are done. Let's go to the next slide. I have a recap of this. So the fast repair results with Azure Stack HCI at 6 minutes and 6 seconds we were done, and we started at 5 minutes 21, that are 45 seconds. And here with a storage basis direct, it's 87 seconds. So the repair is nearly double the time, even in the small environments, if we count it from the start of the repair to the finish. So they start around the same time here, and Azure Stack HCI is much, much, much quicker. And imagine you have a larger design. It really saves you a lot of time. Patching and so on is much, much faster. So we talked about this already. Azure Stack HCI is covered by Azure Support. Storage Basis Direct is not. Storage Basis Direct, if you want support, you have to do the incident-based support and pay for it, or you have to have a premium support contract, Unity support contract, and you pay upfront, and it's not cheap. So Azure Stack HCI starts at $29, but this is more marketing because $29 is for the developer support, and you are not allowed to do production with your developer stuff. So you need the standard support, but Cosmos mentioned it's around $100 for your whole subscription. So you can have multiple Azure Stack HCI systems in your subscription. And you pay $100 per month or $1,000 a month if you need a very critical support with. So look at Azure.com support for the information. I think the $100 support is enough, but if you need more, you can have. Then performance. Performance in Azure Stack HCI is at least the same as in Storage Basis Direct, and it's amazing. And only a hint here, Storage Review, it's an independent third party. It's not Microsoft. They tested and measured the performance of an Azure and Storage Basis Direct 2019 system and vSAN on the same hardware, and it was multiple times faster than vSAN. I think 4 times faster. And I have never seen a faster system for a smaller price than Storage Basis Direct. So you never have to care about really performance if your application needs the performance. So here I have another video for you. This is a setup with 4 nodes, all NVMe, and you see here the CPUs in Task Manager. They are all at 100%. You see here, this is a VM fleet running with 120 VMs. We are creating nearly 1 million 8K IOPS. We have 70% read, 30% write. So we move 8 gigabytes of data per second. And I have a mirror accelerated parity here. So we also have a volume that has double parity and the mirror. And if you look here, you see it. While we're doing this test, there is data moved from the performance tier, the three-way mirror, to the double parity tier. You can see that here on the right. We have 8 megabyte write here. And in addition to the 120 VMs that are killing the system, I have another VM running with an IO meter in it, also doing 8K IOPS, and I get another 15 to 30,000 IOPS here. So let's do the video. It's very fast. You see here. Here you see the data is moved. We see 13 megabyte, 15 megabyte, and we see 1 million IOPS. And that's a 4-node system with NVMEs. Never seen such an amazing performance with any other system. So let's go. This will not, okay. So then we have something, because Azure Stack HCI is included in Azure. It is Azure. And in Azure, you have the extended support for Windows Server 2008, 2008 R2, SQL Server 2008 and 2008 R2. So you can get security fixes for your VMs that run Windows Server 2008, 2008 R2 on your Azure Stack HCI. You get the security fixes for free. You don't have to pay for them. I think that's a nice thing that we get with Azure. Cosmos talked about this integrated full stack update, and if you have seen the video, there was a solution update. So this will be the solution update where the firmware, the drivers for your solution from the hardware vendor will be installed over Windows Update. We see that. We have seen this slide from from Cosmos. They are moving more and more Azure services will include Azure Stack HCI, and Cosmos said there will be some services free, like in Azure. I have to look into that. I'm very interested in that. So they have huge plans for Azure Stack HCI in Azure. And we saw this at Cosmos presentation, self-service VMs from Azure to Azure Stack HCI or on premises. The feature is not here yet, but I'm very curious about it and I can't wait to test it. And then, of course, Azure Kubernetes services, so Azure AKS for Azure Stack HCI. And this is really huge because a lot of services in Azure are in containers, and more Azure services are in containers, and they use the Azure Kubernetes services. And we have now Azure Kubernetes services for Azure Stack HCI. So you get the I can't do this word. And the data services, the connective services, and more are coming. And Microsoft cares about the VMs with the Kubernetes part in it. So with an update, you get the newest AKS on your site. And of course, the native integration with Azure. So normally, no, let's go back. You have your on-premise services. They are on-premise. Your servers, they have to be connected to Azure. We saw that in Cosmos presentation. And you can see them in Azure. More is coming, and you have to register them. If you don't register your servers in Azure, you can't deploy VMs there. So let's have a short demo. I'll go to the demo. Let's see. Where is my... Here we are. So here I'm on the host you have seen before. It's registered in Azure. You see that here. It's clustered, it's registered in Azure with my subscription. And if I open, oh, the portal is not here yet. I hope I have not to re-log in. It's a mess for me because I have multiple Azure accounts. So where we are, let's look at the resource groups. I hate it. Always the wrong directory. Always my Microsoft directory, of course. So let's go to the portal again very fast. You see here, I have an Azure AZHCI3 cluster resource group, and in that is my Azure Stack HCI cluster, and it's registered in East US. That it's also available in Europe, so we can register it in Europe. We see our 4 machines, we see the memory, we see the cores, and they have 4 cores actually, so something is wrong with the counting here. And more is coming, so I'm really eager to play around with Azure and Azure Stack HCI. Let's see. So coming back to the presentation, there is, of course, more information. So you have my blog. I have a newsletter. I do regularly webinars about Hyper-V and Storage Bases Direct and Azure Stack HCI. So here is the link for the newsletter. If you register here, you get informed if there is a new webinar. I want to give you this URL because we did an Azure Stack HCI day in November with 11 Microsoft product managers. Helmut was also there helping a lot. Thank you, Helmut, for that. You see here a lot of presentations about Azure Stack HCI. And if you want to have more information, go to azurestackhciday.de. All the recordings are available and look there. And I have a course if you are interested in an S2D and Azure Stack HCI course. It's powercourse.net. Look there. The new schedule for 2021 will be there for next week. If someone is interested, we will have a course in KV6. It will be soon there. And I also do a conference. But now let's go to the questions. Do we have questions in the chat? I see one question from Rainer. If you have more questions, please do. Rainer is asking, is there an eval version of Azure Stack HCI available? Unfortunately, not. You can download Azure Stack HCI. It's free, and then install it. But you have to register it in Azure. It's free for the first 30 days, so you don't have to pay for it for the first 30 days. But you have to register the version. And then you can use it. I'm looking for an eval version because you have to play around with the stuff, really. So
but you still can use your free Azure credits for it. So if you do it on a low core machines, then you can get over with some free Azure credits, whatever possibility.
Yeah, but you know, the $150 credits are very, very fast gone if you.
I know, yeah.
You know that. Okay, so let's thank the sponsors, and I know how important sponsors are. You make these things possible. So thank you for all the sponsorship. If you have more questions, you can tweet me at hypervserver, and I'm still around, so to answer your questions. And thanks you guys for watching this. So and now we have our lunch break, right, Helmut?
Yeah, thank you, Carsten. And now we have an 1 hour, 10 minutes lunch break, and start over again at 1 o'clock afterwards. And yeah, I really appreciate all efforts of the different speakers and so on. Okay, and see you or hear you in 1 hour 10. Thank you.
Businesses are rapidly adopting cloud computing, taking advantage of its flexibility and speed. Whether consuming SaaS applications, building cloud-native applications, or migrating existing applications to the cloud, finding a security solution that addresses a diverse set of needs is critical. Fortinet Cloud Security Solutions deliver. Get the confidence you need to deploy any application on any cloud supporting any initiative. Fortinet supports all major cloud providers, ensuring that critical assets are secure and that security is manageable. The Fortinet 3-pillar cloud security strategy provides the same level of security across multiple clouds by natively integrating security into the cloud platform, defining security policies for cloud services, and leveraging cloud services for security, ultimately enabling automation of security services. Fortinet provides the industry's broadest set of cloud security products, enabling you to use the same security in the cloud as you have on premises. By using purpose-built security tools in the cloud, you'll save time by leveraging existing skill sets. By managing security across multiple clouds through a single pane of glass, and by automating the security lifecycle management, you can better leverage existing skill sets and accelerate the confidence to deploy applications anywhere. From consuming cloud applications to building applications in the cloud and migrating IT to the cloud, Fortinet Cloud Security Solutions cover the broadest set of use cases, delivering the flexibility and confidence to use the cloud in a way that best serves your business.
Hello, everybody, just after lunchtimes. And I hope everybody had a great lunch, is ready for our next session. I proudly present Bartek from Fortinet, who will tell us something about security and resilience in hybrid cloud networking, while maintaining performance even in a hybrid world. So I'll give over to Bartek and have a good session. We don't get your audio at the moment, Bartek.
Is it better now?
Yeah, it's much better now, yeah.
Okay. Now it's working at least, that's fine. All right, so welcome everybody. Thank you very much for inviting me and for the opportunity to tell you a little bit about the networking. As I was already introduced, my name is Bartek Moczulski and I am the consulting systems engineer in the public cloud EMEA team at Fortinet. Pretty long title, but that's how it is. I deal with cybersecurity for a pretty long time, will be quite almost 15 years, I guess. And for 6 years, I'm working with public cloud. So I will be giving you a network security person perspective to the public cloud, to everything that changes. When I started many years ago, it was really easy and really primitive, I would say, what was happening in the cloud. We didn't even have custom routing in Azure. So it was there was no Azure marketplace even. So it was really we felt like cavemen reinventing the fire. Now it's of course very different. Right now you've got a marketplace with thousands of different solutions. Now you've got a lot of tools for the networking natively from Azure. Of course, we've got UDR, which is an obvious thing right now. We've got standard load balancer with HA ports, which helped our customers a lot. We've got right now the virtual one, which is a great product directly from Azure, but like still there is some security part which can be added to this. So the things really change rapidly in the public cloud, and depending when you started, if it was just a year ago, maybe last week, or a couple of years ago, you see that the pace of changes in the public cloud is really great, and you have to constantly learn new things and constantly adapt to it. So this is enough of an introduction, and let's start talking about security itself. So what is security in public cloud, and what does it mean, and what is the perspective from the infrastructure and network itself to the security? When you start reading about security in public cloud, well, right now you already find normal texts which are real life problems, but several years ago, you were mainly reading about, oh, you have to take care of SLAs, you may have to make sure that your contract with a cloud provider is intact. Well, good luck for everyone who is working for a big enough customer to negotiate contract with Azure and TNCs, but normally you just accept what is given to you. So what really is security in public cloud? Actually, the threats are still the same. So if you look from the perspective of the security theory, still confidentiality, integrity, availability is the thing that you're taking care of, right? Just for a little bit more new challenges and new ways to protect against the same old threats and the same old bad guys that we had out there. So external actors, internal actors, that try to get something that they should not have access to, or damage something that they should not be able to damage. Of course, availability is the easiest to fix in public cloud. That's what public cloud directly addresses. But confidentiality, so regulating access and regulating, making sure that the data that you have is intact, is still challenging. Yes, there are some more challenges after you migrate to the public cloud. So after you migrate to public cloud, it turns out that everything is much more complex. That's the first thing. When you compare it to on-prem, cloud world is really complex to configure. You've got a lot of things to configure, and it's really easy to make mistakes. And you know that most of all these big news about cloud being hacked, right, is usually just somebody not setting up correctly the privileges to the objects in the public cloud. So complexity is the first problem. You've got fogged visibility. You see some parts of the landscape, but not everything, and you have really a lot of tools to see different spots. So to see the big picture of what is happening, to have one pane to manage everything, is another challenge, which makes it a bit more complicated. Management itself, well, you have one more vector for the attack, right? To get access to your credentials to actually manage the cloud. Connectivity. Connectivity is, I would say, one of the new things, and it's connected to a thing which I like to call island security. Your network is no longer a single fortress where you have clearly defined boundaries and everything inside is your secure data, or, well, the data that you should secure. Right now, we've got a lot of islands. We are managing an archipelago of like multiple small islands. Each of these islands needs to be protected, but also each of these islands needs to be able to connect to the others, right? These islands are exactly the hybrid world. So this is your on-prem data center. This is your private cloud, your VMware or Hyper-V. This is your Azure Stack. This is your public cloud. This is your Azure environment. If you've got some department also reaching out to other clouds, that is another cloud. So connecting from Azure to something else, AWS, GCP, whatever you want to use. All of these need to be securely connected, and each of these islands must be secure. So it's pretty much building up the complexity when you go for the hybrid deployments. and so on and so on, right? So like we really have a lot of things, but still really what we want to protect is to make sure that nobody gets access to the data that they should not have access to, and nobody breaks our data. So that's still the core of the thing. So the question is cloud secure or it's not from a network's perspective? And not only network perspective. Well, it depends how you look at it, right? So of course, these parts which are provided by the cloud provider, by Microsoft, are usually much more secure than anything that you can do by yourself. And the important part is like, what is that part which is provided by the cloud provider? Because when you move to the cloud, when you first see the cloud, you think, oh, it's all so secure. It's running all the time, 24/7, secured by Microsoft. We do not really need to do anything. And this is a big lie. Okay, so probably you know the diagram which I have on the screen right now, because this is actually coming directly from Microsoft website. And this is a diagram which explains so-called shared responsibility model. It's a well-known standard for how to secure clouds. So actually, it's really simple. Whatever you get from the cloud, you can assume is secure, but all the rest is your role. So if you go for infrastructure as service, infrastructure is secure, but application, software, platform which is running on it is your job to secure. If you go for platform as a service, you've got a little bit less work to do. If you go for SaaS, then like just a tiny bit on the top, like privileges, is your work to secure. But infrastructure is always secure. And actually, in perspective of Fortinet, we usually deal with IaaS deployments. So we help our customers to secure everything which is above the infrastructure, which means above the physical hosts. So you have to secure the networking, you have to secure the VMs, and you need to make sure that the communication between VMs is managed in a proper way. Okay, so in general, what tools do you have, or you can get, or you should get, to secure your IaaS deployment? There are a couple of different tools. Some of them are traditional and migrated from the on-prem world. Some of them are new and very specific to the public cloud. So let's just go quickly through what we have here. So the first, maybe this is not classic for Fortinet approach, but I personally believe this is the most important tool you have for the security in public cloud, is Web Application Firewall, or a WAP, Web Application and API Protection. So that's a, let's say, extended version that was defined by Gartner. And Web Application and API is treated together because most of WAFs on the market actually naturally evolved towards protecting also API. That the reason for it is that our website or our services that we all deploy look a little bit differently. So it's not always just a website for which a client is a web browser, and it's nicely rendered in the web browser, and everything else is really done on the server side. But also, very often you've got services which are provided as API. So you do not really have then a website to protect, but you do have an API to protect, because all your customers are just pulling data for you. Also, this is how a lot of mobile games work, right? You've got a fat client sitting on the mobile, which connects to the API, to the service through the API to communicate with other users, to download the worlds, and so on and so on. So API is really something which might be publicly available, might be privately available. One of the things which comes with the cloud is the microservices architecture, which means that you do not really have one big service, one monolithic service, but you deploy dozens of small services, right? So you've got one small service which is dealing with, I don't know, shopping cart. Another with the catalog of products, if we're talking about classic example of online shop. Another one which is maintaining the login only. So there's like really small boundary, and all of these are small islands which you have to connect and which you have to protect between. So what your WAF or what your WAP solution should do, it should protect your application, be it a web app or be it API. It should take care of all the problems which are mentioned in OWASP Top 10. Some bot mitigation, some machine learning, that would be nice. And that also helps with the compliance. So those of you listening to me working in financial services know very well that simply deploy WAF is one of the recommendations from PCI DSS, or not recommendations, but something that you have to do, you have to take care of. So all of these things are important to take care of. There are some products that are available directly from the public cloud. They usually are like solid but limited in functionality. If you want to expand to go for machine learning, for additional inspection, for I don't know, decide if you want to use negative or positive model for scanning, then you have to go for additional appliances. Now, one thing which I wanted to bring to your attention is the form factor of a WAF or WAP solution. Because depending on what you want to protect, you might want to use different form factors for it. And available ones are VM, right? So that's a classic. That's literally moving the on-prem hardware device to the public cloud, running it as a virtual machine, and yeah, just having it there. Or usually it will be a cluster of virtual machines, but I will get to the clustering later on anyway. So VM is the first one, right? Or a hardware machine. Pretty bad idea actually to backhaul your Azure traffic to on-prem to scan it through the hardware and then send to Azure. Some of our competitors did it. I think they do not do it anymore. Anyway, VM is one form factor. The second one is SaaS, software as a service. So that means that you do not have any VM. You just buy a service and redirect your traffic to it. That's the way how Azure WAF works, by the way, right? You just enroll to it, you see it as a service. You do not really care how many VMs are running the software. You just use it, right? So this is pretty convenient, definitely more convenient than a VM, but it also has some limitations because software as a service is targeted strictly to protecting your website against what is outside. So the traffic from public internet is coming to the service, then the service is forwarding to the internal service, to the backend service. But what about internal traffic? What about traffic from your on-prem, which is going to your own application to the cloud? What about traffic between your different services, which are both running in the cloud? Right? This is the moment where SaaS is not so good anymore. So maybe you should go back to the VM. Also, there is a third form factor which you should take into account, especially if you go into microservices and if you go into Kubernetes, which is a lot, right? After you move literally all your application from on-premise to the cloud, which is usually the lift and shift is usually the first phase of a migration to the public cloud. Then you want to modernize it, or you want to build new applications using cloud tools, and one of these is containers. And then if you want to scan traffic between APIs which are running on containers, then you do not really want to go out to a VM and scan it again. You might want to run a WAF as a container, right? So 3 different form factors. Think about it, which one is best for you when you deploy any WAF or any WAF protection, because it's like you do have differences between them. Second product which helps you take care of your part of security responsibilities in the public cloud is, of course, a firewall. And I added here a few words to the firewall. The first one is next generation firewall, and then it's NVPN. Next generation firewall with VPN give you a lot of tools which you do need for protecting your cloud deployments. The first one is connectivity. Remember, again, island security, right? You need to hop between the islands somehow in a secure way. You've got the IPA, you need the IPS, which goes beyond HTTP, especially if not everything that you're running is HTTP. So if it's HTTP, you can use WAF, that's fine, and that's absolutely good enough. If you are running anything else, then you need something which is not a WAF, where you need a firewall with IPS. So that's another thing. you need application control and web filtering. You may ask why, right? It's like we do not really have users in the cloud. We only have servers there. So application control towards servers doesn't make sense because we know what is running on these servers. But think about traffic which is generated by your servers in the cloud. They go out, they download the updates, they download maybe some content from the repositories from GitHub. So yes, you do need an application control. You want to make sure that this server has access exactly to, I don't know, Ubuntu updates, and another server has access to Windows updates and nothing else. So application control is still the thing that you have. Web filtering and antivirus scanning. Yes, you want to make sure that your servers do not download anything. And if they do, you want to be alerted, right? You want to know that something is wrong happening on your server because it actually reached out to a resource where it should not. And these are things which already are like next gen, right? So you need firewall with threat scanning. Then you've got IPsec. IPsec is the crucial thing in the cloud. So it's like, yeah, I've got this subtitle here. The cloud is only as good as your connectivity to it, and this is very, very true. As soon as you have problems connecting to your cloud, or your customers have problems connecting to the cloud in a secure way, then there is no use, right? You might have hundreds of servers, scalability, everything running super performant in the cloud, but if there's no availability, it's a problem, right? So IPsec allows you to connect all your branches to the public cloud, so you can reach out from all your offices to your internal apps. Sometimes you give your applications to your customers, and you need to do it in a secure way. So then you build IPsec between your customer gateways and your cloud and the cloud, and all of this needs to be somehow managed centrally in ideal world. So IPsec management is important. An extension to IPsec is SD-WAN. A lot of our customers use ExpressRoute for connectivity between the on-prem data center and the cloud, or the headquarters and the cloud. But not everything is running through ExpressRoute. Sometimes you want to split the traffic and have maybe ExpressRoute and IPsec, maybe as a fallback, maybe at the same time. Maybe you want to limit the throughput on the ExpressRoute, or make sure that the bandwidth on ExpressRoute is available to your critical applications, and something which is less important, you can just send over the IPsec. So you need SD-WAN solution which is able to split this, recognize what type of traffic it is, and send it through the proper connection. So next-gen firewall still is the thing. If it's a next-gen firewall which will be on-premise, which will be able to connect to your cloud, if it will be next-gen firewall which is sitting in the cloud and protecting your workloads, doing the north-south inspection or doing the east-west inspection, if it's a next-gen firewall which is sitting in the cloud and giving you access to the resources, either from the branch offices, from the clients, through the SSL VPN, so again, connectivity, or it's a next-gen firewall which encrypts your ExpressRoute. This is another use case, right? We very often have customers that say, okay, we've got this ExpressRoute, we've got low latency, high availability, guaranteed bandwidth, and everything, but well, regulations require us to encrypt all the traffic, so we need to run the IPsec on top of the ExpressRoute. So a lot of use cases where next-gen firewall is used still, even though you might think that it's obsolete because you've got the network security groups, you've got the Azure firewall, so why do we need firewall? So threat scanning, threat intelligence, SD-WAN, all of these things managed in one place. That's the reasons why next-gen firewalls are still a big thing in the public cloud. Yeah, and there are couple of new solutions that you might use to secure your cloud deployments. Cloud workload protection, CWP solutions will scan if your configuration is intact, if you do not open some storage to the public, for instance. You've got CASB solutions, so Cloud Access Security Broker, which allows you to manage the access, to control the access to the cloud resources. You've got SASE, which is like step up from the SD-WAN a little bit and moving your firewalls and all the scanning to the cloud and saying, okay, we do not need any hardware, or you still need some hardware because you still need to connect somehow. But basically, SASE is another step in evolution of a firewall to IPsec or VPN to SD-WAN and then SASE. So all these are specifically cloud solutions. So they are not migrated from on-prem, but delivered there, and they are usually available as SaaS solutions, usually, and also from Fortinet, of course. Now, how do you install it, right? How do you manage your or design your infrastructure in the cloud? So once we want to migrate, there are a couple of things that you should think about. First thing is high availability, and you might think, why high availability? This was my very first question when I started with cloud. I asked my friend Felix, who was introducing me to Azure, like, why do you really need high availability? This is cloud. This is running 24/7, right? Super secure. Nothing can happen. Well, you do need high availability, definitely in the public cloud as well. You've got a couple of reasons for it. The first one is Azure maintenance, right? So from time to time, a host which is running your VM will need to go to maintenance. Right now, Azure issues a warning before that. So they say, okay, in tomorrow at 3 p.m. we will shut down the host, migrate it or do something because it will be just shut down. So Azure maintenance is one thing. Second thing is your firmware upgrades, your own firmware upgrades. If you want to run a firewall and you want to upgrade that firewall, then yeah, you load the new firmware, you need to reboot it, right? During that reboot, you've got downtime. You do not want any downtimes. So if you have an HA cluster, that means that you upgrade the one of the nodes, you reboot it, you take over, you upgrade the second one, right? Zero downtime, or minimal downtime, let's say so. So that's another reason. And the third reason, last but not least, is the infrastructure SLA or compute SLA. If you look at the SLA from Azure Compute, you will see that if it's just a single VM, you've got, depending on what disks you are using, it might be from something between 95 to 99.9% of availability. And that means roughly almost 9 hours per year of allowed downtime. Of course, it needs to be distributed across months, so you will not really have 9 hours, but theoretically, you can have up to 9 hours of downtime for a year. Now, if you are running an e-commerce website, like again, my favorite because of the simplest example, how much money will you lose during 9 hours of downtime? And is it worth it, right? I'm not mentioning what happens if you're a bank and you've got 9 hours of downtime. So what is the solution? The solution is to go for the HA. If you have 2 instances running in 2 different availability zones, then it's 4 nines of SLA, which translates to like 40 minutes, right? During the whole year. So this is not a big thing now anymore, because that means like you've got 3 minutes per month. And that is something that your users can bear with, right? Like if you've got 3 minutes downtime, yeah, fine, I will just try in a moment. Maybe it's my internet, maybe it's not it's not my bank going down, but it's maybe my internet at home. So this is a very, very big difference for the customers, for our customers. So for all of you providing services using public cloud infrastructure. So go for high availability. Now, there are 2 ways or a couple of ways to approach it. The most popular one is to use active-passive. Why not active-active? I will go into it in a second. Then if you want to use active-passive deployment with 2 instances, 2 firewall instances, then there are 2 well-known design patterns for it. The first one is to use the API calls. So you've got the, maybe I will just go back because this will be, the next diagram will be just in a second. So when you use API calls, that means that during the failover, to the HA partner. There is an API call issued towards the cloud to move the public IP to the newly active node and to change the routing on the internal side to route the traffic through the newly active node. So this is pretty simple, right? Because you cannot use ARP, of course, right? We all know, hopefully we all know, that you cannot just do how we do it the same way as we do it on-prem, where the new partner either takes over the virtual MAC or sends the ARP information. But hey, right now this IP is mine. You cannot do it, right? That's cloud. You do not have ARPs in Azure. Every single device in Azure, every single VM in Azure has exactly the same MAC address. If you don't believe me, just check on your VM. You always will get 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Yeah, too many digits. Doesn't matter. Anyway, you always get the same MAC. So ARP does not work. You need to use API to tell Azure right now this public IP and this route should point to this instance. And this is fine. This is working. But the problem is that there is no SLA for API calls. And in practice, it takes like 40 seconds or more, which is not so good, right? Not nice. So then there is a second approach, which is called load balancer sandwich. And in load balancer sandwich, you put the firewalls or appliances between two load balancers. And these load balancers constantly probe both instances, both VMs, to check which one is active, which one is not, which one is not. From the load balancer perspective, it will be called a healthy and unhealthy instance, right? So, but from our perspective as a firewall vendor, it's active and passive node. And then load balancers, as soon as the failover happens, they detect that the active is another one, and they start directing traffic there. In Azure, it's much faster to use load balancer sandwich than the API approach. We support both, but we recommend load balancer because it's just much faster, and there is literally no disadvantage to use it. So that's the AJ. So active passive in load balancer sandwich, that's the classic design which most of our customers use. Now, the second thing which you will always hear about is auto-scaling, right? In the public cloud, auto-scaling is the thing. You want to do auto-scaling. When you move to public cloud, everybody gets fascinated with auto-scaling because this is something that you totally cannot do on-prem, right? You cannot just say, if my server is overloaded, just unpack the server, put it in the rack, connect it, start it, and yeah. No, it totally doesn't work on-prem. But in cloud, yes. So this is this new possibility that cloud gives you, and everybody is really, really excited at the beginning of a journey into the cloud that, yes, we can use auto-scaling. Auto-scaling is great. So you can scale out, and you should know the difference between scaling out and scaling up, right? Scaling up means bringing a bigger appliance. Scaling out means adding more appliances. So you can scale out and get basically in infinite performance, right? There's no limits. If you want to serve billions of connections, you do it with just enough instances. And it is a great idea. I cannot say it's not a great idea. Autoscaling is a great idea. Autoscaling, or like VMSS, as it's called in Azure. So if you want to deploy, it's like called VMSS, Virtual Machine Scale Sets. But it's great for server farms. So yes, if you are deploying a web application and you have web servers, you want to deploy these web servers, you do use autoscaling. Definitely. Scale sets are great. Scale sets will allow you to just run a new server, install your web app there, run it, and have it added automatically to the group. So it's really a nice thing. Now, if we think about firewalls, it's not that great anymore, right? Cloud was not built for firewalls, and firewalls, really firewall appliances, or NVAs, as we call it in Azure, network virtual appliances. So NVAs are not really built for cloud, right? NVAs is something which is between cloud and on-prem worlds. And they do not behave that well with public cloud and auto-scaling. Why? The first thing is asymmetric flows. Depending how you deploy it and depending on your use case, it doesn't. It's not a problem always, but very often. If you have an auto-scaling farm of firewalls which are facing the external side of the network, so which are facing internet, then you have this farm between two load balancers, external load balancer and internal load balancer. So the packet which is coming from outside hits the external load balancer, gets distributed to one of the firewall instances. That firewall instance checks the packet against the access list or firewall policy, however we call it, and releases it and sends it to the backend server, right? Backend server says, okay, I've got a packet, I send my acknowledgement packet back. It sends that packet back, it hits the internal load balancer, and internal load balancer distributes it to one of the firewalls. And absolutely not the same which was processing the initial one. So you get asymmetric flows, right? Flow is one half of a connection, one direction of a connection. So you've got the flow of packets towards the server and the flow of packets from server back to the client. And these flows very likely will go through two different firewall instances. And technically, yes, you can synchronize the connection table, totally fine. But that already introduces some race condition, right? Will the synchronization packet be first or will the return packet from the server be first? So it will work in like most of the cases. This is not a big problem. The problem is when you go and you think about the firewall as a threat protection device. So you want to do the threat scanning, because for the threat scanning, you need to see, or the appliance needs to see all the content of both flows. And now if you want to set the content of both flows between the instances, that very quickly generates a lot of traffic between all the instances. So this is not really something that you want to do. So asymmetric flows is a big problem. It doesn't happen if you are scanning the internal traffic only, or if you are scanning the traffic between your on-prem, which is, for instance, coming through the express route and hitting your backend servers, because then you just use one load balancer, one internal load balancer, and that one is aware already of the connections, so it will keep the affinity to the same firewall instance. But this is just small part of the use cases. Many of our customers have problem with external and internal, and then auto-scaling is a problem, or basically active is a problem, not only auto-scaling. You can fix asymmetric flow with source nothing. For some use cases, again, this is fine, because sometimes you do not care about it. We can inject the X-forwarded for if it's a HTTP traffic. If it's not an HTTP traffic, and it will be source nutted, you just lose the information about the client IP. So asymmetric flow, problem number one. Scaling lag. If you are scaling out or scaling in, or scaling in is not a problem, scaling out, adding a new appliance takes time. It's not really just starting it. It needs to be allocated, it needs to be provisioned, it needs to be run. And one of the less known facts is that actually Azure Marketplace, one of the rules for publishing in Azure Marketplace is that your appliance should not start faster than in 5 minutes. Not always that's the case, but that's one of the general rules. So if you want to start, for instance, a 40 web, you will have to wait for it. And maybe your fluctuation up and down is not fast enough to adapt to it. So scaling lag is another problem. Licensing challenges is another problem. You want to have different type of licenses. We solve it with FortiGate in a way that you can mix licenses which you buy for the whole year and the temporary licenses, like pay-as-you-go licenses. And last but not least, remember FDOS. FDOS, that's like more note to me. FDOS is not an official term, by no means. I take credit for FDOS. FDOS stands for Financial Denial of Service. So if you are really excited about auto-scaling, you set up your auto-scaling, you say, okay, whenever you need more instances, just scale out and add more instances. And let's say we scale out based on connections, because that's usually the first thing that we run out. There's a limit of number of concurrent connections in Azure for Azure VMs. So yeah, we just scale out, right? So it's like whatever we have coming to us, we will be able to provide the service, and we'll just add more firewalls and more firewalls. And when we add 100 firewalls, Azure will be really, really happy to do it for you, to build 100 firewalls for you to process your traffic. I would say a firewall vendor would be also very happy with licensing, but then you will get the invoice for it, and you will have to pay for it. And yes, that traffic, maybe it was a DDoS attack, who knows? That traffic which generated 100 VMs maybe did not kill your web application, but it will cause you a lot of trouble for your financial for your finance. And maybe this will just close your cloud project because of the CFO. So be careful about the scaling. Remember that you can use it in some cases, but not all cases. And yeah, remember ethos, and do not be killed by the financial denial of service. All right, so how do we actually deploy anything, right, in the public cloud? There are two ways to do it. Oh gosh, I've got only 12 minutes. I need to speed up. You've got two ways to do it. First one is just go to Marketplace and click it, right? That's the easiest one. But as soon as you get a little bit more fluent in public cloud, you will see that this is not the best way to do it, because it's not really flexible enough. So the second way is to use the templates, ARM templates usually in Azure. There's also Terraform, which is universal across clouds. I personally prefer ARM, but that's a personal preference. So templates mean that you code your infrastructure and you code your configuration for the VMs and for the firewalls, so you can deploy it automatically. And that's part of DevOps thing, to have everything in a code, have infrastructure as code, so you can replicate it easily, you can document it easily, you can trace the changes very easily. There's really a lot of things that you can do with this, and you've got access to all the features of a cloud when you use templates. While if you use just the solutions which are in the marketplace, you do not really have that. Actually, Marketplace is also templates. I will show you, if I have time, how it works, where to find templates in the Marketplace, really. But that's another story. Okay, so for automated cloud deployments or for immutable infrastructure, those of you into DevOps know what immutable infrastructure is, and you will know exactly my next slide. But just to give you a little bit on what we have to offer, so reference architectures, ready-to-go deployment templates, integrations with most popular tools like Terraform or Ansible, and most importantly, we've got support for headless deployments or immutable deployments. So that means that during deployment, you can provide all the configuration, all the licensing to the appliance, to the NVA, and you do not need to log into it or touch it at all later on. So that's the ideal DevOps world, right? Where you can deploy everything and you do not log into the server once, and everything works. And do not log into the server once includes also firewalls. So this is an important part and very big difference between on-prem and the cloud thing. So if there is only one thing that you want to learn about the cloud, this is it. This is the cattle versus pets principle. And for those of you who do not know cattle versus pets, what it is about, it's the difference between your servers in the cloud, which is cattle, and your servers on-prem. Your servers on-prem are like pets. You choose them, you bring them home, you give them names. When something is wrong with them, you spend days and nights fixing it and making it work. Your servers in the cloud are like cattle. They do not have names, they have numbers. And if they are sick, you just kill it and get a new one, right? Maybe brutal, but that's exactly how it works. You do not really want to spend your night on the SSH session or whatever operating system you prefer, PowerShell session, fixing your server in the cloud. if it's not working, you've got the IAC code to deploy a fresh one. So you kill the VM, create a new one, done. And this is one most important lesson about public cloud and moving to public cloud that you have to learn. You do not want to spend time maintaining the server. Maybe you do it during the POC phase when you want to check how things work and how to configure it. But afterwards, you put it in the template and you just deploy it. And you do not log into the server even once. Okay, short information about who we are. So Fortinet, for those of you who do not know, Fortinet is one of the top cybersecurity companies in the world. We have a pretty unique approach to the security, which combines networking and security. So we have a lot of like top network security companies started just as network or having a very narrow view of security, being firewalls and VPN. Fortinet was the company which introduced the concept of UTM, so adding everything into the appliance, not only having a firewall and a VPN, but also having web filtering, antivirus, IPS, all of the things for threat scanning included. So this is really what we mean by security, not just the firewall policy or access policy, but also having a look into the content and checking what is inside. We have probably the broadest security portfolio in the industry, starting with access points for Wi-Fi, which are centrally managed by your firewalls, with SD-WAN, with a VPN, with a WAF, with a mail security, with endpoint security, with a CM solution, with SaaS solutions for CWP or CASB. So really a lot of things that build our portfolio, and you can check many of these appliances available in the Azure Marketplace. Not all of them, but many of them, really most of them. And all of these are not standalone solutions. So one of the things which is important with Fortinet is Fortinet Security Fabric, which builds the integrations between the appliances. So you've got, for instance, FortiGate, which is the firewall, which talks to the FortiManager for central management, which talks to FortiAnalyzer for finding common trends across multiple appliances, which talks to FortiSandbox to detonate the payload and check what it is doing really, and not only use the antivirus patterns, which we develop by ourselves anyway. So a lot of these things that allow you to build the whole infrastructure together, and also Security Fabric is a public infrastructure. So we have a lot of external partners working with us to integrate with our appliances and provide additional automation, additional security. Okay, I will end this slide deck now. And let me just very quickly change the sharing and share my other window, which is this one. Okay, so just to give you a really short demo on what we have and how it works. Where I am right now is our GitHub. So I will just show you how to deploy our appliances, how to do it in a proper way, let's say. So if you want, you can go to the Azure Marketplace. In Azure Marketplace, we've got like over a dozen of different solutions, and some of them include some automation. And actually, let's, we will do it in a second maybe. But the second way how to deploy something is to use the templates which we provide on our GitHub. So github.com/Fortinet, you can find some templates there. And if I go for FortiGate, let's go for VNet peering. That is deploying most common infrastructure. And let's open a new tab. Azure makes it really easy. So it's like you've got this deploy to Azure button, which gets you to the Azure portal and allows you to deploy something from any custom template that you want. And this already should seem a bit familiar to you, right? So this is Azure. I will very quickly create a resource group for myself. Let's deploy to West Europe, my favorite. I provide my password. Choose queue, choose the version. I can provide some additional configuration later on. I will just skip it for now and use the defaults. And we can go and create. So what this template is doing, it's deploying a so-called security services hub, which means we will have a cluster, active-passive cluster of 2 firewalls between the load balancers. The external load balancer gets the public IP address, so we can connect to and from the internet. On the internal side, we've got, if this is a hub, then these are the spokes, right? So we've got 2 VNets, which are the spokes. So you can think about it. This is the very common deployment when you are moving your deployment from on-prem. It's a lift and shift thing, right? So you take it and you put your multi-tier application in the cloud. So this is exactly what it is doing, right? Without waiting for it to actually deploy everything, I already have one running. So just to save on time. And I want to show you one more thing, which you want to have a look at when you are working with public cloud. Okay, this is just a welcome video. Let's skip it. Now, in the public cloud, you've got a lot of dynamic objects, a lot of dynamic VMs or other things that just appear and disappear, and they change their IP addresses very often. So you either use static IP addresses and assign them in Azure, or you have to use something to understand the dynamic nature of the cloud. And understanding the dynamic nature of the cloud is done here by using the so-called dynamic addresses. So I will create a new dynamic address right now for you. And just to show you how it works, Fabric Connector, let's use this one. And I can create here an object which will say, for instance, I don't know, I want to use some tag, or I want to use something just from the VM, right? So let's say I want to use my resource group. I want to use my subnet, which I do not know for sure what IP addresses are there. So this way you can say all traffic within this resource group from one VM to another VM. Okay, so you can have from this VM to another VM, and I do not worry what IPs they will get. Should be allowed on this and that conditions with this and that scanning. So instead of providing IP addresses into the firewall policy, you can use these dynamic objects to say exactly what objects you want to create your firewall policy about. There is more about it. I was on my diagram, you saw there is spoke 1, spoke 2. Usually it's a 3-tier, right? Usually you've got the front-end application and database. But in public cloud, very often you will just move the database to the service, right? So you do not really have a VM running a database, but you're using the database as a service. And how do you allow the traffic to the database? As you're used to publish the XML file right now, it's an API. I would just add it here as a new thing. Don't worry about it. Let's move it. And to find out the public IP or of SQL service, you just use the so-called service tag. Those of you who played with Azure Firewall know it. And you can also do it in an appliance. So this way I can say, okay, all the traffic from my front-end servers, whatever IP it is, to some service, or from my backend servers to the SQL service, right? That would be more real-life example. will be allowed, but frontend cannot talk to it, and backend cannot talk to any other service in Azure besides the MySQL. Besides the MS SQL. So you have the dynamic nature of cloud moved into here. You've got all the threat protection moved here, and that's just like one tiny bit of how to do it. And also, of course, because we use this hub for transmitting all the traffic, all the connections between Spoke 1 and Spoke 2 networks will be also scanned by my firewall here. All right, it's 52, so I'm 2 minutes over time. Thank you very much for your attention, and yeah, this is it from my side.
It's great. So I just sent, since you just sent your video. Thank you. We had some questions out there. So okay. One of the main questions was, is Fortinet working in the Microsoft Biceps project?
We are not actively contributing to Biceps. We are monitoring it, of course. Biceps is a language for translating to abstract templates. So Biceps is then translated to ARM templates and then allows you to deploy the network, for those of you who do not know what Biceps is.
Yeah, thanks. The other one is just really thank you. And yeah, we will meet again and see you at
Hopefully.
Our next event. Yeah, and now we wait for the next event in 7 minutes. So it was no problem that you took a bit over. Thank you.
Okay, perfect. Bye-bye. Thank you very much.
Perfect.
Bye.
Okay.
Businesses are rapidly adopting cloud computing, taking advantage of its flexibility and speed. Whether consuming SaaS applications, building cloud-native applications, or migrating existing applications to the cloud, finding a security solution that addresses a diverse set of needs is critical. Fortinet Cloud Security Solutions deliver. Get the confidence you need to deploy any application on any cloud supporting any initiative. Fortinet supports all major cloud providers, ensuring that critical assets are secure and that security is manageable. The Fortinet 3-pillar cloud security strategy provides the same level of security across multiple clouds by natively integrating security into the cloud platform, defining security policies for cloud services, and leveraging cloud services for security, ultimately enabling automation of security services. Fortinet provides the industry's broadest set of cloud security products, enabling you to use the same security in the cloud as you have on premises. By using purpose-built security tools in the cloud, you'll save time by leveraging existing skill sets. By managing security across multiple clouds through a single pane of glass, and by automating the security lifecycle management, you can better leverage existing skill sets and accelerate the confidence to deploy applications anywhere. From consuming cloud applications to building applications in the cloud and migrating IT to the cloud, Fortinet Cloud Security Solutions cover the broadest set of use cases, delivering the flexibility and confidence to use the cloud in a way that best serves your business.
Hello, Stefan.
Hello, Helmut. Hello.
Okay, I send you live with your desktop. No. Yeah. So. Yeah. We see you. Yeah. You're live now, and yeah. Welcome to everybody. I'm very proud to welcome Stefan Denninger with a really interesting IoT, Azure IoT presentation session. And as you can see, he's highly committed to presenting, even bringing his own image into the folios. Okay, Stefan, may I hand over?
Dankeschön. Ich bin mir noch nicht ganz sicher, ob ich Deutsch oder Englisch reden soll, aber ich glaube, es ist heute auf Deutsch einen Tick leichter, weil es gibt ein paar Dinge, die ich zeigen muss und es ist heute unfassbar schwer, das live zu präsentieren, wenn es um IoT geht, weil IoT ist ganz was anderes, wie das, was wir jetzt die letzten 4, 5, 8 Stunden schon gehört haben. Die Einleitung vom Kosmos, die ganzen HCI-Themen und dann noch der Helmut dann am Schluss mit dem Kubernetes. Das sind alles Dinge, die ich brauche, damit meine Dinge funktionieren. Und ein Ding wäre jetzt zum Beispiel, wenn alle aufstehen, ja, also wir sitzen ja schon relativ lange, wenn wir aufstehen und wieder sitzen, dann wäre interessant, das als Sensor auch zu wissen, ist dieser Bürosessel benutzt, ist er herumgesetzt, ist er herumgeflogen und ich werde dann auch gleich erzählen, warum das relevant ist. Also wir reden heute nicht, oder ich in meinem Teil, nicht über Azure Services aus diesen Infrastructure- und Plattform-Dingen. Es geht um die physische Welt, das ist das Schöne an so einem Hybrid Day wie heute. Es geht um die physikalische Welt mit der digitalen Welt zu verbinden. Also Dinge, die in der echten Welt existieren und Dinge, die in der echten Welt passieren, die zu digitalisieren und in die verschiedenen Applikationen dann hineinzubringen. Das sind Dinge, die wir kennen. Auf der einen Seite die ganzen Applikationen, also zum Beispiel, wenn irgendwo ein Use Case wäre, zum Beispiel der Mistkübel ist voll, dann wäre ja natürlich gut zu wissen, irgendwo, wenn das die Müllabfuhr jeden Tag herumfährt, bringt das nicht viel, aber wenn das irgendwo ein Gerät ist, das weit oben am Berg steht und keiner von der Gemeinde weiß, dass der Mistkübel schon total überquillt, dann wäre das durchaus interessante Information, die zu transportieren. Das sind Dinge, die ich ein bisschen zeigen möchte. Der IoT-Teil ist unfassbar breit und es gibt unfassbar viele Dinge davon. Konzentrieren möchte ich mich ein bisschen heute zu der Ecke Manufacturing, also alles, was aus dem Shopfloor kommt und vielleicht ein bisschen, wo passt es am besten rein, dieses Ganze vielleicht Real Estate, so Building, Offices. Also es geht um das, was eigentlich dem Kunden oder dem Benutzer, sei es um Business oder Privatbereich, was dem Mitarbeiter wirklich was hilft, wirklich weiterbringt. Fokussieren tun wir uns in letzter Zeit, und das ist gerade in der Zeiten, wo alle zu Hause sitzen, wo wir eben nicht wissen, wie es im Büro oder wie es in der Produktionsstätte gerade zugeht. Es geht um Remote Monitoring, Condition Monitoring. Wir wollen wissen, wie es in unserer Produktionshalle aussieht. Wir wollen wissen, wie es einfach, wie es der Firma geht und nicht den Teilen aus den Office-Zahlen, also die Bilanz, die Steuer, das sind Dinge, die sind schon lang digital, sondern vielleicht auch, funktioniert die Maschine, läuft die? All die Dinge, die man in der Produktion normalerweise, wenn man durch die Hallen schreitet, wo es ein bisschen nach Öl riecht, ein bisschen nach Arbeit riecht, Das muss man auch zu Hause irgendwie mitbekommen. Das heißt, IoT und Industrial Analytics ist ein weiter Bereich vom Daten erheben, Daten festhalten, Daten persistieren, hin zu Daten auswerten, wo auch der Industrial Analytics ist der Teil, um die Daten gemeinschaftlich zusammengeführt zu analysieren und dann festzustellen. So in Österreich sagt man dann ÖH, also wo man dann merkt auf einmal, da passiert etwas, die Daten passen nicht zusammen. Ich zeige das dann am Beispiel von einem Kühlschrank, wo man zum Beispiel feststellen kann, wie geht es dem den Kühlschrank? Zu Zeiten der Impfstoffe und der Tests, die Tests braucht man nicht so viel kühlen, aber gerade bei Impfstoffen sind die relativ viel Geld wert. Also wir haben ja Impfstoffe, die sind vielleicht 5 Euro oder 10 Euro wert, wir haben aber Impfstoffe, die sind 10.000 Euro wert oder zumindest 1.000 Euro. Und so ein Kühlschrank, der hat dann doch um die fast 1.000 Artikel drinnen in so einem ein bisschen größeren. Da kann man sich dann ungefähr ausrechnen, wenn so ein Kühlschrank die Tür nicht zu ist oder das Aggregat irgendwie leckt und nicht weiter tut, dann hätte man das schon ganz gern gewusst. Also in IoT, da geht es um all die Dinge, Daten zu heben, Daten zu finden. Da gehört natürlich auch dazu der Bereich OEE. Also wir wollen wissen, läuft die Maschine, läuft sie nicht. Wenn sie nicht läuft, wollen wir auch wissen, warum sie nicht läuft. Ist macht der Mitarbeiter gerade Pause, ist gerade irgendwie in der Nacht, wo man keine Betriebszeit hat. Und daraus kann man dann auch KPIs errechnen. Die Referenzarchitektur ist seit Jahren eigentlich die gleiche und gilt ein bisschen als Blockschaltbild. Und in den Bildern, die es bei Microsoft gibt, geht immer von links nach rechts. Die Daten kommen irgendwo rein. Die Daten müssen irgendwie gemappt werden. Die Daten müssen irgendwie analysiert werden, müssen irgendwie korrigiert werden. Ist der Sensor, ist der richtig? Misst der Mist? Also wenn man merkt, zum Beispiel der Kühlschranksensor sollte eigentlich in einem Bereich von minus 5 Grad, vielleicht bis plus 20 Grad messen. Und auf einmal kommt der Messwert daher mit 1000 Grad oder mit minus 300. Dann kann man sich überlegen, stimmt das jetzt oder kann es sein, dass der Sensor defekt ist? Also auch diese Dinge werden typischerweise im IoT-Device oder im Edge-Service ein bisschen vorgefiltert und vorkorreliert, weil da muss schnell wer hingehen und den Sensor reparieren. Dann geht es eigentlich ab in die Cloud, wobei Cloud, das ist vielleicht ein bisschen ein cooler Verweis zum Hannes Lagler, seinem Vortrag. Es gibt fast alles von dem, was ich heute zeige, auch on-prem oder demnächst on-prem. Es wird auch den IoT-Hub auf Azure Stack Hub gehostet geben. Das heißt, von den Dingen, die wir hier auf dem Bild sehen, gibt es praktisch zu 100%, ich will gerade schauen, ob ich was übersehen habe, zu 100% auch on-prem gehostet. Vielleicht gibt es das Device Provisioning Service links unten, vielleicht in der Form nicht gleich oder vielleicht nicht so global, wie man es glaubt, aber das sind Dinge, man schafft es auch, die Daten lokal zu halten. Es ist immer das gleiche Bild für Industrie. Schaut ein bisschen komplizierter aus, aber wenn man sich die Details anschaut, es ist wieder das Gleiche. Das ist jetzt vielleicht um ein paar Dinge ergänzt, nämlich um den Connector zu OPC-UA. Das sind all die moderneren Maschinen oder die moderneren Datenserver, die irgendwie so ein PLC heutzutage einfach hergibt. Ich habe das Bild noch rein, um ein bisschen die Unterscheidung zu sehen, was Industrie heute für übliche Services dazu braucht. In der Realität, das ist ein Bild, das ich gezeichnet habe, geht es vielleicht so darum, von links, irgendwo müssen die Daten gemessen werden. Das sind die typischen Siemens S7-Steuerungen oder irgendwelche LoRaWAN-Funkdinge. Das sind grobe Unterschiede einerseits, weil das eine ist batteriebetrieben, sehr, sehr langsam, komme ich dann später gleich dazu, oder in der Industrie, da geht es eher Meter pro Sekunde. Also da geht es richtig in Millisekunden-Takt dahin. Schlussendlich können aber die Daten von links irgendwie nach rechts, weil der Manager will wissen, ist alles grün, und wenn es nicht grün ist, dann möchte er relativ schnell und relativ einfach in das hinein drillen, immer weiter runter bis runter. Warum ist es gelb? Wo ist die Maschine? Wo ist der Defekt? Welcher Mitarbeiter steht davor? Was ist da gerade im Gange? Damit man einfach auf den verschiedenen Ebenen Informationen erhält, was Sache ist. Das ist alles ein bisschen kompliziert und das schaut alles ein bisschen komplex aus, und darum geht es heute um IoT Central. Das all das einfach kaschiert, das all das uns einfach abstrahiert und in eine mehr oder weniger fesche, fertige App zusammenfasst und man dort all diese Sensoren anschließen kann, dort all diese Dinge in ein Dashboard zusammen aggregiert. Und das Schöne dabei ist, wenn es quasi zu kompliziert wird, man kann jederzeit wieder ausbrechen, und ich zeige das dann im IoT Central, man kann dann eben so einen Livestream quasi aus der Applikation wieder ableiten in Azure Event Hub, Azure Stream Analytics, in eben ganz neu zum Glück auch in normale Webhooks. Man kann auch integrieren in Logic Apps, Konnektoren in die ganze Welt, um irgendwelche Dinge in externen Tools machen zu lassen. Was ein super Feature ist, was viele IoT-Plattformen leider nicht mitbringen, ist ein Punkt, der mir besonders wichtig ist. Das ist Identity Management ist einfach nicht dabei, sondern es setzt fix auf Azure AD. Azure AD ist das Backend für alle Cloud-Logins. Azure AD kann man aber auch koppeln wieder mit ADFS und bringt damit die On-Prem-Login-Welt hinzu. Und ganz toll auch Cross-Tenant-Logins. Das heißt, ganz egal, wo, ich brauche die App nicht irgendwo registrieren, ich brauche nicht irgendwelche App-Services irgendwo registrieren und Vertrauensstellungen, ist alles fertig, sondern ich brauche nur einen User eintragen und der kann sich sofort einloggen für die Dinge, die ich ihm freigegeben habe. Das Preismodell ist vielleicht auch ganz toll. Man zahlt all diese Dinge pro Sensor. 2 Sensoren sind kostenfrei dabei. Und man zahlt dann, das ist jetzt neu im Dezember, man zahlt jetzt auch die Anzahl der Messages, wenn es über eine gewisse Menge drüber geht. Es ist aber alles so im wenigen Cent oder sogar im Mikrocent-Bereich. Also wir reden von, ich glaube, 14 Cent pro Gigabyte an Daten, die übertragen werden. Wenn man weiß, welche Datenmengen da in der Regel anfallen, also dass ja da nur einzelne kleine Werte übertragen werden, dann ist das eine ganz schöne Anzahl an Messages, die da daherkommen. Eingebettet in die Microsoft Produktportfolio ist es eben als fertige Solution. Das heißt, die brauchen wir mit all den Dingen, die da unten angesiedelt sind. Wir haben da, vielleicht zeigen wir das ein bisschen dazu, da unten, über das haben wir heute schon sehr viel gesprochen. Azure Stack Edge ist ein wunderbares Hosting-System, um die Edge-Komponenten zu hosten. Wir haben hier unfassbar viele Dinge aus der IoT-Solution-Ecke mit all den Pass-Services, die hier benutzt werden. Ist alles wegabstrahiert und man bekommt genau eine Solution, nämlich IoT Central, und kann darauf dann seine Lösung bauen. Ein bisschen zusammengefasst, das letzte Jahr war ein sehr gutes Jahr. Ich zeige nämlich auch dann ein IoT Central her, das uralt ist und hat wirklich tolle Dinge dazugelernt. Und vor einem Jahr habe ich noch gesagt, naja, viele, die sich angeschaut haben, sagen so, naja. Und jetzt ist es echt anders. Es ist das Third-Party-Integration ernst gemeint. Man kann jetzt die Daten auch in beliebige Webhooks extrahieren. Und es ist auch auf der linken Seite dazugekommen, natürlich ist Azure Sphere noch eine wichtige Plattform, aber man kann mit dem IoT Device SDK und auch mit dem IoT Edge, das jetzt voll integriert ist in IoT Central, ganz, ganz tolle Dinge tun, wie eben aus der Industrie all diese Legacy-Protokolle einfangen und damit zusammenholen. Zentral ist dann die App. Hinten raus kann man es wieder exportieren, wohin man will. Das mit Monthly Updates ist jetzt ernst. Das Produktteam hat sich da ordentlich bemüht, neue Dinge einzubauen. Ganz, ganz wunderbare Dinge. Ich werde jetzt da über 3, 4 Folien, das ist mir jetzt eine Nachlese, ein bisschen drüber zu gehen, das habe ich gerade erzählt. Regelmäßiger Export, also man kann permanent die Daten exportieren. Man kann Jobs laufen lassen, weil man kann ja auch Informationen, die nicht nur sammeln, sondern auch zurückschießen auf die Sensoren hinunter, sogenannte Commands, und kann das in Jobs automatisieren. Man sieht jetzt endlich Zugriff auf die Rohdaten. Das, was man praktisch früher immer die Kommandozeile aufmachen musste, sieht man jetzt auch im Web. Man kann Daten nachschießen, wenn man quasi Konfigurationen und Daten braucht, in größeren Mengen in beide Richtungen. Und was ganz Neues, aber leider sich für heute nicht mehr ausgegangen ist, tut mir viel sorry for that. Das werden wir im Sommer dann nachholen, sobald wir es live präsentieren können. Es ist jetzt durch den Support von IoT Edge ist jetzt auch Video Analytics als Edge-Komponente dazugekommen, genau dafür, wo man dann eben so große Azure Stack Edge Devices oder eben Video-CPUs auch lokal benötigt. Ein wichtiger Punkt, den ich heute live zeigen kann, ist die Device Definition Language. Es wäre ja toll, wenn man das nicht alles selber konfigurieren muss, sondern wenn eigentlich ein Sensor, der von sich aus ja eigentlich weiß, was er tut, von sich aus auch mitteilt, was er denn vorhat zu schicken. Und das passiert eben genau mit dieser Device Definition Language und teilt der Plattform mit. Übrigens, ich bin ja den Temperatursensor, ich habe Temperatur zu melden, und zwar in Celsius und in Fahrenheit. Und dadurch funktioniert eben genau IoT Plug and Play, damit jegliche Art von Sensor, wir haben einmal so gescherzt, ein ganzes Flugzeug könnte ja ein IoT-Sensor sein und könnte ja eine komplette Beschreibung mitschicken, was es denn alles zu leisten vermöge. Ich glaube, der Helmut Otto weiß, von was ich rede. Das ist von kleineren Dingen einfach klar. Ich zeige noch CO2-Sensoren her, Luftgütesensoren, einen Push-Button. Ich habe vor mir liegen dann einen Temperatursensor aus der Industrie, Abstandsmesser. Also das sind ja alles Sensoren, wo ja die einzelnen Dinge schon wissen, was sie tun, und können das damit auch automatisiert provisionieren. Ganz eine tolle Sache, weil damit diese ganze klickgebundene Sache einfach ein bisschen in den Hintergrund tritt. Was natürlich Device Twins auch kann, das sieht man in IoT Central noch nicht so toll, ist Relationships. Man kann jetzt die Dinge auch verlinken und sagen, übrigens, ich gehöre dort dazu, ich bin Komponente von, ich bin untergeordnet dessen. Das geht im Device Twin geht das schon, aber im IoT Central weiß davon noch nichts. Ja. Pricing, ganz neu, nicht mehr coming soon, sondern fertig. Massive Preisreduktion, weit unter dem, was die Mitbewerber sich zu nehmen trauen. Wir sind mittlerweile, es ist zwar 400 Messages jetzt nicht die Masse, aber für selten sendende Sensorik ist es einfach so, dass die Applikation praktisch verschenkt wird oder so günstig ist, dass man es wirklich in der Masse ausrollen kann, weil $1 pro Jahr ist einfach so ein Wert, das weiß jeder, selbst bei 40.000 Sensoren sind $40.000 im Jahr, ist keine große Sache. Also das ist etwas, das kann man sich leisten, wenn man sich das runterbricht auf einen Monat. 400 Messages, dass man ein bisschen ein Gefühl kriegt, das reicht für so Container-Tracking zum Beispiel. Wo steht meine Müllkippe? Wo steht die rum? Wie voll ist das Teil? Muss man es ausleeren? weil so ein Müllcontainer typischerweise nicht jeden Tag, jede Minute rumgeschoben wird, sondern da kommt der LKW, der stellt das auf, das bleibt ein paar Tage auf einer Baustelle stehen, dann wird es wieder abgeholt. Damit kriege ich 5, 6 Events und das reicht völlig. Ja, die Messages nach rechts. Ja, ich habe bei mir 30.000 Messages eingestellt, weil ich möchte, dass die Dinge relativ schnell reagieren. Man sieht, dass das zwar in Prozenten, ein Finanzer würde sagen, kostet ein Wahnsinn im Vergleich dazu. Und auch die Overage, eine K-Message kostet auch 0,00014 Cent, also so wenig wie nichts, aber 1 Gigabyte ist es dann doch bei 14 Cent. Na gut, es ist jetzt auch neu zusammengefasst, all diese Dinge in einer zentralen URL. Das heißt, man sieht jetzt auch alle seine IoT Central Applikationen, die man provisioniert hat, in einem Portal. Und zum Beispiel könnte das so aussehen, wo man einfach einmal einen Sensor sieht, der da seine Daten in so ein Dashboard hinein provisioniert. Vielleicht ein weiteres Beispiel, das wäre zum Beispiel vor einem Jahr uraltes Dashboard, wo ich mal versucht habe, Sensoren von meiner Terrasse da reinzubringen, also Temperatur, Luftfeuchtigkeit, wie hell ist es gerade, war offensichtlich schon eine Zeit her. Condition Monitoring von einem Kühlschrank, das wird das Ganze ein bisschen ernster. Das schaut dann genau so aus, nämlich wie ist die Temperatur im Healthcare-Bereich. Einerseits interessant die Umgebungstemperatur im Verkaufsraum, aber natürlich viel, viel wichtiger ist der heilige Kühlschrank warm oder kalt genug. Er muss konstant 5 Grad haben. Man sieht dann gleich, dass 5 Grad konstant einfach nicht funktioniert, weil es einen Kompressor gibt. Und kann sich solche Dashboards eigentlich relativ simpel und schnell zusammenbauen. Eine Sache, die viele, glaube ich, gesehen haben als separates Tool, ist Time Series Insights. Das ist mittlerweile auch integriert. Das heißt, ich habe da oben eine Zeitleiste. Das ist noch ein relativ junger Screenshot, den ich vorige Woche gemacht habe. Da sind noch relativ wenig Daten drinnen. Man kann hier eben auch Sensoren vergleichen und die gegenüberstellen. Jetzt kommen wir mal ein bisschen mehr in die Praxis. Wie legt man sowas an? Also, ich habe mir sowas gebaut. Am Anfang ist das alles sehr Prototyping-mäßig. Man geht ins Azure-Portal. Es ist der Startpunkt sowohl im Azure-Portal, aber es wird dann als App provisioniert und schließt seine Sensoren an. Das Beispiel hier ist ein Prototyp für ein Air Quality Monitoring Station. Ist ja gerade ein heißes Thema, weil man herausgefunden hat, man kann zwar nicht die Virenlage wirklich messen, aber man kann die verbrauchte Luft messen und das korreliert dann doch ganz toll mit der Virenbelastung. Verbrauchte Luft sind auch viele Viren in der Luft. Na gut, im Azure-Portal, wo wird es denn sein? Es gibt eine eigene Kategorie IoT Central Applications. Man wird diese gelistet und hat hier eine Liste an vorgefertigten Templates, die dann schon gewisse Sensoriken und gewisse Templates mitliefern. Ich habe das am Anfang nicht verwendet, weil das sind oft sehr testweise Dinge. Ich bin da eher der Hardcore-Nummer, aber man sieht dann auch, dass meine komplette Applikation, wenn sie dann einmal fertig designt ist und fertig gebaut ist, kann man dann auch eben exportieren und immer wieder weiter instanzieren. Ja, das Dashboard ist leider leer zu Beginn und schaut natürlich dann ein bisschen trocken aus, wenn man halt keine Sensoriken schon angeschlossen hat oder eben kein fertiges Template benutzt. Damit ist das ein bisschen eine trockene Baustelle, aber es ist zumindest einmal ganz nett verlinkt. Kurz auf die Uhr schauen für Time for Demo. Vielleicht gehen wir noch einen Schritt weiter. Jetzt zeigen wir das kurz her aus der Praxis. Ich habe Sensoren, die selbst gebaut sind und wenn sie selbst gebaut sind, sind sie in der Regel irgendwie, da kann man Hardcore programmieren. Ich verwende dafür eine IoT-Edge-Komponente, die man aus der Industrie sehr gut kennt und in vielen Industrieroutern einfach mitlaufen, weil viele Sensoren einfach so ein gewisses Mapping brauchen an Daten. Die Zeit vor OPC-UA hat man einfach oft das grafische Tool Innovate benutzt, wo man einfach so ein bisschen Daten manipulieren, ein bisschen Datenmapping, das Feld von links nach rechts rutschen kann, in einem JSON-File in die richtige Position rücken kann. Node-RED kann auch Protokolle konvertieren. Ich habe das da auf einer Folie zusammengeschrieben. Also es ist eine Open-Source-Lösung. Es ist eine Node.js-Plattform, kommt originär aus der IBM heraus. Und das ist einfach entwickelt worden. Es läuft auf vielen, vielen Industrieroutern. Also überall, wo ein Docker-Container laufen kann, kann man das anstarten. Also vom Raspberry angefangen über die ganze Industrieschiene. Es gibt von der Siemens so IoT-Gateways, wo das überall drauf läuft. Aber viel wichtiger, es spricht so gut wie jedes Industrieprotokoll. Also ganz egal, ob das ein Power Meter ist, ein Smart Meter ist, die reden meistens Modbus, Seriell oder IP. OPC-UA klarerweise, Siemens S7, MQTT, HTTP, da gibt es unzählige noch. Und super easy. Hat aber einen riesen Nachteil, der ist hier, darum ist das Ganze auch immer nur sehr, sehr, sehr beschränkte Sache, nämlich es gibt keinerlei tolles User-Management. Es gibt zwar User und Passwort, wie durchaus üblich, man kann das auch mit HTTPS ganz gut absichern, aber so richtiges Enterprise-Login-Management-System nicht. Ja, ein bisschen aus der Praxis, wie funktioniert dann diese Brücke? Das Dashboard aus der Apotheke habe ich zuerst gezeigt. Also meine Sensoren liefern über MQTT die Daten ab. Das heißt, es geht von links nach rechts. Über die MQTT-Daten kommen daher. Der Sensorwert wird einfach hier wieder ein bisschen verschoben und gemappt. Dann baue ich einen String zusammen, gebe die Device-ID, die von Azure IoT Hub notwendig ist, dazu und schicke es einfach an den IoT Hub. Ja, auch unter dem IoT Central läuft natürlich native der IoT Hub, gibt es nichts anderes. Genau der wird auch natürlich benutzt. Ich zeige dann ein paar Varianten her. Zu den Daten zu kommen, gibt es entweder die Möglichkeit mit dem AC, also AZ-Kommando, den Connection String herauszubekommen oder mit dem älteren Tool Device Provisioning, Key Generation, wo man eben aus seiner Scope-ID, also das, was die Applikation instanziert, herausbekommt. Die Daten tragt man dann ein, ich zeige das gleich live her. Eine weitere Variante, wenn man dieses ganze Node-RED-Gedöns nicht braucht oder nicht möchte, gibt es auch mittlerweile eine ganz nette Lösung, die natürlich auf Azure gehostet ist, eine IoT Central Bridge. Das ist nichts anderes wie eine Azure Function, die man auch on-prem auf Azure Stack Hub hosten kann man auch auf Azure Stack Edge hosten oder eben auch in der Cloud. Hier mit dem Deployment-Button läuft es natürlich auf Azure, das genau dieses Mapping macht. In der letzten Variante gibt es eine neue Methode, wo man sich viel diese Dinge schafft. Und man sieht hier, das ist wieder in dem Fall ist das ein CO2-Sensor, der liefert diese Daten so ab. Das Mapping ist, also ich konnte kein JavaScript, aber ich glaube, das kann jeder lesen, was daraus entsteht. Das ist genau dieses Ding da dazwischen. Also da wird der CO2-Wert in den CO2-Value und der Temperaturwert übernommen. Und dann gibt es eben ein neues Node, der dann eben diese drei Werte da eintragt und man spart sich das ganze DPM-Zeug und die Lösung schlussendlich schaut dann so aus. So, Demo-Time. Ja, ein bisschen will man das vielleicht auch live zeigen. Schauen wir mal, wie toll das funktioniert. Also, beginnen tut alles im Azure-Portal. Im Azure-Portal sieht man, ich habe hier einfach ganz normal meine Ressourcegruppen und meine Ressourcen und so eine Ressource wie ein IoT Central ist nichts anderes wie einfach eine Azure-Ressource, die heißt da IoT Central Application und die ist da kann man auch nicht besonders viel einstellen und besonders viel tun. Das Einzige, was man hier macht, ist, hier auf die App klicken, man kommt direkt in seine Applikation hinein. Wenn man eben ich habe das auch gesagt, das ist jetzt nicht besonders toll. Das ist ja das Erste, was ich jetzt mache, ist, habe jetzt Wochen darauf gewartet, dieses Dashboard löschen zu dürfen, dass es endlich weg ist. Man sieht dann eben ein anderes Dashboard wie dieses. Das heißt, wenn man kurz beginnt, wir haben Azure AD Login. Das heißt, ich kann hier, kenne ganz normal das normale Login-System. Ich habe hier unten eine Übersicht all meiner IoT Central Applikationen. Ganz wichtiger Hinweis, warum braucht man mehrere Applikationen? Derzeit ist es vom Berechtigungssystem her nicht möglich, die Sensoren zu filtern. Das heißt, ein Subset an Sensoren gehört einer Applikation. Weil ich das noch nicht filtern kann, es wäre zwar in der GUI schon vieles davon vorbereitet, aber es ist einfach noch nicht da. Das ist quasi meine Uralt-App, die von den Screenshots her zeigt. Das ist mein Kühlschrank, brav mit 4,7 Grad. Man sieht ja da jetzt rechts, habe ich schon den Stromverbrauch erinnern, dass der natürlich regelmäßig die Kühlung einschaltet und dann eben von ein paar wenigen Grad raufgeht auf seine ca. 100 Watt Stromverbrauch. Da sieht man schön, wie der Kühlschrank läuft. Man sieht ja hier von der Menüführung her, da ist noch nicht viel, da fehlen zum Beispiel die Rules, also da gibt es dann Dinge, wo man Dinge machen kann in der Administration, kann ich da die Applikation customizen, ich kann auch hier Mitarbeiter einfach berechtigen. Aber vielleicht ein bisschen zu den neueren Dingen, das Azure-Portal braucht man nicht mehr, mein Dashboard ist einfach hier, man sieht ja da, dass es gecached hat. Das heißt, ich habe meine Sensoren. Der Sensor, den ich zeigen möchte, ist diese. Achso, jetzt kommen wir mal zu dem lustigen Teil. Ich kann das nämlich hoffentlich einblenden. Das habe ich mal extra hergerichtet, dass ich die Kamera einschalten kann. Die zweite Kamera. Dann sollte man nämlich hier, das ist der Sensor. Das ist Livecam, also nichts Fake. Das ist das Gerät da hier und zeigt auf einer lokalen Ampel den Sensorwert an und zeigt auch hier brav, dieser Wert ist es, der geliefert wird. Das heißt 600 ppm, das heißt eigentlich noch gut gelüftet. Die Firmware, die da drauf läuft, ist Tasmota. Das ist eine Open Source Community Software, die auf einem ESP8266 läuft. Da kann man eigentlich benutzen, was man möchte. Natürlich geht es auch mit Azure Sphere. Ich habe einfach nicht die Zeit und die Lust gehabt, da irgendwas zu programmieren. Ich glaube, die wenigsten wollen irgendwas selbst programmieren, sondern wollen einfach was benutzen und verwenden und einfach bedienen. Das Einzige, was man machen muss, ist, habe ich in einem Blogpost geschrieben, man muss es selber kompilieren, damit man hier auch verschlüsseltes MQTT bekommt und die Daten dann auch quasi auf meinen zentralen MQTT-Broker sendbar sind, sonst ist es nur unverschlüsselt. Und man sieht auch hier in einer Konsole, relativ schön, ich bin jetzt gespannt, ob das Zoomen funktioniert. Man sieht auch hier schön diese Werte, wie er da seine Werte brav als JSON mitschickt. Das heißt, wir sind da bei ca. 600 ppm aktuell und sehen dann diese Werte. Das ist meine Bridge dazwischen. Das ist meine CO2-Ampel Blackbox. Das ist genau dieses Teil hier da. Und jetzt kann man die Kamera dann wieder umschalten. Man sieht eben, wie gesagt, das geht von da links weg. Also das ist recht nett. Man kann das da so rumziehen. Man kann dann den Wert, jetzt ist schon auf 614 rüber geschwappt. Da drinnen sieht man dann eben, das ist nicht besonders spooky. Also ich tue da einfach diese zwei Werte schicken. Temperatur schicke ich mittlerweile auch mit. Dann schicke ich das in den Unterknoten. Das ist alles JSON oder ein JSON-Objekt und schreibe da den Wert in den Unterbegriff Data rein, setze noch den IoT-Hub dazu, dann setze ich da noch die Security-Werte dazu, wie mein Device heißt, und ab in die Cloud damit. Und genau der Wert taucht dann hier, Devices, Air Quality Sensor, da ist meine Blackbox, da sind meine Raw Data, sollten wir da 611 waren es am Anfang, das ist da gewesen, dann sind wir jetzt bei 614, wenn ich ein bisschen reinhauche, dann wird es raufgehen. Seht ihr meine Werte. Ja, das ist so weit, wie das Sensorik, der Weg von meinem Sensor lokal ab in die Cloud funktioniert. Ein bisschen möchte ich natürlich mehr sehen, weil das ist jetzt der Weg WLAN, Sensor, der bei mir da im Zimmer steht, wird ein bisschen durchkonvertiert und über MQTT in die Cloud geschickt und dann da im IoT Central tauchen meine Sensoren auf. Richtig cool wird es aber erst, wenn der Sensor vielleicht nicht bei mir zu Hause steht, sondern eben irgendwo anders unterwegs wäre. Das heißt, ich verwende Sigfox dazu. Sigfox ist eine Funktechnik, sehr ähnlich, vielleicht kennt jemand LoRaWAN. Sigfox ist quasi die Business-Ausprägung, ein bisschen als Mitbewerb zu sehen, ist europaweit verfügbar, ist sogar weltweit verfügbar, aber mit dieser Frequenz in Europa verfügbar, existiert auf allen Kontinenten und schickt immer auf ein zentrales Backend. Von dort kann man sich dann hinschicken lassen, wo man möchte. Natürlich auch IoT Hub und damit auch IoT Central. Was habe ich für einen Sensor mitgebracht? Ich habe einen CO2 und Air Quality Sensor, der liegt bei uns in Linz bei der Firma Cubito, dort direkt in der Cafeteria. Das heißt, die Leute wollen dort auch wissen, wann ist die Luftdicke und wann ist Zeit zum Lüften. Genau das kann man damit umsetzen, mit wenigen Schritten. Es ist auch natürlich dadurch, dass es keinerlei Roaming-Gebühren und all diese Dinge gibt, die man bei NB-IoT vielleicht bezahlen müsste. Also ich sitze hier in der Nähe, sieht man dann gleich, im nördlichsten Nordburgenland. Ich verwende hier die Sendemasten schon aus der Slowakei mit. In Wien haben wir tolle Netzabdeckung, in Salzburg verwendet man schon das Deutschlandnet mit. Also man kriegt es einfach nicht mit und kann die Use Cases hauptsächlich für so Logistik und Location Services benutzen, weil es eben über Land auch einfach toll funktioniert. Also aus jedem LKW, aus jedem Auto rauszusenden. Es ist einfach eine Funktechnik. Was sind die typischen Sensoren, die wir so umsetzen? Das ganze GPS-Tracking, habe ich schon erzählt. Also die typischen Müllcontainer, wobei es rentiert sich nicht wirklich bei so kleinen Mistkübeln, aber sobald das einmal ein gescheiter Container ist das schon ein Thema, zu wissen, ob der voll oder leer ist. Man kann mit einem IoT-Button, wer kann sich nur an den Dash-Button erinnern? Beim Dash-Button kurz das Video einblenden. Der Dash-Button schaut vielleicht bei manchen so aus. Das ist halt ein Sigfox Dash-Button, der sendet 10 Jahre lang Drücke, Bewegungen, Temperaturen, Licht. Der kann unfassbar viel Dinge. Man kann aber das Ganze natürlich auch das Air Quality Monitoring machen, Vehicle Tracking machen. Und was bei diesen Sensoren auch sehr, sehr cool ist, die machen Location-Based Services innerhalb eines Gebäudes mit dem Scannen von WLAN und Bluetooth-IDs und schicken die einfach über das Funkprotokoll mit raus. Und dann schaut einfach mein Dashboard plötzlich so aus. Schaut mal wieder ein bisschen auf die Live-Demo um. Das heißt, ich habe da meinen Dashboard, das genau mit dem richtigen Sigfox. Das heißt, ich kann mir das da zusammenbauen, ein bisschen zoomen. Ich habe hier, da ist das Bild, so schaut das Teil aus. Also so klein wie es da ist, ist es nicht. Das ist ungefähr so 10 x 10 cm groß, relativ schwer. Es ist deswegen schwer, weil ein relativ großer Akku drinnen ist. Die Laufzeit von dem Teil soll bis zu 10 Jahre sein. In der Praxis sind es eher so 3 bis 5 Jahre. Abhängig ist es davon, wie oft er schickt. Wir haben jetzt auf die häufigste Schicken eingestellt. Das sind 140 Nachrichten pro Tag. Das heißt, alle 11 Minuten schickt er die Werte. Und wir sind eben in Linz, ich habe den Damen schon Bescheid gegeben, 900 ppm. Das heißt, so ab 1200 soll man lüften, darum habe ich es jetzt gelb gemacht. Diese Dashboards sind unfassbar leicht zusammenzubauen. Das kann sich auch jeder Mitarbeiter selber machen. Im IoT Central kann man sich eben application-wide Dashboards bauen oder private, also die nur ich sehe oder eben meine Kollegen auch. Und dann kann man eben auch hier diese ganzen Schwellwerte konfigurieren und da hier zum Beispiel die Farben einstellen, wann soll er welche Werte anzeigen. Das heißt, man kann hier ein bisschen so ampelmäßig bauen. So richtige, schöne Ampel, wie ich schon mal gebaut hatte, gibt es leider nicht. Ich sehe dann auch hier den Verlauf. Das ist hier drinnen, man sieht da hier dann der letzte 12-Stunden-Verlauf. Das heißt, für meine Kollegen, die da mithören, das sieht man auch schön, dass die Heizung immer so circa 5 Uhr, 5:30 Uhr in der Früh loszischert und dann tagsüber einfach die Temperatur schön raufgeht. Man sieht das dann in den Werten von gestern, dass dann um ca. 19 Uhr sie die Werte wieder ausschalten. Nochmal kurz die Kamera eingeschaltet. Also ich habe zum Beispiel den Sensor, der dieses Ding ist, der Sensit nennt sie das. Wenn man den schicken lässt, das ist genau das Ding, was da unten hinein postet an Informationen und Daten. Jetzt habe ich den auch gerade drauf gedrückt. Das heißt, das sollte sich dann jetzt auch dann gleich aktualisieren, die Werte, was der an Temperatur und Luftfeuchtigkeit so misst und einsammelt. Man kann sich hier auch auf der rechten Seite, sieht man ein bisschen weiter rechts, ganz coole Dinge tun. Natürlich kann man sich auch hier einblenden lassen, wo natürlich, weil bei Location-Based Services schickt ja entweder der Sensor mit über Funktriangulation, das ist so wie da, der Sensor schickt nämlich das nur so ein bisschen mit, darum glaubt er auch, dass ich mitten in Bratislava auf der Brücke sitze. Ich bin aber in Wahrheit, der Sensor schickt Wi-Fi-Location mit, damit bin ich da auf ganz knapp bei meinem Haus hierbei, wo er das mitmisst. Jetzt hat man gerade gesehen, dass er es aktualisiert hat. Also ich habe den Button gedrückt, jetzt ist er da ein bisschen rumgesprungen, also das ist da wirklich eher so eine Wurfpassung, also 8 Kilometer Radius ist das rechte, wenn er es quasi nur über Sigfox misst und das linke ist schon sehr genau, weil er die WLAN-MAC-Adressen herausmisst. Was kann IoT Central sonst noch? Wie gesagt, es sind Devices. Die Devices haben eine Kategorie. Eine Kategorie hat dann eben eine konkrete Ausprägung. Es gibt eben die RAW-Daten, die das Ding mitschickt. In einem Fall da alle 10 Sekunden. Kann man die Daten da so ein bisschen ein Device-Dashboard voranzeigen lassen. Ich kann mir natürlich aber auch device-spezifische Cloud-Attribute hinzufügen, einfach um zu zeigen, um das als Schwellwert zu sehen. Könnte es sein, dass der Schwellwert von dem einen Sensor ein anderer ist, wie von einem anderen Sensor. Also zum Beispiel der in Linz hat einen ganz anderen Schwellwert drinnen. Mit Rules kann ich dann so Alerts hinterlegen. Das ist der Wert, wenn das Threshold das Threshold drüber steigt. Wenn es der 5-Minuten-Condition übersteigt, dann bitte ein E-Mail schicken oder ein Webhook. Da unten, ja, man sieht das eh. E-Mail, Webhook, ganz cool. Monitor, es geht in Azure Monitor Action Groups hinein, es geht in Power Automate hinein und es geht in Azure Logic Apps hinein. Das heißt, man kann die Brücke schlagen von Sensorwerten ins SAP, von einem Temperatur-Alert in sein ServiceNow, von seinem IoT-Button rein in ein ITSM-Tool. Also diese Brücke kann man sich genau damit bauen. Dieses Analysewerkzeug habe ich kurz hergezeigt. Man kann hier CO2-Werte dann auch vergleichen. Hier sieht man eben das Digital Analytics. Wenn wir den Sensor aus Linz ausblenden, dann sieht man auch, meine 2 Sensoren stehen quasi einer am Schreibtisch und einer ein bisschen höher. Die sind schon ziemlich genau die gleichen, wenn man nämlich die Sensoren in der Qualität ein bisschen bemessen möchte und vergleichen möchte. So, mir geht die Zeit aus. Das heißt, ich muss im Vortrag weiterkommen. Das war live. Eine ganz andere Ecke. Es geht ja auch die Möglichkeit, dass das nicht über Funk geht, sondern es gibt ja auch die Möglichkeit aus der Industrie. Dafür gibt es ganz coole Sensoren von der Firma IFM. Ich glaube, die kennt auch jeder, der in der Industrie schon ein bisschen zu tun hat. Das sind so orange Dinge, so richtig was Gescheites. Und auch mit denen geht es ganz, ganz toll. CloudRail ist dann der Lösungspartner, der das Edge-Device gebaut hat. Das zeige ich dann auch gleich live her. Und kann eben genau diese IO-Link-Sensoren, also das ist so ein richtiges, cooles Kabel, so mit Bajonettanschluss. Ich zeige gleich ein Foto dazu, dass das einfach in die Cloud schickt und auch OPC-UA abholen kann. Verwendet Plug and Play, genau diese Digital Twin-Geschichte. Optisch schaut das Zeug so aus. Das heißt, ich habe die Sensoren, den links, den Sensor, der Temperatursensor, der da daherkommt. Schaut ein bisschen basic aus, das Teil. Das ist ein IO-Link Master in der Mitte. Das auf der rechten Seite ist das CloudRail Edge Device und schickt es bei mir da rein. Vielen Dank an die Firma CloudRail und IFM. Gestern kam die Hardware an, so war das Package. Heute habe ich es dann so zusammengebaut. Und so, schauen wir, ob das Bild jetzt ankommt. Und so schaut es live aus. Das ist das Zeug, das dann rumsteht. Ich weiß nicht, wie gut und wie verzögert man das sieht. Das ist eine LED-Lampe. Da links habe ich einen Laserabstandsmesser mit einem Laserding. Da oben habe ich einen Temperatursensor. Und wenn wir die Zeit jetzt noch haben, dann kann ich den jetzt noch live einbinden in das IoT Central. Und werde das jetzt versuchen als Demo, nämlich, dass man hier volles Risiko, das ist immer bei Live-Demos so, das heißt, ich habe da meine Box, in der Box drinnen, das ist das Management-Tool und diese Box kann eben genau die Verbindung schaffen von meinem IoT Central. Ich habe das am Anfang geglaubt, ich kann das auch nur live anschließen, dann taucht das auf. Also ich muss mir entscheiden, ist das ein OPC-UA-Sensor oder eben Brownfield, also irgendein angeschlossener. Ich habe dann aus meinem IO-Link Master, das ist wirklich Plug and Play, also ich stecke das Teil an, der taucht hier auf, der Temperatursensor, sage ja bitte, ich hätte es gern nicht on change, sondern vielleicht machen wir das jetzt schneller, im 2-Sekunden-Rhythmus, die Daten, wo schicken wir es denn hin? Oh, da gibt es ganz was Tolles, nämlich mein fertiges IoT Central. Ja, CloudRail kann auch anderes und fremdgehen, aber in meinem Fall machen wir da jetzt einen Industrial Temperatursensor. Und jetzt passiert was ganz was Witziges. Ich habe meinen IoT Central Connection String hinterlegt und in meinem IoT Central, wenn man das hier schaut, war vorher noch nichts drinnen. Ui, jetzt war ich zu schnell. Jetzt ist es leider schon da. Der hat jetzt live diesen Sensor durchgemappt mit diesen Fähigkeiten aus der Device Definition Language, mit diesen Beispielwerten, sieht man hier schön, und hat die Werte da durchprovisioniert. Also ich kann das dann gleich live herzeigen mit meinem zweiten Sensor. Das ist hier der Laserabstandsmesser, der ist noch nicht da. Der Laserabstandsmesser, neue Connection, Brownfield. Das ist da der Laserabstandsmesser, ziemlich cooles Teil. Ich sage ja, gern, ich hätte das auch gern im 2-Sekunden-Rhythmus, passt. Man kann das runterbringen bis zu 50 Millisekunden, ist ganz okay. Ich nenne den jetzt Distance. Man sieht jetzt, während er das da anlegt, Update Available, wenn ich da drauf drücke auf Refresh, also das geht hooky spooky, da Refresh, zack ist der Sensor schon da. Unglaublich schnell, das ist Plug and Play. Ich stelle dann da rein, drücke dann auf Raw Data, zack, und der liefert da schon die Werte mit. Unglaublich schnell, im 2-Sekunden-Rhythmus füllt er mir da die Datenbank an und sehe dann auch hier schon als Wert in meinem Dashboard, schaut es jetzt ein bisschen traurig aus, weil das ist natürlich nicht vorbereitet oder nicht vorbereitbar gewesen. Aber wie bringe ich das da rein? Kann man natürlich jetzt hier auch wieder meine Sensorgruppe heraussuchen, meinen Temperatursensor, den einen Sensor, den ich da drin habe. Sage ja gern, ich hätte die Temperatur in Celsius, bauen wir das da rein, ziehen wir das noch ein bisschen hübsch, kann man das richtig schön konfigurieren, kann man das vielleicht noch ein bisschen benennen. Ich glaube, man kann sich da ungefähr vorstellen, was Sache ist. Habe dann da meine letzten 100 Werte vielleicht und sage, ja, wunderbar, tolle Sache. Das geht natürlich auch als diskreter Wert. Ich sage, ich mache das da so, schreibt man das um, Last Value, schiebt man das da schön zusammen, wenn man das da her, kann das dann benennen, umkonfigurieren, ein bisschen hübsch, ein bisschen groß machen. Ich glaube, man kann sich das jetzt gut vorstellen, was die Sache ist und wie das geht. Ja, speichern, freigeben. Wenn der Kollege dann Fragen hat, kann ich das sehr gerne ein bisschen live zeigen. Das waren so die Eindrücke aus der Demo, wie schnell das online geht. So schaut es aus, wenn man es dann noch ein bisschen einfärbt, mit Schwellwerten, kann man das sich auch im Hintergrund ein bisschen anschauen. That's all, folks. Ja, 50, unglaublich. Jetzt habe ich auf die Tübe gedrückt. Ich verspreche, hoch und heilig, ich werde das live herzeigen, in person, sobald es geht. Es ist unfassbar schwierig, das in so einem Digital-Event zu machen. Ich gelobe, und sobald es geht, Termin kommt. Wir danken allen aus dem Organisationsteam und auch als Speaker, dass solche Dinge möglich sind, an die Sponsoren und darf herzlich mich bedanken. Ich hoffe, es war was Interessantes. Ich hoffe, es war ganz was anderes. Und heute kommt noch der Helmut mit den Kubernetes-Teilen. Wichtiger Link, Azure Stack Edge oder Kubernetes ist eine Untergrund, damit IoT Edge läuft und braucht richtig coole Hardware in den Shopfloors der Industrie heute. Vielen Dank und ich stehe gerne noch für Fragen bereit.
Okay, danke Stefan. Ja, und wir werden uns auch vom Experts Live her bemühen, möglichst schnell einen In-Person-Event machen zu können. Ich meine, die äußeren Bedingungen sind halt momentan nicht so wahnsinnig günstig, aber wir tun uns halt als Experts Live teilweise leichter wie große Organisationen wie Microsoft oder ähnliche. Also sollte man schauen, hier und da auf die Webseite schauen. Wir hoffen, dass man schon, ja, wenn es besser aussieht und vor allem, wenn es wärmer wird, dass wir was in Person machen können, wenn auch mit Auflagen. Okay, gut, dann kurze Pause.
Ich habe noch eine Frage.
Ja.
Da ist noch eine Frage aufgetaucht. Ist die Datenspeicherung nur in IoT Central möglich oder auch in Log Analytics? Die Frage kann man natürlich auch freigeben. Um das zu beantworten, da geht wahnsinnig viel. Ja, und man kann es natürlich in Log Analytics schicken, nämlich genau mit diesen Exportfunktion, wo quasi zuerst sammelt einmal alle Sensoren bei sich und dann hinten raus in Service Bus, in Event Hub oder in Log Analytics. Das sind die 3 Ziele, die mir jetzt einfallen, plus Webhooks, plus Logic. Also bei den Destinations, ich habe das jetzt nicht herzeigen können, da geht wahnsinnig viel.
Okay, und dann ist noch die Frage, hat jeder Sensor die Definition Language?
Also man muss so sagen, wenn der Sensor diese Fähigkeit, diese Definition Language von sich aus nicht mitzuschicken, was die wenigsten, muss man sagen, heute können, ja, dann ist es so, dass man das einfach händisch sich zusammenklickert, nämlich das Interface, was kann der Sensor, welche Werte hat er vor mitzuschicken, und damit baut man quasi diese Definition Language, ohne dass man es weiß, baut man es halt in der GUI die Sachen zusammen. Ja, insofern, ja, jeder Sensor hat sein Device Template, das Device Template beschreibt diese Dinge und entweder das kommt eben automatisiert über Plug and Play oder man macht es einfach in der GUI zu Fuß.
Okay, dann sage danke. Und
ich danke schön.
Schönen Nachmittag. Okay, dann
Bye.
Pause bis um 15 Uhr, bis Didier dann wieder kommt. Danke, tschüss.
Businesses are rapidly adopting cloud computing, taking advantage of its flexibility and speed. Whether consuming SaaS applications, building cloud-native applications, or migrating existing applications to the cloud, finding a security solution that addresses a diverse set of needs is critical. Fortinet Cloud Security Solutions deliver. Get the confidence you need to deploy any application on any cloud supporting any initiative. Fortinet supports all major cloud providers, ensuring that critical assets are secure and that security is manageable. The Fortinet 3-pillar cloud security strategy provides the same level of security across multiple clouds by natively integrating security into the cloud platform, defining security policies for cloud services, and leveraging cloud services for security, ultimately enabling automation of security services. Fortinet provides the industry's broadest set of cloud security products, enabling you to use the same security in the cloud as you have on premises. By using purpose-built security tools in the cloud, you'll save time by leveraging existing skill sets. By managing security across multiple clouds through a single pane of glass, and by automating the security lifecycle management, you can better leverage existing skill sets and accelerate the confidence to deploy applications anywhere. From consuming cloud applications to building applications in the cloud and migrating IT to the cloud, Fortinet Cloud Security Solutions cover the broadest set of use cases, delivering the flexibility and confidence to use the cloud in a way that best serves your business.
Hello there.
Hi, Didier. I like the picture with the bear on your side.
He's my buddy.
Was it in the US?
Yes, absolutely. I have. They built a number of them, and they're numbered. And I've been collecting pictures of me with him on several locations, so I'm trying to find them all.
Okay.
But Corona is putting a bit of a stop to that at the moment.
Yeah. Yeah, it's still 2 minutes left.
Yeah. So how is it going? Still?
Yeah, still nice on track at the moment.
At 100 users in the morning, that was nice.
Yeah, 120.
Yeah, I mean it's an early start, right? I mean it's nice.
Yeah, it's great. But now it's Friday afternoon, so
yeah,
it's after lunch and after work.
Yep. I told my team coach I have a hard stop on Friday. Bye-bye. For some reason, the background isn't working for me. I can't.
That's the do's and don'ts with Microsoft Teams, like the real nice problems with audio in the morning.
Yeah, that was a bit disconcerting. I was like, is it me at the first? I was like, am I dropping my internet connection?
No. It was the line to Cosmos.
Because for some reason they're breaking up the entire neighborhood from the telcos to put in cables. So I was like, oh no.
Yeah. Okay. Yeah, I think we can start. So I now proudly present Didier van Hoye, Twitter handle working hard in IT, who will tell us something about Azure Virtual One for everyone. And yeah, it's a personal pleasure for me to have Didier here today with his session. Thank you.
Well, thank you, Helmut. That's very nice of you. So Azure Virtual One is indeed for everybody. So we're going to dive into that. And we're going to look at what it is, why you would use it. We'll be discussing what a hub is and how the routing goes, what connections are, how gateways work. We'll talk about a secured virtual hub, because once you have one, you might find it a good idea to secure it. And we've already seen some things about security today. And then also monitoring and diagnostics is very important. And it's all integrated in the Azure platform. So let's dive in. What is it? Well, this is the definition Microsoft gives you. It's a global networking service that allows you to easily leverage the Azure network backbone. That's an important one. They like that. To build private high-speed global transit network architectures. So what does that really mean? Well, that Azure global network backbone, you can use it not just to talk in Azure, between Azure regions or subscriptions or whatever, but also to your customer locations, your data centers, your branch offices, and so forth. So you might think, if you've worked with Azure for a while, well, basically we can do that today, right? And what is so special about that Azure Global Backbone? And why would we use this instead of what we already have? Well, the Azure Global Backbone, it's a nice image from Microsoft. The thing you need to know is it's a vast network across the entire globe, and it has petabytes and terabytes of capacity. That means that wherever you are in the world, if you have an internet connection and you want to connect to Azure, you will get there very fast, which means that the latency will be minimized and the speed will be optimized. And there's a company that's called 1000 Eyes. Every year they do a comparison between all the big cloud players and their backbones, because everybody is trying to leverage their own backbone to deliver services to their customers. Well, Microsoft always comes up on top. There are some edge cases where that might not be the case, but still Microsoft is always the one that has the lowest latency and the fastest speed wherever you are in the world. So that makes it interesting to do all your networking as much as possible on their backbone, because if you have to implement it with telcos or implement it yourself, it's going to be very expensive, and you'll never get to that amount of bandwidth and that level of high availability and SLAs. So that's good to know. And then why would you use it? Why is it so important for you versus what we do now? Well, to make things easier. Because if you have done networking at small scale, at a larger scale, you know this concept, right? The hub and spoke model, where you create the transit VNets that have the gateways, the VPN gateways, the express route gateways, where you might deploy firewalls, everything you need to connect to on-premises locations or to end users. And then you have to connect all your other VNets. You have to pair them to that transit VNet, and then you have to build up your connectivity. But it takes a lot of work. If it's a very small deployment, it's not that much, but then you grow a little bit and you have extra VNets, and you have to remember to do this for all your VNets. Then you have to deploy an NVA, a network virtual appliance, if you want to have the VNets talk to each other, because this is not transitive, right? They can talk to the transit VNet, and they can talk to on-premises if you can configure it correctly, but they can't talk to each other. So if you want to do that, that's extra work, extra pairing or network appliances that take care of that for you. And that becomes a bit of a management burden. It becomes more complex and tricky. If you make a mistake, things go wrong. So Microsoft wants to replace this by this. And basically,
You still, of course, have your regions and your VNets, but what you see here is the virtual one hubs in regions. And those hubs are going to replace that transit VNet and are going to become the routing heart of your Azure Virtual One, so to speak. So that's basically what it is. So let's dive in a bit, because there's more to it. The global transit that Microsoft always talks about is actually everything you connect up to Azure Virtual One, if you do the defaults, is transitive and can talk to each other. So that means that VNets can talk to VNets, a branch can talk to a VNet can talk to a branch, branches can talk to each other. You can have VPNs connect over ExpressRoute to a data center, etc., etc. So that's pretty cool, and you don't have to do anything. It's done for you behind the scenes automatically. So that hub with its gateways becomes the place where you connect all your sites, your offices, your home workers. You can use site-to-site VPNs, you can use point-to-site VPNs for road warriors, or you can also use ExpressRoute if you want, but it's all in the same construct, that hub. For routing, you have the default routing tables that are associated with a hub, and then there's the non and the custom route tables, which you can use to manipulate how the data flows and make sure that things that need to talk to each other or are not allowed to talk to each other get routed appropriately. So this also integrates with Azure Firewall, with the new Firewall Manager that uses the policies to configure the firewall. That became available somewhere, I think, early this summer. And that's the way to go. You will see all the new developments, I think, for Azure Firewall be delivered by the firewall policies and the Firewall Manager from now on. And of course, there's a lot of integration with all kinds of partners, both for the branch connectivity as well as for the firewall, as for virtual appliances, but also for services. And we'll have a look at that as well. Monitoring is always important, and everything you do in Azure Virtual One is integrated into the monitoring that Azure has for you, and we'll take a quick look at that too. So now, if you think about Azure Virtual One, Azure Virtual One is the concept, the service, the global service, but it exists out of at least one Virtual One hub that you have in a region, and you can only have one hub per region within a single Virtual One. And this is what it looks like, right? You have connectivity to the internet if you want, you have the different VNets, you have your express routes, site-to-site and point-to-site VPNs, and this is the Microsoft story. But you can go beyond that. There is no reason why you couldn't put a site-to-site VPN or even direct connect gateway to an Azure Express route up to AWS. Some people offer that. The site-to-site you can do yourself. This one, some telcos offer that to you. But it could be Google Cloud, it could be Alibaba, it could be a managed service provider, it's private cloud. So you're not tied into the Microsoft Azure stack only. You can talk to anything you want, basically, as long as you set up the connectivity. So the components of an Azure Virtual One, as we mentioned, that Virtual One is your single pane of glass, right? That's important. That's where you manage it all. But it's actually the construct where all the other components of Azure Virtual One live. And the hub is the most important one. Why? Because that's the gateway, that's the heart where everything connects to each other, and routing and security can be deployed. As said, you can only have one hub per region, and you will select them based on your locality, right? If you're in Europe, you will choose the region the most, let's say, obvious to you. It's no use taking one in Australia if you're in Europe. As we said, it replaces that transit VNet construct with all the efforts you have to do there to make it work. So that's the making things easier part of it all. And the address space they have to get it's done for you upon creation. You don't have to do much with it, just make sure it's one that's not in use already. So if you look at that hub, then you have that major component in the hub, that's the connectivity, right? So that's the site-to-site VPNs, the user VPNs, and the express route circuits, but also the VNets, the virtual network connections. So at the moment, you have a virtual network, you can pair it with a Virtual One, and then it becomes a virtual network connection with Azure Virtual One. There's about 500 spokes you can create that way. That's a pairing limitation at the moment. I think that's one they might break in the future, because things are scaling out and up more and more. So I think they're going to break that one soon. If you look at the hub-to-hub connectivity, that's also an important one, because as we said, you have one hub per region, but those can talk to each other, which is very interesting, because that means that everything from this region can talk to everything in another region. So it becomes really that global transit network that Microsoft likes to talk about. And the routing, of course, the hub is that routing construct. We said you had the default route table, the non-route table, but you also have the custom route tables for VNets. And these are all constructs to manipulate how the data flows. Now, they are populated manually or dynamically via BGP. And as always, if you do things manually, they override what is done automatically. So if you look at a VPN site, there's something interesting going on there. It's always an active-active tunnel per link, and you can have multiple links, which means that even a single link has an active-active tunnel for fast failover and redundancy, but you can have multiple links up to 4, which means that you can have multiple ISPs providing you redundancy, but also failover and bandwidth aggregation, or depending on your device you use on premises, that they select the most appropriate link, looking at bandwidth or latency. So there's intelligence in there, and it's quite nice. And then there's 2 virtual WAN types you need to know about. One is the basic one that only supports site-to-site VPNs. So you can talk to Azure from a branch, or from Azure to a branch, or from a branch to a branch, but you cannot do point-to-site or express route. You can connect your VNets, but the VNet pairing, the automatic pairing, is not there. So you would have to take care of that yourself in some way. And the hubs themselves are not connected, so there's no global transit. Why would you use this? Well, there are people that just want to replace their or deploy software-defined WAN based on the Microsoft global network because it's so great and fast. Well, this is it. It's the minimum deployment you need to do that, and that's what it is. Now, the more interesting one might be the standard, where you get extras, of course. So you have the multiple hubs that are connected to each other in a full mesh. You get express route and the point-to-site VPNs. So anybody can talk to anybody over the entire globe, which is nice. And it scales, of course, beyond what you can do today. But that's true for basic as well. But this is the one that has everything, every component available to you. Now, a site-to-site VPN, if you look at it, the multi-link support we mentioned, right? So the dynamic distribution, path selection, you have a tremendous amount of providers that give you the hardware for that. Basically, anyone that's on the supported list for VPN gateways will also work with Azure Virtual WAN, so that's not a problem. The redundancy, we've mentioned that they can select the link that is up, they give you reliability, etc., etc. And of course, important, the cost reduction. If you deploy your SD-WAN based on Microsoft, or you replace your MPLS based on a Microsoft SD-WAN solution, there is a significant potential for cost savings over there. The scale is another one. You have up to 20 gigabits of aggregate throughput. So that's quite large. And you can have 1,000 site-to-site connections per hub, which is also considerable, especially if you look at the normal VPN gateways, where it's, I think, 30 or something. So this is a big difference. IPv 1 and 2 is there, just depending on what you have available on premises. You can use fully qualified names for your IPsec. You have dynamic DNS support in Azure. You can build your own dynamic DNS in Azure at the moment. So you're not depending anymore on some of those services if you don't want to use them. And you can do custom BGP and APIPA, which is important if you want to connect to other clouds like AWS. The point-to-site is one that, well, took the world by storm during the Corona pandemic that is still going on, because suddenly everybody had to start working from home. And guess what? It scales up to 20 gigabits per second, and you can have 10,000 users per hub. So that's also quite impressive. It also gives you security if you want, if you integrate with Microsoft firewall, but also with third-party offerings. So that's kind of interesting, especially in these pandemics where everybody started working from home without actually planning for it. So you have the OpenVPN possibility or IPv2 clients. OpenVPN has some benefits. It means you can integrate with Azure AD for authentication, Radius, and Azure AD opens up that ability to leverage conditional access, for example. So that's kind of nice. Again, IP or FQDN based, and you can even do custom DNS now, which is nice because that was one they were missing at the start of the pandemic, and they added it. So you can now also define your DNS for your user VPNs in your Azure Virtual One, and that brings it up to par in functionality with what already existed. And as said, any to any. This really means that somebody with a site-to-site VPN can connect to VNets and can connect to the data center or a branch office if it needs to be. So that's cool. That's all taken care of you. Again, as said, everything we mentioned here integrates with Azure Monitor. The express route options, also important to some people, of course. 20 gigabits aggregate bandwidth as well. And the scale units here, the other ones started at 500 megabits. These ones start a bit bigger, but that's the nature of express route. And you can have up to 8 circuits now. It used to be 4, now it's 8. Private connectivity, what does that mean? Well, it used to be that you had to have the premium circuits with global reach enabled, right? Because that's what you needed for that global transit connectivity. But for some people, that's a bit expensive and they don't really need it. So now you can do it with a standard circuit that gives you connectivity within geopolitical regions, like say within Europe. But that disables the branch-to-branch transitivity. And then my text got mixed up here. I see you can also lose a local circuit, which is even more limiting, but of course cheaper. And depending on your needs, this might be enough. Important to know, we said any-to-any, so express route and VPN interconnects, which means that all those VPNs can talk to endpoints that are connected over express route. And important to some folks, encrypting your traffic over express route is also supported. A little side mark with express route, if you have global reach and it makes more sense to do connectivity between the express route circuits you have set up, and instead of going over the virtual one, that will still happen. There's no risk of losing your benefits and what you pay for by implementing an Azure Virtual One, so there's no risk of that. So that's a very quick overview of what it is and what the capabilities are. So why would you use it, right? That's the most important question, probably. Well, the operational efficiencies are there. The simplifies architecture, so replacing all those dozens to maybe hundreds or even thousands of VNets that you have to take care of with peering or with NVAs to have transit connectivity. That's all gone. You can have a network design that is a bit simpler and a bit more centralized to manage, which is also important. And then you can reduce your operational costs, not only by using it as an SD-WAN and replacing MPLSs or so, but also by the automation you get with Azure and the integration with third-party players, right? The appliances you will use for your home offices or your branch offices or your shops. They can all be configured very easily to basically power up, connect to Azure, get the configuration, and start working. So that there's a potential there for a lot of reduction of complexity and cost. The scale is very important to some people. You go to 20 gigabits for VPN. That means 20 gigabits for site-to-site, 20 gigabits for point-to-site. That's 40 in total. That's 10,000 users per hub and 1,000 site-to-site VPNs per hub. So that's very impressive. So if you look at it in the complete picture, it's almost 60 gigabits per second of throughput for an Azure Virtual One at the moment. And it has, of course, enormous benefits for high availability and redundancy, because you don't have to worry anymore about zone redundancy when you design your network. The virtual hub has that by default. It's all set up. There's no wondering what SKU you need to make it redundant or to get the capacity. It's all very easy. You just size it to your needs and you can scale up and down as you need. The other benefit, and we've already discussed this, is the any-to-any networking. Really, you can have everybody talk to everybody, and that is thanks to that hub, which is the central routing hub for that entire region, and the hubs are interconnected, right? So all the connectivity you do there, BGP wise, is exchanged between your branch offices or data centers, or is updated for you automatically when you connect the VNet to your virtual one. So all that configuration there is gone. So that's kind of nice to know. And as said, hub to hub, global construct all over the planet. Everybody can talk to everybody. And we already mentioned, if you have global reach, you don't have to go via that virtual hub. You don't lose what you pay for there. So if you look at it from an entire picture, let's see, we have an Azure Virtual One here with 3 regions across the globe. What does this mean? Well, the full mesh between the hubs means all the hubs are interconnected. So that means that a branch to Azure can talk, a branch here in region 1 can talk to VNet in region 3. And an end user with a point-to-site VPN can also talk to a VNet in a different region, no problem. Express route to VNet also works, and it only gets better. The branch offices over Express route can talk to the branch offices or over a VPN in a different region. That works. So all that connectivity is there. If you want VNets to talk to each other within a region or across regions, it's there. All done for you by that hub or those hubs within that Azure Virtual One. A lot easier than it used to be if you have to build this all yourself. So that's what Microsoft means with the any-to-any connectivity. And the simplified network design, the ease of use, and the operational savings are the benefits you get from this. And that's what Microsoft, if you look at the complete picture, calls their global transit architecture, because everything can talk to everything. Now, the State of the Union, basically that's the slide that's in there when you read the slide deck. It's a summary of what we just discussed, and it's a lot of material to go through, and there's a lot of detail in there. If you go to the Microsoft site, you'll find a lot more information. The one thing I haven't mentioned here probably is that it's also available in the government cloud in the US and in China, but you have to realize, of course, that you are then limited by the Great Firewall of China, and speeds are not that optimal as they should be. The custom route tables is something that we'll dive in a bit deeper later, because it's a very important construct they deployed this summer, and it finally became available early September. And then another thing that is new, the hub used to be a Microsoft only game, but now you can actually replace the hub by an NVA from one of your preferred partners. And then it actually does the work of the hub, but with added capabilities that the partner implements. Now, I've played around with some of these appliances, and I'll show you some screenshots. I got my hands on a Barracuda, and basically you have to set up a service endpoint in Azure. But once you've done that, the only thing you need to do on those appliances is fill out the information about your tenant and your client you set up with a password, and ship it to the location where it needs to be attached. If you color code the cables and you give them a little manual for plug this one here and plug the red one in the other port, and then just boot it up, it will connect to the internet, it will connect to Azure, and it will configure itself. So all the complexity of that is taken care of by automation, and it's integrated with Azure Virtual One. At first I was a bit worried, will this work? How well will this work? But once I've set it up and I booted it up and I waited a couple of minutes, my link is here with my 2 tunnels from both instances. It just comes up automatically. It's magical. Imagine if you have 1,000 points of sales to send an appliance to for a site-to-site VPN. Well, it's quite easy to do. And that was Barracuda, because that's the one I got my hands on. But of course, there's a truckload of other partners. And then there's also the MSPs that actually provide the services for you, because if you don't want to do it yourself, there's people that will do it for you, of course. And as said, the fact that you can deploy an NVA in the hub, I think it's Barracuda, Cisco, and maybe already a third one, but they're taking it easy there just to make sure that everybody has a good troubles-free experience. So might sound nice, and we've been talking about connectivity all over the globe. And you might think like, well, I'm not a Fortune 500 multinational conglomerate, so what is in it for me? Well, basically everything those guys get. With exception for you, maybe that scale is not that important, but all the other things of making things easier, more redundant by default, that you don't have to spend as much time configuring things, that you can have cost optimizations, that you can get rid of your MPLS networks to reduce your costs. It's all there. The other thing is, even if you are a smaller business, the mantra is you have to design for failure, which means if you want high availability, well, you'll need to deploy across 2 regions. And the complexity of interconnecting 2 regions, well, it's taken care of for you by that Azure Virtual One construct. So why not? And remember that MPLS we used to have, where you had a central office with the branches connected over MPLS, and then we went from there to the cloud. Well, the world changed a bit, and we got SD-WANs, and then we had internet breakouts to the cloud services, whether they were SaaS or anything else. But we also made the MPLS a bit more redundant. We added broadband backup links, etc., etc. Well, if you that already shows that there is a potential here, because hey, every location has internet. Why not get rid of that MPLS and do everything over Azure Virtual One? And that's one of the reasons that people will adopt this and are already adopting this. Take, for example, a customer that has no Azure presence at all, but has a sizable footprint somewhere within the country or across countries in Europe, for example. Well, if he creates an Azure Virtual One, he can link his factory, his data center, his shops, his end users, and maybe his end users via point-to-site or via site-to-site VPNs. That's also possible, all to Azure Virtual One, and create an SD-WAN, so to speak, but based on that backbone that Microsoft has. So it's redundant, it's fast, it's cheaper, and it's easier to set up. And you already have the connectivity because everything has an internet connection nowadays. If you are a company that wants to migrate to the cloud, well, good. You've already had a very important part in place. That's Azure Virtual One. You can add your VNets in your regions or in the same region, and you can start building out your hybrid environments. And if you move to a more and more Azure-focused environment, well, Microsoft has you covered, right? Because if you look at what they're doing, and Cosmos talked about this this morning, and some other people as well, you have Azure Stack Edge, Azure Stack HCI to replace what you have on premises while you move more and more to that cloud. But again, your investment is solid because you have your Azure Virtual One. And also don't worry if you already have an Azure presence, you can deploy an Azure Virtual One next to your existing environment and slowly migrate over. You're not forced to move everything on one day. You can take your time and do it well. Now, we've already talked about that hub and that the routing happens there, so it's very important. The hub, of course, to do this has a router. The capacity of that router is 50 gigabits, and all the connectivity happens there: site-to-site, point-to-site, express route. It's also the construct with the mesh between the hubs that will deliver your global connectivity and your transitive peering for your VNets. And there's 3 types of route table. The default route table, that's where everything goes, where if you don't have a preference. The non-route table just means that if you associate a connection with that, that it's not going nowhere. That's also a need you sometimes have, that you don't want things to be available or go somewhere. And then the custom route tables, they are optional, but they allow you to manipulate the data flow. And that's something that popped up this summer. It took a bit longer than planned, but in September it finally lit up, and you can do a couple of things. You can create your own route table now, and you can give it a label. You can associate connections with route tables, and you can propagate connections to route tables. And we'll take a look at what that actually means, because that's a very important construct. The thing that you need to know about The labels they are just a logical construct that make sure that you can have propagation and association easily to multiple locations. Let's see, the default route table that is in every hub. Let's say you have a global network with 15 regions to make it a bit large. You say propagate to default, but default is not the name of the routing table, it's actually the label. So if you say I'm propagating to default, it's actually propagating to the routing table in each of those hub deployments in every region. So you don't have to do that 15 times, you just use the labels. And you can even associate your own label name with an existing default routing table, but not in every region. So you can limit propagation to only the regions that you want. So you can play with those labels to create data flows. It's kind of cool. And what is an association? Well, basically, if you have a connection, let's say the VNet2 connection, if you associate it with a route table, that means that this connection knows where to go. Everything that's in the default route table, because you are associated with it, you can read this and you know where to go for these network addresses. That's what association means. Now you can associate only with one route table, but a route table can have associations from multiple connections. Basically, that's what I said here. With the exception, of course, the default route table, you can add static entries and those will override the dynamic ones. That's important to know. Now, then there is the propagation. The propagation is actually what a connection does to let a route table know what it has to offer in terms of connectivity. So if you say that VNet2 propagates to the default route table, that means that the routes to get there are in that table. So the VPN gateway propagates to the default route table, the VNet1 as well. So everybody knows how to get to everybody. That's the default situation. So association is being able to read it, and actually propagation is I'm putting my routing information in there so the people that are associated, or the connections that are associated with the route table, know where to go. That's the text for you. The labels, we've already mentioned this, how this works. Define your own labels and get things get things propagated easily, because you don't have to do it 20 times if everything is called default, but also to manipulate how the data actually flows. Now let's do an example of this. This is the default situation. So the default table is being used, and we have two regions with VNets, branch offices, express routes, everything you want, and they are of course hub to hub connected via the mesh. So what does that mean? Everybody can talk to everybody. That's the situation. So we'll have a default route table, and we'll say, hey, all the connections from the branches will be associated with the default route table. And we'll associate that across two regions. Still, nothing is happening. What we also do is we propagate those connections to the default route table. And hey, look, now we already have some connectivity, because now the branches can talk to each other within a region, and they can talk to each other across a region. Now let's go a step further. We also associate the VNets with that table, and then we propagate the connections of those VNets with that table, and so that information about their networks gets propagated in there. And now we have a situation where, well, we can talk from a branch to a VNet across hubs, across regions already. That's the construct. And of course, the VNets can talk to each other. That's your default situation without doing anything, any-to-any connectivity. Now I have more examples, but we're going to skip to just one more. Let's say you have the same situation, but you have VNets that are in the blue sector and VNets that are in the red sector, and the red ones can talk to each other but not to the blue ones, and the blue ones can talk to each other but not to the red ones. So you have segregation of connectivity here, but they have to be able to talk to the branch offices. So how do we do that? Well, let's set it up. We create a default route table, and again, we're going to propagate our branches. We're going to associate our branches with the default route table. We're going to propagate them as well. And again, we already have the connectivity between the branches. That's good. Now we're going to do something funky. We're going to say, hey, we are going to propagate the VNet information of the blue and the red VNets across the regions also to the default route table. And then you could say, hey, the branches already know how to get to the VNets. That's cool, but the VNets don't know how to get to the branches yet. And because we want to have the separation of data flows, we're going to create a custom red VNet routing table, and we're going to associate those red VNets with that table. And then we're going to propagate the information of the gateways into that red VNet table as well, which means that all of a sudden, this connectivity now works. Now we still need to make sure that the VNets can talk to each other, the red VNets, so we propagate them as well. And because they are associated with this routing table, they can find each other now. So red can talk to red across regions or within a region. And now for the blue scenario, we actually repeat that effort. We create a blue routing table VNet, and we associate the blue VNets with it. We propagate the gateways connectivity, the IP and the routing information into that table. And again, the flow between the blue VNets and the on-premises connectivity they start flowing. And we just need to add the propagation from the blue VNets, so the blue VNets can also talk to each other. And this is just a simple example of how those custom VNets can manipulate the data flow. So you can start thinking about constructs to make this happen. And again, propagating to such custom routing tables, remember you can create custom labels for them, so you can group them so the propagation and the association becomes a bit easier if you have a lot of them. Then, of course, you can add a firewall to the mix, and then your firewall will perhaps say, hey, look, anything that I don't know or that is not a VNet has to go via the firewall. So whether it's go to the branches or the internet, it has to pass through the firewall. So you can start playing with that. There's a little trick, of course. If you have multiple firewalls in multiple regions, you have this dilemma of asymmetrical routing, and that is not 100% solved yet. So that's something you'll run into with a lot of routing and firewall deployments, that you have to be a bit careful there what you want to achieve. But we've come to the next point in the presentation, that is securing that virtual hub, because it's all very nice that you can connect everything to everybody all over the world, but one day your CISO will walk in and they might say, wait a minute, the guys from Fortinet were talking about this. We need to protect all those different islands, and all those islands want to talk to each other. Well, the talking to each other we've just made very, very easy, but the security of things, of course, well, it's not an afterthought. It's something you have to have. So early this summer, I think, the firewall became available with Azure Virtual One, and that was thanks to the fact that Azure Firewall Manager came out with the policies, and now you have that ability to protect it as well. So if you look at that, this is everything that is possible. You can have a secured virtual hub. Basically, what is that? It's a virtual hub that gets firewall policies and security policies and routing policies via the firewall manager, and that's it. Of course, if you do this, all of a sudden you have to take into consideration that, well, the firewall is there, and that scenarios that worked previously might not work anymore, because, hey, I had a virtual machine that had a public IP address, but now it has to go to the firewall, and the firewall doesn't allow my service. Well, you have to configure your firewall. That's obvious. Now, you can use that virtual hub as a construct in Azure itself, just to manage all the connectivity between the VNets. That's, let's say, the most simple way of using it. But of course, you can integrate it with all your on-premises connectivity. If you look at the GUI or the Azure portal, you will see that if you click through to Firewall Manager in the Azure Virtual One, you can see your secured virtual hubs and your hub virtual networks. And the hub virtual network basically is just a normal virtual network that is secured by a firewall policy, but a secured virtual hub is when it is a hub in a virtual one. So Firewall Manager is not exclusive to Virtual One. It's just a new way of doing firewalling in Azure, and it's the only one that works with Azure Virtual One. So if you look at it, the firewall itself is policy driven and is hierarchical. So that means you can have a global firewall policy that you push out to multiple deployments, multiple regions or multiple VNets, multiple hubs, but you can allow local people to add to the rules. So this is nice in a DevOps environment where the local people in the dev environment can add their own rules to make things work. And when things have to move up to staging or production, they will have to be added to the global admin. It's how you organize it. But it's nice to know that you can have this. It's hierarchical. That means the local admin can add and change things, but they can of course not disable or overrule what the global admin pushes in. So you can't just turn it all off and say I'm a happy developer now because the firewall is no longer in my road or in my way. Then the other thing that you need to know about the Azure Firewall, that it integrates again with a lot of third parties. So as you have a hub where you can deploy a VPN or sorry, a network virtual appliance from a third party, that could be one that integrates with all the VPN devices you deploy in your branches. And it will be secured by the third-party firewall. You can also integrate with third-party services. If you want your internet traffic from your VNets to be protected by a service provider, you can do that. If you want your branch office's internet connectivity protected by such a provider, it's possible. The only thing you have to watch out for that you can't combine everything with everything. So if you start using some of these providers, some scenarios are not compatible with others, and that's very vendor and scenario specific. So if you want to learn more about that, you will have to do some reading. There's one global truth with everything, that if you have Office 365, it's always still the best to have a direct internet breakout for Office 365. So don't push your Office 365 traffic over the hub or over a service provider if you don't need to, right? Just go there directly and use it as you are accustomed to. So these are the integrations with the third parties. There are a ton of them, and it's more of a scenario where Microsoft can't do everything for everybody at any given time. So they just partner up with people that already have partnerships with them to do networking in Azure, and they offer you a wide variety of possibilities that you can pick and match to your needs. And then finally, there is the monitoring that we need to talk about, because it's all very nice to have all this stuff, but you need to know that it's working properly, and you might want to keep an eye on how much bandwidth you're consuming or what is going wrong. So this is still in preview last time I checked, and what it does is actually it shows you from the entire setup of your Azure Virtual One, the insights. If you click on it, you'll get this nice view, and it will just draw out your Azure Virtual One setup for you. And the cool thing is that all these things, you can click on them and dive deeper into them, and they have metrics associated, which means that you can click on them, dive in, and you'll get this scope. The scope is the ID of the resource you want to look at, and then you can select what kind of metrics you want to look at. So the bandwidth, the egress, the ingress, packet drops, etc., etc. These are the metrics that are happening and that you can discover. But then there's also the diagnostic logs, and the diagnostics logs, well, of course, you do the same thing. You start filtering on the resource ID, and then you can get a lot of information. Like from a VPN, you can have the IPv2 or IPv1 logs, what is being dropped, what is happening. So you can troubleshoot your point-to-site VPNs, your site-to-site VPNs, and that sort of stuff. And that's, in a nutshell, very fast, the overview of Azure Virtual One. 45 minutes for such a massive subject is not too long, but I'm very grateful that I got the opportunity to share the introduction and why it might be interesting to you. And that's thanks to our sponsors, and I'm here for a little bit of questions and answers. And of course, thank you for attending, and stay home, stay safe, wash your hands, wear a mask, because I all want to see you again somewhere, somehow in the future. So do we have any questions? Because I have not been paying attention to the...
No, Didier, at the moment there are no questions there.
Oh,
so
that is wonderful. I mean, that was crystal clear then. Okay.
Yeah, so everybody understands you.
And I wasn't even speaking German. That's fascinating.
Yeah, perhaps you should better speak Flams.
Yeah, maybe.
Yeah. Okay.
So thanks a lot. If there are no questions, then everybody can take a break and get ready for the next session.
Yeah, I think everybody can grab a coffee. It's still late on Friday, so yeah.
Okay, cool. And I got it right in time.
Yeah, it's great.
I'm happy with myself now.
Yeah.
Okay. Thanks.
Thanks. Okay.
Businesses are rapidly adopting cloud computing, taking advantage of its flexibility and speed. Whether consuming SaaS applications, building cloud-native applications, or migrating existing applications to the cloud, finding a security solution that addresses a diverse set of needs is critical. Fortinet Cloud Security Solutions deliver. Get the confidence you need to deploy any application on any cloud supporting any initiative. Fortinet supports all major cloud providers, ensuring that critical assets are secure and that security is manageable. The Fortinet 3-pillar cloud security strategy provides the same level of security across multiple clouds by natively integrating security into the cloud platform, defining security policies for cloud services, and leveraging cloud services for security, ultimately enabling automation of security services. Fortinet provides the industry's broadest set of cloud security products, enabling you to use the same security in the cloud as you have on premises. By using purpose-built security tools in the cloud, you'll save time by leveraging existing skill sets. By managing security across multiple clouds through a single pane of glass, and by automating the security lifecycle management, you can better leverage existing skill sets and accelerate the confidence to deploy applications anywhere. From consuming cloud applications to building applications in the cloud and migrating IT to the cloud, Fortinet Cloud Security Solutions cover the broadest set of use cases, delivering the flexibility and confidence to use the cloud in a way that best serves your business.
So, und somit kommen wir jetzt zum letzten Vortrag des heutigen Tages. In dem Fall jenen Vortrag, den ich selbst halten werde, zusammen mit Armin Oberneder von der Thomas Krenn. Das heißt, unser Vortrag geht im Thema um Minimal Kubernetes and Azure Stack HCI. That means we try to show you what's the minimal installation size you can achieve when doing an Azure Stack HCI cluster and run Kubernetes services on this cluster. So, yeah, my name is Helmut Otto. I'm Managing Director of SecureGuard GmbH, and hopefully was a successful host for the whole track from the beginning till now. So now it's really the last time you hear me till the closing session, and I will be supported by Mr. Armin Oberneder from Thomas Krenn, who is a solution engineer there. Perhaps Armin can say some words to himself by himself.
Yeah, sure. Yeah, my name Armin Oberneder. I'm a senior solution engineer from Thomas Krenn in Germany. And my part today is to show you a few great solutions which are available and validated for the Azure Stack HCI OS.
Okay, and so we come to the agenda. It's relatively easy. The first part is I want a short explanation, do a short explanation what is Kubernetes. Kubernetes is a buzzword which is often heard at the moment, but I'm not totally sure that everybody knows what it's for. Some guys for sure do. Then we have Kubernetes in Azure, short AKS, and then we can deploy Kubernetes on Azure Stack HCI. At the end of the day, there we can really achieve interesting installations on interesting hardware in a minimal environment, but also in bigger environments. And that's where Armin will drop in and show us what the environments are and how we can do it. Yeah, so let's start. What is Kubernetes? Kubernetes, also known as K8S, the 8 stands just for the 8 letters between K and S, is an open source system for automating, deploying, scaling, and management of containerized application. That's the original text from the Kubernetes size. It groups containers that make up an application into logical units for easy management and discovery. Kubernetes can scale without increasing upstream. Kubernetes grows with you to deliver your applications consistently and easily, no matter how complex the need is. So in general, Kubernetes is an open source environment which allows you to run containerized applications in all worlds. Kubernetes K8S runs anywhere. It's open source and gives you the freedom and advantage to run it on-premise, hybrid, or in a public cloud infrastructure. So you can move and migrate workloads in every way you like and in every way you are. Microsoft also found this interesting and therefore built some time ago the Azure Kubernetes services. So supplying you services for Kubernetes and containers inside virtual machines, supporting Docker containers in virtual machines running inside Azure to ease up your DevOps environment, to ease up your DevOps infrastructure, to make it easier to modernize Windows apps, and for sure to get some Azure consumption there. But in a way, not everybody wants to have everything in the cloud. So when we see here, that's the standard Kubernetes architecture. We have the dev spaces, the source control. We then get out of this pipeline a container image, which is going to a container registry, and then at the end of the day on a production cluster in Azure, and then there is monitored via Azure Monitor. That's the default installation from the beginning when AKS was built. And that's how it still works. But they're coming in more and more requests, not only run it in the cloud, but also in hybrid and on-premise environments. And so where can Azure Kubernetes services run now? So in the cloud, but also on-premises with a Kubernetes service runtime on a single Windows server, which is not really, let's say, redundant. You can run it on-premise in an Azure Stack Hub environment using the AKS engine on Azure Stack Hub, which is especially for bigger deployments, where you also have data sovereignty problems or legal problems because you don't want to put your data on the cloud. But in more and more environments, it came that also smaller people want to have installations hybrid and on-premises. And that's where it comes in that you can run AKS on Azure Stack HCI on-premise and still manage it with Azure Portal and Azure Services. We see that we have two different forms of cloud hosted. We have the cloud-hosted services where the Azure Kubernetes services or the platform services are not really visible to you, and the rest of the Kubernetes cluster, which is normally based on made out of a control plane and worker nodes, is in a partly customer managed environment, but in your tenant in Azure. If you run it on Azure Stack HCI, all of these machines are running on one or more Azure Stack HCI clusters, but all of it is customer hosted. So there are no additional costs for hosting virtual machines, for running it in the cloud. You can run it on-prem in whatever size you like. The on-prem has special requirements which should be, let's say, considered upfront so that the Kubernetes installation, the installation on Azure Stack HCI runs easily. One of the most important requirement on premises, you have to have correct time synchronization services so that all of the hosts of the management plane, of the control plane, runs in the same time zone and runs in the same time frame, not that they are off more than 1 second. Then second thing also is you have to have the correct account permissions. So you require list, read, modify, and delete permissions on all objects in the Active Directory unit there. One of the big recommendations, especially to get the account permissions correct, is that you run it on a separate organization unit for the servers and services. And then please, really advise, exempt AKS HCI from your group policies so that you don't have group policies, which gives you directly problems afterwards when they are applied. So everything is working fine till you change a group policy and then everything goes up. Then from a hardware requirement, you have a minimum of 2 servers. In the current installation, there's a maximum of 4 servers in the cluster. You need at least 4 cores per node. And you need at least 64 gigabytes per node. That's coming out that you run VMs and you need at least 30 and 16 gigabytes for running the VMs in the worker and in the control plane. Then for the storage network in the Azure Stack cluster, like normal for Azure Stack HCI, you need at least 10 gigabit Ethernet interfaces, but you're not limited to them. You can go to up to 400 giga, whatever you want to achieve and whatever you want to buy. Then you need 1 terabyte of cluster shared volume storage. You need external internet connectivity for sure, because you're running Azure Kubernetes services on premise. You're in a hybrid environment that only can work if you have a connectivity to the cloud, to the outside, which is going via the internet. And please, also one more advice, disable IPv6 on all network adapters. The current installation only runs with v4. This V4 installation runs on 4 boards on each server, which is 45,000, 45,001, 55,000, 65,000. That's for the remote procedure calls between the servers, and that's also the network ports you need to allow on each of the servers. If you are doing, let's say, a more defined security installations, you have, if your local firewall should allow these connectivities between the different servers, and also out to the internet, you should allow different URLs for downloading the necessary data, especially for downloading the Helm binaries, the Kubernetes binaries, the Azure CLI. You need the blob for the containers and binaries. You need some for metadata out of the Microsoft Azure environment. VHD images are coming down from Azure environment, and for sure you need to download then your container images, which were published to the container registry. So when doing your prerequisites, be sure that your firewall to the external has these different exemptions so that you are not blocked by simple network problems when you install this cluster. Last but not least, to run the whole thing, you need a Windows Admin Center. This Windows Admin Center has to run on a separate Windows 10 or Windows Server. Running Windows Admin Center in this environment on Azure Stack HCI is not supported at the moment. You need 60 GB free space for this Admin Center. Please register it with Azure, because what we install now is Azure Kubernetes services in a hybrid environment. The Admin Center has to be in the same domain as the Azure Stack HCI cluster to avoid special security problems. And also the Admin Center needs to be at least built 2009 or later. Otherwise, AKS won't be supported on HCI. Then we came still to the, at the moment, maximum supported hardware specification. So as already mentioned, it's maximum 4 physical servers per cluster, 4 total Kubernetes clusters, and not more than 200 total VMs. That's the data which is valid now for the preview. It will change over time as normal with this form of services. And now we came to the point, how can you achieve access to the software? How do you get it installed? How you install it? And then at the end of this track or of this session, we go down to the path how you on which hardware you can install it. So at the moment, Azure Kubernetes services on Azure Stack HCI is in a preview. So you need to register with an account. In that case, I'm signed in with my company name, submit this registration, and then I get a download of a zip file containing this data. This was done with the public preview of the October last year. Essential part in this preview for our session, or if you want to install it with a UI on Windows Admin Center, is the new BKG, which is the extension for Windows Admin Center, which gives you the possibility to install Azure Kubernetes services. You have to install this extension into your Admin Center. So the way how you do is you extract that file, for instance, on your C drive, add a manual feed to the C drive so that you can install it on your Admin Center. And then it should come to available extensions so that the Azure Kubernetes services is, when it's installed, is an available extension in your Windows Admin Center. Now the prerequisites are done. We have an Admin Center. We should have an Azure Stack HCI cluster. How can we now roll out AKS? When we connect to the cluster, we have the extension installed. We see that there is new extension, which is called Azure Kubernetes Services. As normal, I have a nice logo. I have a link that I can learn more, which is an offsite link, brings me to Microsoft environment. But what we now do is we want to install the Azure Stack Kubernetes services. That's if you remember back to the architecture. That's the part which is in Azure on the total left-hand side. It's not visible, or on Azure Stack HCI, it's the platform service here. So when we go to setup, it's rather easy. We have some prerequisites. We register Windows Admin Center. We have to have 40 GB of free disk space for this. So it adds up to the 60. We have to have 30 GB of available memory for running the VMs. So that's part of the 30 and the 16s then. We have the 1 TB of free space. We have to have one virtual switch with internet connectivity, and we have to run it on undecked network ports with a DHCP server and the open firewall ports 45,000, 45,001, 55,000, and 65,000. So nice, easy, straightforward. We go to the system checks. We need to enter an administrator password, then the system checks will run. Look if this whole thing is connected. If everything is fine, if all servers in the cluster are fine, in that case, all servers in the cluster are fine, there will be 2 roles installed before we can go on. And look, it's next done. So like we come to the host configuration. Vital part in the host configuration is just the way we have to give this management cluster a name. We have to define what's the external virtual switch which has access to the internet. And yeah, we can do some custom allocations, but normally in the first part is just make it as easy as possible. And we need a folder to store for the VM images. So we have to select one cluster shared volume where all of the VM images are available. This cluster shared volume should have at least 1 TB available. Then I need to register with Azure. And with this Azure registration, I have to go to an Azure Stack HCI subscription. Yeah, my Windows Admin Center is already registered, so I just choose one. I review the whole thing. Systems checks are running. And then that's why I didn't do a live demo. There will run a setup in a, let's say, normal performing environment. You can see it here, it's running 33 minutes and 30 seconds. In the minimal environment we have in mind, it can go easily over 2 hours. So that's why we refrained from a live demo in a 50 minutes session track and just made it in the, let's say, more or less formal part. So when we finish here, our Azure Kubernetes services on Azure Stack is done. If I want to connect it, I can download my kubeconfig file with all the certificates, my YAML file, which gives me then in the future the possibility to connect to these Kubernetes services with or the normal Kubernetes tools. It's just an easy download link here. And I get the cluster file in my download session. I can look into it. It's a normal JSON file having all the different forms in it. When I look at my cluster, I see that there's 2 machines there. I have now the control plane there, and I have the load balancer there. So my whole Kubernetes services is made out of 2 virtual machines. When you look at it, one of the machines, the control plane, is consuming already a whole lot of memory. The load balancer is less memory hungry, hopefully, as long as there's no error. Yeah. And when I go back to Windows Admin Center and I want to add a new element I see, like in Carsten's session before, you can make a cluster, but what we can now do also here is we can create a new Kubernetes cluster, as said, still in preview. When we go to the Kubernetes cluster, we see what we need to define this cluster, and there's an interesting duality in that case, because if we look at the Microsoft Azure portal for the Kubernetes clusters, we see that with one or two exceptions, it's totally the same. So it's basic node pools, the networking, the integration. In the Azure portal, I have chosen as additional point the authentication and some tags to find it in my resource management that is data which isn't really necessary on Azure Stack HCI, because I know the authentication is done against my local domain and I have no resource management. I'm on my Azure Stack HCI cluster. I don't have resource groups on this cluster. And again, it's a really, really simple form. I need for Azure Arc integration, again, my Azure HCI subscription. I need a cluster name. Now we're putting on the worknode cluster. I have some cluster details, like what's the service host. I need a username on the service host. I need the security there. I can use different Kubernetes versions. Then I can add the node pools. In these node pools, I have to say how many control planes and of which size and type the control plane and the load balancer will be. Load balancer will always be 1. And interesting thing here is now we have this duality. So we have these VM types which came down from Azure. Now we have the same types also on-premise. So we have a much tighter integration done via Azure Arc between on-premise, Azure Stack HCI, and Azure, Big Azure in the cloud. Yeah, at the node pool, again, what node size and really essential, what node type. I can run Linux, as mentioned before. It will have some, if I only have Linux containers, I have some essential advantages when it comes to licensing. But you also can mix the pools. You can make a Linux pool with 2 nodes and a Windows pool with 2 nodes, both of standard A4 version 2 machines. Then the networking is just, you have a load balancer. That's it. No networking policy and no HTTP application routing at the moment. So what we see here is we are still in preview. A lot of features have still to come over the time and still go on. Then we have our cluster storage volume. We will have a cluster storage interface of a fixed integration. Everything can be reviewed and then it will be created. And we've successfully, easy in a fast lane, created a Kubernetes cluster, which we can manage now with Azure Arc. We have security credentials there for the cluster with the key, and we have the kube config to use it, normal Kubernetes tools to run and work with this cluster. And we see here now, we have the new machines there for the different node pools and the new load balancer. So we have now 2 pools with 2 worker nodes each, one for Linux and one for Windows, running on A4 machines, version 2 with 8 gig of memory. And here we are again, this 2 times 8 gigs is the 16 gigs. So at the end of the day, I have 30 gigs for the AKS, for the service itself, and 16 gigs at least for the worker nodes, which sums up to 46 gigs. I need some memory for the OS at the end of the day, so that's my minimum requirement of 64 gigs. And I've built this architecture. I'm running on Azure Stack HCI with Linux and Windows container host in a virtual machine. I have a Microsoft provided operating system code for all of the Kubernetes compliant OS components. They was downloaded on the fly from Azure. It's maintained by Microsoft in Azure, so I don't really adapt go to this machine. And at the end, I have a high-level control plane in Azure Arc to project my K8s clusters into Azure. It's a nice, fast, straightforward installation with really no problems. And now I'm ready to just run my DevOps, my CI/CD form, and have supplied containers on my local on-premises installations. For instance, for Stefan's IoT tests, that he doesn't need to go for data management, especially, or like pattern matching, and so up to the cloud, and can do it in here. So if Stefan wants to do this signing again, I just send it out live. And we can see Stefan laughing and cheering about these features he has here. Yeah. And when can I use it? So yeah, first of all, for sure, I can use it to modernize existing Windows apps, to bring it to a modern container world, still run all the DevOps cycles and so on premises, which makes it easier, better for my devs, because they don't have to care that there's some lost over container which is consuming data over the weekend or over Christmas time, not shut down and just doing strange things like consuming IOPS like hell. Or I can design new now cloud native apps. I go to new, or I go to Arc-enabled data services and Azure IoT, what we have before. So I do a whole lot of data processing down on-premise because of low latencies, because of small installations. So I have an on-premise plant which doesn't need a whole lot of processing power, but I have it down there somewhere in the, let's say, Indian jungle, or and then one of our customers is there on an Libyan oil field where you have no low latency data. Everything you do there is over satellite with at least 500 milliseconds of latency, and you want to do the data processing already out there and also the IoT. Then that's a perfect solution, because by the way, you also can run your IoT Edge Gateway on Azure Stack HCI, and then everything is in one installation. And yeah, build the whole thing. Then I have admin center as management part. I have my validated hardware. I run Azure Stack HCI. I run AKS on Azure Stack HCI. I have Azure Arc for data services up front, and then I have my applications come to the Azure portal, and I'm fully integrated into this whole solution. And now we will have a look and where you can run it. And the first thing I will still speak about is one of my, let's say, projects from last year. So because some of the Microsoft guys told us at Ignite in 2019, showing Lenovo servers on always on the stage, I told the guy, Mr. Cosmos Darwin, that next time I will see him, I will have something with it what he can run when he's on the stage, and which is a full working Azure Stack HCI cluster. So I built an Azure Stack HCI cluster in the form of a hand luggage size in a wooden box, including the access point, the 10 gigabit network, a battery pack for mobile usage. So it's running 3 hours out of battery only. By the way, in the meantime, it's fully Azure Stack HCI certified and validated. So it passed all of the Microsoft certifications and is for sure the smallest installation where you can do an Azure Stack HCI cluster, and it's also running Azure Stack Azure Kubernetes services on Azure Stack HCI. So we're down to 2 times 4-core CPUs, max 258 RAM, and from the storage size we have 4 times M.2 NVMe slot. So at the end of the day, it's not only a small solution, it's also a full-fledged, full SSD, full flash solution. And the other part is, since it's in a wooden box, but it's easy to deploy such a solution in a more, let's say, industrial form. You can put it into a ruggedized rack because it's no, you can put it on the blade, put it in a normal 19-inch ruggedized rack, like you can know it from audio equipment, for instance, and then you have it for industrial environments in full ruggedized form, and you can use it anywhere where you can build it. And now I will hand over to Mr. Oberneder, who will show us the solutions from our partner Thomas Gren and also the rest of the hardware.
Thanks, Helmut. Yeah, I will show a few of our solutions. They are secure guard solutions, also then Thomas Gren solutions. In the first step, who is Thomas Gren? Thomas Gren is one of the leading local OEMs here in the German, Austria, and Switzerland market. We are an OEM manufacturer where we can build very individual solutions for our customers. Since a very long time, we have a great partnership and cooperation with Microsoft to do such or to build such hardware in combination with the Microsoft software. And we have also a great partnership with SecureGuard to provide the best solutions to our customers, which matches exactly for the individual requirements. Here we have our very small sized solutions. They are called microcluster micro solutions. They are in a very small form factor, but of course they fulfill all the requirements, and each system is fully validated and certified for deploying Azure Stack HCI on them. With these solutions, you can build an enterprise class cluster environment because of the validation and certification. And micro solutions are in a few different configurations available. You can, for example, choose between AMD or Intel CPUs, and the smallest configuration is an AMD-based configuration. With 4 cores, but combined with the NVMe-only configuration, you will get a very powerful clustered solution. If you need a lot of disk space, for example, these solutions can also be configured as a hybrid storage system, so the performance comes out from the flash drives, and the big capacity arises from the high capacity hard disks. These solutions are all built on 10 gigabit network with have RDMA functionality. Let's talk about licensing for such small solutions. The licensing is also flexible. All these solutions are available with the brand new Azure Stack HCI operating system, which is subscription based. Within this subscription, there's no upfront cost for the host OS. The billing is through the Azure portal every month. The pricing is about $10 per core per month. And if you choose, for example, a 4-core system, you have only to pay a few bucks per month for the operating system. So it's very interesting because it's about $40 per month per system. In this case, you have 2 systems, but it's under $100 per month for enterprise class cluster solution.
And interestingly, if you put your worker nodes on Linux, you have no additional costs. So the whole yearly costs for the full cluster will stay below $1,000. In detail, it's let's say $80 per month, which sums up in a year for $960 with full form of software subscription and so on. So in really small environments, the new licensing has even extreme advantages there.
Right. And alternatively, you can choose or decide to license as the old and familiar way to license your hosts. It's the Windows Server based operating systems. Especially for this very small sized solutions, there's I think in 2020 there came a new Windows Server Data Center license. It's called 8-core Windows Server Data Center license for remote office and branch office scenarios. And with this license, you only have to license at least 8 cores. And in this case, you can save about 15% in comparison to a typical data center license. The next solutions I will talk about are our all-rounder solutions. These are typically 2-unit rack mount systems. Here in these solutions, we have the maximum of flexibility on all available solutions. We can provide as a dual socket Intel, dual socket AMD system starting from 16 cores up to 128 cores, up to 2 terabytes of RAM, up to 200 or 400 gigabyte RDMA networking. You can choose between full flash configurations like full NVMe or full SSDs or a hybrid storage solution. 3-tier storage solutions are always also possible. You can put inside NVMe's, SSDs and hard drives. In this form factor, we can handle almost all of your requirements because of this immense flexibility.
And just to be honest, we are working at the moment also in this form factor to go to PCI 4.0, define and to the new forms and make full flash, full NVMe solutions available there based on AMD at the moment because Intel isn't released. Okay.
Right. Next solutions are our high capacity solutions. These are 4-unit solutions. The technical stuff inside is the same like in the 2-unit solutions or in the all-rounder solutions. We also can provide these solutions as AMD or Intel based, 128 cores, 2 terabytes of RAM, and with high bandwidth RDMA networking. The one big difference is the chassis. It's a chassis with up to 24 3.5-inch hard drive slots. And so with this immense amount of hard drive slots, you can build cluster solutions with hundreds of terabytes or petabytes. To accelerate the really slow spinning hard drives, you can we can use the power of NVMEs for doing the caching part. So the hard drives are cached through NVMEs, so the cluster performance is really, really good. In this case, it's also possible to build 3-tier configurations with NVMEs, SSDs, and hard drives to a great mix out of all worlds of capacity and performance. And in the last slide, there's an overview over all solutions which are at the moment available from Thomas Krenn and SecureGuard. Every of these products was built for an individual use case. The small micro solutions, for examples, are for really small companies, maybe doctors, lawyers, or even associations. All-rounder solutions are typically for almost each of our SMB customers, and the high capacity solutions, of course, are for all who have a huge amount of data. Each solution is flexible to adjust to adjust the hardware to exactly your requirements. If there is no suitable configuration for you online, you can contact us, because we have the ability to build a complete new server system for you. And the best thing is we can fully validate and certify this individual hardware for the usage of Azure Stack HCI.
So you have the possibility to really do a build-to-order Azure Stack HCI validated solution, which totally fits to your needs in a, let's say, running in a list price range below 5,000 euros to up to list prices from multiple 100Ks, and you can choose the solution or the way to do it which best fits for your own business needs.
Right.
Yeah. If
one thing, maybe because we have a few minutes, maybe give a little sneak peek what's coming soon or what's happening next. The last weeks and months, I was working very hard with, in this case, Helmut, to design a few new innovative solutions. In 2021, there will be a complete refresh of all systems from Thomas Krenn, which are at the moment available. I think a few from the SecureGuard solutions also will be updated. And the plan is to bring different product families or product lines online with single socket AMD, dual socket AMD, and dual socket Intel. And within this product lines, there would be, for every product line, there should be available full NVMe and also hybrid storage from 1 unit to 4 unit. This is our sneak peek. We don't have an exact time frame when these solutions will be online, but usually in the first half of this year, I think the most of the configurations will be online.
Yeah. Now, since that's the last session, we still want to thank our sponsors, especially since Armin is here, Thomas Krenn, but also Fortinet. Want to really thank all the attendees on this, and since it's the last session, I will just make the closing notes directly here, but I still want to thank Armin for his session here and for his help in my session, and hope to see you soon again and hear you soon, and stay healthy.
Businesses are rapidly adopting cloud computing, taking advantage of its flexibility and speed. Whether consuming SaaS applications, building cloud-native applications, or migrating existing applications to the cloud, finding a security solution that addresses a diverse set of needs is critical. Fortinet Cloud Security Solutions deliver. Get the confidence you need to deploy any application on any cloud supporting any initiative. Fortinet supports all major cloud providers, ensuring that critical assets are secure and that security is manageable. The Fortinet 3-pillar cloud security strategy provides the same level of security across multiple clouds by natively integrating security into the cloud platform, defining security policies for cloud services, and leveraging cloud services for security, ultimately enabling automation of security services. Fortinet provides the industry's broadest set of cloud security products, enabling you to use the same security in the cloud as you have on premises. By using purpose-built security tools in the cloud, you'll save time by leveraging existing skill sets. By managing security across multiple clouds through a single pane of glass, and by automating the security lifecycle management, you can better leverage existing skill sets and accelerate the confidence to deploy applications anywhere. From consuming cloud applications to building applications in the cloud and migrating IT to the cloud, Fortinet Cloud Security Solutions cover the broadest set of use cases, delivering the flexibility and confidence to use the cloud in a way that best serves your business.
Yeah. As the host of this track, I want to thank you and thank you for being our guests. But I will take the next minutes to just give a short outlook what in Experts Live we want to do in the next months or in this year, so that you can be prepared. So we are really, really eager to make an in-person event as soon as possible, as soon as everything it's allowed and possible here. So we really hope that it can be done in the second quarter of this year, even if it's the end second quarter. So please join us at Experts Live AD. Also the possibility that all of the speakers can be seen live again and not really touched, but anything. There will be recordings from the whole thing. Please watch them. All of the slide decks will be uploaded to GitHub in the next days. You can then get in touch with the speakers. In a way, we appreciate your feedback, so please tell us what you think. Just mail it. It's the easiest way. And again, a great thanks to our great speakers, beginning with the keynote, down to Armin at the end. all of them here again. None of these conferences would be possible if we don't have these great speakers and these technical competent presenters there. And then also thanks to our sponsors again, because yeah, in such events there is still a whole lot amount of organization and of costs which can't be carried out. Experts Live is now an enterprise or a company called Verein in Austria, and we are not aiming for profit, but for sure we don't want to make any loss of it. And also go to Experts Live AT, to the org team. There you also find the way how you can join us. We have a membership fee in a year for 10 euros. So, and perhaps somebody of you is interested to help us with the next event. And now it's time to say goodbye and stay healthy. Bye.
Businesses are rapidly adopting cloud computing, taking advantage of its flexibility and speed. Whether consuming SaaS applications, building cloud-native applications, or migrating existing applications to the cloud, finding a security solution that addresses a diverse set of needs is critical. Fortinet Cloud Security Solutions deliver. Get the confidence you need to deploy any application on any cloud supporting any initiative. Fortinet supports all major cloud providers, ensuring that critical assets are secure and that security is manageable. The Fortinet 3-pillar cloud security strategy provides the same level of security across multiple clouds by natively integrating security into the cloud platform, defining security policies for cloud services, and leveraging cloud services for security, ultimately enabling automation of security services. Fortinet provides the industry's broadest set of cloud security products, enabling you to use the same security in the cloud as you have on premises. By using purpose-built security tools in the cloud, you'll save time by leveraging existing skill sets. By managing security across multiple clouds through a single pane of glass, and by automating the security lifecycle management, you can better leverage existing skill sets and accelerate the confidence to deploy applications anywhere. From consuming cloud applications to building applications in the cloud and migrating IT to the cloud, Fortinet Cloud Security Solutions cover the broadest set of use cases, delivering the flexibility and confidence to use the cloud in a way that best serves your business.